What is going on, ladies and gentlemen? I go by the name of Gio. Welcome to my channel. This is going to be the start of my Kotlin tutorial series. This series is going to be great for beginners getting into Kotlin, wanting to know more about Kotlin, individuals who are trying to refresh their Kotlin skills, or maybe want to learn even more about it, and lastly, the curious who just want to know another language. Maybe they want to pick up, another great language that they can add to the repertoire. So this is going to be a great course for all those type of individuals, and I'm going to try to break it down as easy as possible for every range from beginner to advanced. But just to clarify that this is going to be great for beginners as well. So who will enjoy this course? Well, Java engineers will enjoy this course because it uses the JVM, but we'll talk about that a little bit more later. Engineers interested in learning Kotlin. So like I said, if you're someone who is interested in learning a new language, especially Kotlin, this is going to be a great course for you. Engineers looking to learn how to create a backend service using Kotlin. So Spring Boot is one service that utilizes Kotlin, and I actually have a couple videos on that on my channel already. I'll leave a link somewhere on the screen, but if you want to utilize Kotlin for that, then this is a great course to get an understanding of how Kotlin works and why it's so great. And then there's engineers who are converting from Java to Kotlin. I was actually one of those engineers, so my job was converting from Java to Kotlin, just to help speed up the coding process, and because of some safety benefits of Kotlin. So it was already a process for me to learn, things about Kotlin coming from Java. So if you're an engineer like that who's converting from Java to Kotlin, this is great. Then there are also Android engineers who will use this for Android development. We'll talk about that a little bit more, but I can say about 60% of Android engineers use Kotlin, and that number is increasing. So if you are doing Android engineering, then Kotlin is great to learn. And like I said, last, the curious, someone who just wants to know what Kotlin is about, what is it great for, why it's utilized, what it can be utilized for. This is going to be a great course for that as well. So what is Kotlin and who uses Kotlin? Well, Kotlin is a cross-platform, statically typed, general-purpose, high-level programming language. That's a lot, but essentially, it's a great language that is cross-platform and it's high-level, just like Java. And like I said before, 60% of professional Android developers use Kotlin to help boost their productivity. Their satisfaction in the developer process is also great with Kotlin. It's a very clean code. The syntax is different, which we'll see in the future. And then they have ingrained some code safety features that will help engineers during the process. So like I said before, Kotlin is a cross-platform language, so it has an increasing audience that will continue to grow, with support for front-end development using Kotlin for JavaScript, iOS development using Kotlin native, and even creating desktop graphic user interfaces using Kotlin. So you're doing yourself a favor learning such a powerful language. And like I said before, I learned Kotlin because my company was transitioning from Java to Kotlin, but my company is not the only company that is interested in using Kotlin. You have companies like Google, which I'm not surprised is converting to Kotlin because they did invest money for the creation of the language of Kotlin. You have Amazon, you have Pinterest, you have DoorDash, and so on using Kotlin for their application, whether that's server side or using it for mobile application development for Android. These companies are migrating to Kotlin, and that is a good sign for the market for anyone who's interested in learning Kotlin if a lot of companies are using that language for their projects. So how does Kotlin and Java correlate? Because like I said before, why is it that people are transitioning from Java to Kotlin, and how do they work together? What exactly is that relationship? Well, both languages uses the Java Virtual Machine, JVM for short, but they do differ in terms of like syntax, features, and performance. Kotlin is a new language, so the whole gist of Kotlin is to essentially make things, or to integrate better features that older languages don't have already, right? But like I said, they both leverage the JVM, which in sense just is used by computers to run Java bytecode. So as long as Java or the JVM is receiving the bytecode in the structure that it's expecting, it doesn't necessarily just have to be Java code. It can be anything as long as it's in the bytecode that the JVM expect, which Kotlin does, right? As long as the program compiles with the format that the JVM expected, it will work. So Kotlin produces the Java compatible bytecode that the JVM expects, and that means that the Kotlin compiler is capable of transforming all the wonderful Kotlin features into JVM compatible instructions. So that's why I have this little diagram that shows, okay, Kotlin compiles it into the expected format to the JVM just like Java does, and it can also be decompiled to what Kotlin expects and what Java expects. So as long as you put in the right format, then the JVM can understand it and do its magic. But it just has to be in the proper bytecode, which Kotlin does. So what you will need to get started, well, you need the Java Development Kit, which has the JVM, which, like I said before, we will use to compile our Kotlin code to bytecode that it understands so we can run our application. So you also need an IDE, which I recommend IntelliJ, and this IDE was created by JetBrains, who are also the creator of Kotlin. So the support for Kotlin will already be integrated in IntelliJ, so I recommend that. The Community Edition is free, so you don't need to pay any money for the IDE. I'll leave a description, or I'll leave a link in the description to both of these items that you'll need to download, and yeah, go from there. And once you have those two things downloaded, we can then go directly into the IDE and get started, which I'm going to do right now. All right, ladies and gentlemen, so let's get straight into it. So the first thing I'm going to do is I'm going to open up IntelliJ. Like I said in the previous portion, you can use whatever IDE that you want to use. In this case, I'm using IntelliJ because, like I said, the creators of Kotlin created IntelliJ, so you already know the support is going to be there. So open up the IDE. In this case, I'm using IntelliJ, create a new project, and then let me bring this up. It's going to show a screen something like this. We're going to create a new project. Choose the location that you want to put it in. Choose a name. In this case, I'm going to put Kotlin tutorial as the name. This is the location I'm going to put it in. If you want to create a Git repository, you can. In this case, I am not. The language is going to be Kotlin because that's what this tutorial is all about. And then the build system, I'm going to choose IntelliJ, but there is an option for Maven and Gradle. If you want to download dependencies and stuff like that, Maven and Gradle is perfect for that, but in this case, I'll leave it as IntelliJ. And then you get to choose the JDK that you installed. So like I said, the two things that you will need is the JDK and a IDE. And in this case, I have the JDK 18, so that's the default one that is here. And then after that, everything looks good, and we can create, and it should start creating that that environment that we'll need to start writing some Kotlin code. Alright, so if everything goes well, a screen like this should pop up. You should see a couple of directories, .ideas, some files that IntelliJ needs to run, what it needs to run, and then you have a source folder with a main folder and a test folder, but we'll be working out of this main folder really quickly here, and then there's going to be a Kotlin folder and a resource folder. We can use this Kotlin folder to start placing some files that I'll be using for this tutorial in here. Just to get started, just to show the power of Kotlin and how to get started in Kotlin, let me right click on this Kotlin folder, press new. We're going to create a new Kotlin class / file. I'm going to name this main. Press enter, and it's gonna make a main class, right? And it doesn't have to be a class, it could be a file as well, but in this case I'm going to choose a class. And then within these curly braces we can start writing some Kotlin code, right? And I'm not going to discuss what a class is just yet. Later in this tutorial I'm going to explain what a class is and all that, but like I said, you don't need it to be a class. If you came from Java, this is usually the format, but this is not necessary. And if anything, I'll show you guys that it's not necessary by actually just erasing it, right? But what we're going to do is create an entryway into our Kotlin application, and to do that we're going to have to define a function, right? So a function in Kotlin is defined by using a keyword fun, like fun, right? Hopefully this is all fun by the end of it, but fun is a keyword in Kotlin. It's a keyword that's used to declare a function. A function is just a block of code that is designed to perform a task, and what you got to do is you got to define a name. So in this case, I'm going to call this function main and open up some open and close some parentheses. and then open up curly braces. And these curly braces, anything within these curly braces is going to be code that executes when we run the application. This is the entryway, right? So if we want code to execute when we run our Kotlin application, we have to place it within these curly braces. So the main function is used to execute code. It is starting point, and anything within the curly braces will be executed. And usually the first thing that we do when we create a new application, when we're learning a new language, is we say hello world, right? We want to see that we're able to output some text, and to output some text in Kotlin, we'll use println, right? And then you open up some parentheses, and then within you define what you want to output. I want to output some text, so to do that, I got to open up some quotes, and that's going to define that it's going to be a string. But in this case, you can see that println takes many different types, and we're going to go over types later in this tutorial as well. Just give me some time. I want to break it down as easy as possible, especially for beginners. But you can see that there is many different types of messages that you can place within this println. But in this case, I just want to say hello world, right? That's the usual go-to. And if anything, I'll put an exclamation point just to make it a little bit more fancy, right? And to run this, all you got to do is, click this green play button, right? And then run this main KT file. And after finish building, right? There's a lot of things running right now, so it's a little bit slower on my end. But it's going to start compiling it, putting it in a language that the JVM understand, and then it's going to output what we expect. So we can see that it's created this out folder right here, and boom, in this terminal we see that it is printing out what we placed inside of this println function, right? It's printing out hello world, and that is what we expect. So now we know, right? If we want to have an entryway into our application, we create a function called main, and because main is a reserved word that Kotlin uses to know that it's the entryway. So now we know, right? So to have an entryway into Kotlin, we create a function, and we use a keyword of fun to create a function, and we have to use a keyword of main because that's a reserved word to let Kotlin know that this is going to be the main entry point into our application. And we define what we want to run initially by opening up some curly braces and defining what needs to be done. And in this case, we wanted to output some text, so we use println, and this is essentially just taking in a message that we want to output, right? And in this case, we use the string, which is defined by 2 quotation marks, and anything within those quotation marks is a string, and we output that, right? A string is just a series of characters. That's also going to be another thing that I'll talk about later in this tutorial video, but in this case, you can think of it as a series of characters, and those series of characters shows as hello world, and we showed that it actually works. If we press the play button, it outputted hello world, and it exited, right? Because there's nothing after this, right? There's nothing else that needs to be ran after. So that is the initial way to get started in Kotlin. We created a project, we created an entryway, and now we can get started onto the serious business. All right, so let's talk variables in Kotlin, right? So let me just give a quick example on what a variable is, right? Variables are, you could think of it as a container for storing data values. So I have this empty box on the screen. It's an empty cardboard box we're moving, right? There's no item inside of this box. It has no significance. There's nothing in it, right? So this is just an empty box, right? But once we start moving and we start placing our items within it, it contains information. It contains items, right? So on the right, I have, some cans that were in my pantry. It could be a cans of tuna that I have. I have a lot of cans of tuna. So I put it into this box. I write the name on it. I write cans, and I place it in the garage for when the moving truck comes, right? And there's a lot of boxes in the garage, but every one of them has a name, right? To know what exactly each one is, right? But I know it contains items within it. It's sealed. It has a name, right? It's not empty. So when the moving day comes in, I know I'm looking for a box of cans. So I look through the boxes. I check each name. Okay, I see that there's a box of spoons. There's a box of forks. There's a box of rugs. But I'm looking for cans, right? So I look through the stack. I find the box that says cans, and it contains the items that I need. So that's how I think of variables, right? A variable is simply a box with a name, and that signifies a description of the type of information that's within that box, right? So in this case with Kotlin, we can create a variable that has a name. We can say box of tuna, and we can assign it a value of a can, cans of tuna or whatever cans we have. And we know that because of that naming convention of what we named the variable, we know the type of information that's within that variable. So how do we create a variable in Kotlin? There's two types of variables in Kotlin, right? There's a var. Var are variables that, the values can be changed later on in the application if it needs to be. And then there's val, where val is like a constant essentially. It cannot be changed after being assigned. And I just noticed that there's a spelling error on the screen, but just know that it cannot be reassigned after, right? It's constant. So say for instance we have the pi value, right? We know pi is 3.14 and a longer series of numbers, but 3.14 is usually the number that people remember, and that's going to be constant, right? But we know that it's not going to change after that. In a sense of var, like I said, we can have a box of cans, right? It can be tuna cans, it can be herring, it can be other different types of cans, right? That can change later on based on our needs. But we have different ways of assigning variables in Kotlin. One can be constant and one can be changed afterwards, and that is signified by using var for changeable ones and val for constants. And here are some of the general rules for creating variables in Kotlin. The names can contain letters, digits, underscores, dollar signs. You should start the name of a variable with a letter. It could start with a dollar sign and an underscore, but I usually don't do that. I usually start with a letter. The names are case sensitive, so the box with a lowercase t and an uppercase b is different than the box with a capital T and a capital B. Those are two different things. So make sure that you understand that it is case sensitive. Just because they're spelled the same, if they're not the same casing, then it's going to be two different things. Name should start with a lowercase letter. I know usually constants start with capitalized. So say for like I said with pi, you might start with a capital P, but usually names or the names of variables in Kotlin start with a lowercase letter. And it shouldn't contain any white space. It's not even going to consider it a variable. It's going to probably throw an error at you. No white space. Reserved words shouldn't be used as a variable. So we talked about a couple. So var and val is considered a reserved word, meaning Kotlin uses that for other functionality within their code base. So like I said, var is to let them know that it's going to be a changeable variable, and val is a constant. And we also talked about functions, which is to create one we use fun, like fun. So these are words that can be used as names because Kotlin has use cases for them, so they can't be used as a variable name. So let's dive into our IDE and start creating some variables. So we're back in the IDE, and I want to start creating some variables, right? So I'm going to create a var variable, which I want to be changed later on in the application. So I'm going to call this cans, right? Right now I'm going to assign it, and to assign it a value, you got to use equal. So this var of cans is equal to, and I'm going to assign it a value, and I'm going to say that it initially starts as tuna cans, right? Because I'm moving, I got all these tuna cans, and I got to put it somewhere. I can't throw it away. That'll be a waste. So now we have a box with a string called tuna cans, because there's tuna cans inside of this box. And then, and then now we're going to create a val, like a constant, right when we create this variable with a value. Once we assign it a value, it cannot be changed. Remember that. And I'm going to call this pi. You could create a capital P, right? It could be capital, and we can make that equal to 3.14. And right now it's showing us weekly, like we're not using it right now. It's not being used, but now we can start printing it out to see, is it actually storing when I need to? Like if I actually go into the garage and grab these boxes, is it actually equal to what I expect it to be equal to? Let's see. So let's print out cans. And remember, println is just used to output, whatever we place within this parentheses. So in this case, I'm using a variable, which is storing this string of tuna cans, and it should print out whatever cans is storing. And in this case, we're going to use another println, and we're going to place another variable within it called pi, which we have above here, and it should output whatever pi is storing. Look at that. It's telling us a local variable name should start with a lowercase letter. So we're going to do that. It should start with a lowercase letter. So we're going to do that pi. And then, now that that's good to go, and IntelliJ is not angry at me, we're going to run this. You can even press this play button over here, but IntelliJ also has a play button up top. Either or is fine. And like I said, my computer is kind of slow, but right here it says tunicans. We expected that. And below we expected pi to be 3.14 because that's what we have within that variable, or like in my example, I used it as like a box, right? It's storing information within that box. And let's actually, test it, right? You said that, or I said that it can't be changed, right? So if I try to change pi to equal to 6.28, I try to times it by 2, you can see that it gets angry. It's like, okay, this is a val, it cannot be reassigned. Like I said, it's constant, but it does give you the option to change it to a var if you really do need to change it, because var is changeable, but a val isn't. So we're not even going to try to change that. We know pi is 3.14, so we'll leave it at that. But for cans, it's not tuna cans anymore. We got herring cans. It's a struggle out here, but I like herring, so yeah, we have herring cans, and we're gonna print that out to make sure that we got that value of herring cans. We don't have tuna anymore. We have herring cans, and let's print that out. I'm gonna leave the other two up here because I want to just show you guys that is it really changing from the previous value? Let's see. So I'm gonna use this play button right here. Gonna run it, and then boom, you can see that initially it was tuna cans, right? Because we started off with tuna cans, 3.14 as expected. We didn't change pi, so there's no point of printing that out again. But we did change cans to herring cans, and I see that here. So that's just the power of variables. Instead of having to write everything down every single time, right? Like I don't have to write 3.14 every time I have to print something, or whenever I'm using an application, I can simply store it somewhere. And if I needed to do any logic or math or anything like that, I can have it in a variable to be used and store the results. Or I can have a constant that could be used for different things, different logics, right? I don't have to manually have to write everything each time. I can have boxes and go and look what's inside that box and use that for anything that needs to use that variable, right? So that's just the power of variables, and we're going to talk about different types that these variables can store. It gives us a little bit more control on what that variable has within it. Right now it's just assuming like what's this value is. So cans know that this is a string, and pi know that this is a decimal. But we're going to talk more about that later in the tutorial on giving exact types for each variable. But hope you guys found that useful, understood it, and let's keep going. All right, ladies and gentlemen, so let's start talking numbers in Kotlin. So in Kotlin, you have two types of numbers. They are the integers and the floating point numbers. So the integer type includes bytes, short, ints, long, right? And the floating point type represents fractional numbers containing decimals, and that is split between float and double. So for integers, I was saying that there were bytes, there were short, there were int, there was long, and you're probably thinking to yourself, what does that mean? Well, it all comes down to how much each individual one can hold. So a byte can hold from the number -128 to 127. The short can hold -32,768 to 32,767. The integer, you can see, can hold a way bigger number, and the long can hold a substantially big number. So for each individual one, there's a range of numbers that it can hold, and that's what makes it different. So byte is the smallest number and long is the biggest, and they all can store whole numbers. When it comes to ints and when it comes to long, it really depends on whether whether it's going to be really, really big, or whether that it's just going to be big but not over the range of an integer data type. So for long, it is good practice to end each number when using a long with an L, and I'm going to show that in the example after this description. But these are the different type of integers that they have, or different type of data types for integers that they have in Kotlin. Now the second type of numbers in Kotlin is floating type numbers, and it can also be broken down by two data types, which are float and double, right? Float is represented as a decimal as well as double, but the only thing that really makes a difference is the precision, right? So a float can only hold up to 6 or 7 decimal digits, meaning the digits or the values after the the dot, while a double can hold a precision of up to 15 digits. So it's usually safer to go with a double for most calculations because of how far of a precision that it has compared to a float. Meaning it's pretty much double of what a float can hold. So it's usually safer to go with that. But if you don't really care too much about precision, then a float is usually the type to go with. And to signify that it is a float, usually an F is used after the number. So if you want to do 14.34 as a float, you just do 14.34F to signify that you're using a float. And if it's a double, then it's just going to go as a double. And usually by default, if you don't specify the type, it usually goes with the double range. You know, just because it's a safer pick when it comes to precision. But if you want to make sure that you're using a float, then you can specify that by, you know, saying that it's a float and putting an F at the end of the number to signify that it is a float. So these are the two data types that signify floating point types or decimals. Now we're back in IDE, and let me show you guys how you can use these data types. So the first one I want to use is a byte, right? So I'm gonna do var small byte is gonna be the name of the variable. And we talked about variables in the previous video or the previous portion of this video. But I didn't show you guys how you can actually restrict the type for that specific variable. And to do that, all you gotta do is put a colon and specify the data type that you want this variable to hold. So in this case, I want it to hold a byte. So that's what I'm gonna do. I'm gonna put a colon, put what I want this variable to hold, which is a byte. And then now we're good to assign it a value if we want to. So in this case, I'm gonna put it to its limit and I'm gonna make it 127, right? Because we talked about how there's a range of numbers that each of these data types can hold. And in this case, the max amount that a byte can hold is 127. If I try to make it 128, it's gonna be angry at me. It's gonna say, wait, hold up. This integer literal does not conform to the expected type byte. Because byte can't hold 128, it would have to go to the next biggest integer type, which is a short, which a short can hold way more than a byte can. Or even if I try to do -129, right, it's still gonna get angry at me because this is not the amount that a byte can hold. We will have to go to another type, which in this case by default, if it's too big, it's gonna conform to an int. So because the int can hold a way bigger range. But if I put -128, then we're good to go because a byte can hold from -128 to 127. So you just got to know when you're doing your calculations or when you're doing your algorithms that you know how much a variable should hold, and be sure to know that, and even use maybe slightly bigger ones just to make sure that it doesn't go over the range that that data type can hold. So I'll make this 127 and then move on to the next one. So then there is a short, which I'm going to put as kind of short. It's going to be the name of the variable. And put a colon again, and I'm going to make this a short. Remember, that can hold from -32,768 to 32,767. And it's the same concept. If I try to make it way bigger than it's supposed to be, then it's going to get angry at me. But if I put it in its range, then it should be good to go. And then there is the int. So this int. And I'm going to make this an int. And honestly, I can put a really big number. And I'm going to try to do that. Try to put it at its max. And this can be very confusing to look at. And the cool thing about Kotlin is you could put underscores to help separate it, to make it easier on the eyes, and it will understand it. So usually where there's supposed to be commas, right, you can put these underscores to signify that it's a comma that is separated by that, to make it easier on the eyes. So this would actually work. As you can see, it's not angry at us. If we try to put a comma, obviously it's going to be like, what is that? But an underscore works to help signify a comma, just to make it easier on the eyes to see that this is a big number, right? This is 2 billion, I believe. So yeah, this is the max number that a int can hold. If I try to make it bigger than that, it's gonna get mad. But yeah, this is the max number an int can hold. And then the last but not least for the integer type is the long. So is long, and make that type a long. And honestly, I'm not even gonna try to type out the whole long number, but I am gonna make it this number +1, right? Because integer can't hold it, but a long can. And I'm gonna make that 8, and you can see that it's not angry. And I usually try to use an L for convention, just to let let myself know and let Kotlin know that this is a long number, right? So you can put an L at the end to signify that this is a long, and we should be good to go. And even if we were to remove the long, right, it now sees that, first of all, wait, this is way too big for an int, but now I can, I can infer, right, because now that there's no type, Kotlin infers that this is going to be a long because this is way too big for an int, and to help signify that it's a long, it lets me know that by putting this L at the end. So that's a good thing about Kotlin, is that you don't even have to think; it thinks for you in cases like that. If you don't specify the type that you want, you can see that, oh well, this number is pretty big. Let me infer it to that type, right? So in this case, it can't fit at an int, so it's going to infer that it's a long. But in this case, I want it to to hold a long explicitly, so I'm going to put long. And then there is the floating point types, and I misspelled that. And this is going to be for floats, and this is going to be for int. So I'm going to call this isFloat, and I am going to make that a float type. Forgot to put the colon. And then I'm going to make this 13.343. And to signify that this is a float, right, I'm going to put F. Because if you don't, it's going to get angry. It's like, wait, this is a float, but you didn't put F. So, yeah, I put F. And then for double, right, I am going to make this a way bigger number with way more precision. I'm still going to make it 13, but I'm going to make it, actually, no, I'm trying to make it bigger, right? So let's make it 353, 343. Just make it really big. And this is going to be way more than what a float can handle, because if I try to make it something similar to that, right, if I try to make it bigger, it's going to be like, hold up, wait a minute. I can't hold that. It's way beyond my precision. But I can replace it with as far as it can go, which is going to kind of cut off at that 4, right? It's going to take out the last 2, because it can only really hold up to 6 or 7 when it comes to precision. So you're going to have to take out the last 2. So if you need calculations, if you know that you need to make it as precise as possible, if you're doing some math, then you can see that double is in your favor, right, compared to a float, because it is restricted on that end. But if you know that you only need a precision up to 6, then you should be good to go with floats. But make sure you know that. Usually I just use double, and usually when you don't specify a type, Kotlin automatically goes with a double. But if you want to save some space, right, float can be used, but just keep that in mind. So these are the data types of numbers in Kotlin, right? This is going to be the integer types, which has byte, short, int, long, and then you have the floating point types, which is float and double. The only difference between these two is the precision, and the only difference between the integer types is the fact of how big you want the number to be. If you know that it's going to be relatively small, you can use a byte or a short. But if you know it's going to get bigger, and you know it's going to be really big, then you can use an int or long. So hope you guys found that very helpful. And the next thing we're going to go over are arithmetic operators, because now that we have numbers and we want to do some calculation with those numbers, and we want to hold that result into a variable. So we're going to do that in the next portion of this video. So let's get straight into it. We talked about numbers in the previous video, right? But what good are numbers if you can't do calculation with it? So in this portion of the video, we're going to talk about arithmetic operators. And the arithmetic operators that Kotlin has are addition, as you can see in this table, subtraction, multiplication, division, and there's the modulus operator, which is really good on finding out the remainder of a number. So we're going to go over this in the code and show you guys how to use these operators for whenever you guys need to use some math or do some math, or if you're doing some algorithms, or you can get the results from these operators. So let's just dive into the code. So now we're back in the IDE, and now I'm going to go through the arithmetic operators one by one just to show you guys how to use them. And luckily I didn't delete any of the variables, so I'm going to reuse some of these variables that's storing some of these values to do some math. So let's just do a println, and I'm going to do a println for each one, and let me put some comments to specify what I'm doing. So we're going to start with addition, and then I'm going to do a println, and I'm going to take small byte and I'm going to add that with small byte, and 127 is the value of small byte. So if I do 127 plus 127, that should be 254. So I'll put a comment to the side of what I expect, and then go on to the next one. Obviously, once I start using the bigger numbers, we're just going to let math do its thing. But in this case, I know that 127 plus 127 is 254. And then for the second one, I want to do subtraction. And just to show you guys, the addition is just simply a plus sign, right? It's just like how you learned in school. To add, you just use a plus. And then subtraction is going to also be the same. It's just going to be a minus, right? And I'm going to also do a println, and I'm going to do small byte minus small byte, and I expect that to be 0. Let's move on to multiplication. All right, so we're just going to multiply really quick. We're going to do println, and then we're going to do, let's do a bigger number, right? So let's do kind of short, which is 32,766 right now, and let's times it by small byte. We can do that, right? So that's going to be a way bigger number that I'm not even going to try to do right now, but we'll see that in the end. And then we're going to do, so let's now do division. And really, we know what division is, right? It's just going to be a forward slash for division. And then let's do a println, and this is going to be, let's see, what number can we use in this case? We could just divide something by itself to make it 1, but I'm just going to use some random. So I'm going to use this int, and I'm going to divide it by kind of short. So like I said, it's simply just a forward slash to just, you know, let us know that you know, we're trying to divide in this case. And the last one is modulus. So essentially, when I think of modulus, and let me just write this out. I think that's how you spell modulus. And it's just a percentage. That's how you do modulus. But it's println. We're gonna do println, and then we're gonna do is long modulus, like I said, which is just a percent. This int. And really, when I think of modulus, I like to think of how many times can a value go into another value. So in this case, how many times can this int go into is long? I know that there's a difference of 1, right? So that means this int can go into is long once, but there will be a remainder of 1, right? So however many times that a value can go into a bigger value, if there is a remainder value, right, then it's going to return that value. If there's not, like if it's even, like if this was the same value as long, then the modulus of that will be 0, because you cannot put that value into it multiple times, or there will not even be a remainder at all. So modulus is used a lot when trying to check if a number is even or odd, because you know that if it's even, then the values will be there wouldn't be any remainder after, you know, doing the comparison. But if there is a value, or if there is something being returned, or if there is a remainder, then it's odd, right? So that is modulus, and you just use a percentage sign, and now we can print it out. Now that we use all the operators, we can run it, press the play button, and this might take a minute because for some reason it builds very slow. I have a lot of things open on my computer, I'm not gonna lie. So let's give it a few, and then boom, I got the results as expected. We got 254 for addition, we got 0 for subtraction, we got a big number which I didn't really calculate, but it's kind of short, times small byte, which I expected a pretty big value. It is in the 4 million range. And then we got the division of this int and kind of short. So this int being 2 billion divided by kind of short, which is 32,766, which ended up returning 65,540. And then the last one was the modulus, which I described, right? So the remainder of how many times this int can go into is long is 1, because, you know, there was only a difference between 1, so this int can only go into is long once, right? If I try to put, you know, multiple of this int inside of is long, it wouldn't be possible. It'll be going over. But since I can put it in at least once and there's a remainder of 1, then the modulus return 1. So that is all of the arithmetic operators in Kotlin that you can use to do some math. Hopefully you guys found that helpful. And in the next video, we'll be going over assignment operators, which will be useful. So let's get going. All right, so now we can start talking about assignment operators. And we've been assigning values to variables this whole time since we've been using variables in this series. But there are other assignment operators that we can use to give a variable a value. So we just went over arithmetic operators, and we can combine that with assignment to combine it and to make it its own assignment operator. So here is a table of all the assignment operators that you can use, right, in conjunction with the regular assignment operator, right, which is just the equal sign, right? So you can do, a plus equal to do an equivalent of a equal, in this case, a equal a plus b. You can do a subtraction, which in this case, if you put a subtraction operator with the equal assignment operator, then it will be, a minus b, and you assign it to the variable of a. So you assign essentially, after doing the math between the two, you would just assign the result to the variable on the left. So we'll go over this in the IDE. We'll go over them step by step so you can see the math in action. All right, so we're back in the IDE, and I'm going to create a couple of variables so we can do all of the assignment operators. So I'm going to create one variable called a, and I'm going to make that equal to 10. And I'm going to create another one called b. I'm going to make that equal to 5. And let me just fix that. Oh, actually, just boom, that's fixed. And then I'm going to make another one called result, and I'm going to make that equal to 0 because all of the results will be going into here. So I'm going to do result plus equal, and I'm going to make that plus equal to a, right? So now it's going to be result of 0 plus equal to a. So this is going to take the value of a and then assign the value or the result of the values to result. So in this case, 0 is equal to, or result is equal to 0 and a is equal to 10. So I'm going to add result and a together, and then I'm going to assign that to the result. So in this case, result is equal to 0, but now it should equal to 10. And I'm going to do a print along the way so you can see the change. Result. And I'm just going to copy that for future reference, save me some time. And then the next one is going to be result, and I'm going to make that minus equal in this case, and then that's going to subtract it, and then I'm going to do that with b, which in this case is 5. So if I do, result minus equal 5, in the previous case it was now equal to 10, so in this case it's now equal to 5, and then I'm going to print that out. Then now I'm going to do result, and I'm going to do a multiply equal. So if my fingers work, but yeah, result multiply equal, and then I'm going to use a in this case, and then that should do as expected. It should multiply, then assign the value to result. In the previous case it was 5, but now 5 times 10, because a is 10, should be equal to 50, and we're just going to print that out. Well, now it's time to do division, so let me bring that down. And then if I do result / equal, that should do a division, and I'm going to divide it by b, and if I do that, then it should bring the value back to 10, because 50 divided by 5 is 10. And then I'll print that, and then finally we're back at 10. And then the final operator, assignment operator that I can do is results, and I'm going to do modulus, so percent equal, and I want it to go back to the initial result, so I'm going to do a, right? How many times can a go into 10, or the result in this case, because result is equal to 10 from the above step, a can go into result once, right? So that means after doing that there will be no remainder, so then this should be equal to 0. So let me do that. That should be equal to 0, and then print that out. So I did the addition, I did subtraction, did multiply, did division, and then did modulus to round it all off. Started off at 0 initially because the result was 0. Then I made it to 10, and then when we got to the end, we went full circle back to 0. So let's run this really quick and see if my assumptions were correct. Boom. Seemed like I was correct. So 10, 5, 50, 10, and then back to 0. So these are some things that you can use. You can use assignment operators. You don't have to just write out the whole convoluted results and then do result plus a, and then obviously you got to sign it, right? Equal. That'll be too much work. So you could do all of this, but then it's going to tell you maybe you should probably do with the assignment operator, right? Do the plus equal. That'd be a lot quicker. So hope you guys found that helpful. I think, you know, this is something that you can use, you know, throughout your coding journey. I used it multiple times. You know, it just makes it easy. It's easier to just get some lines going. So hope you find that useful. And now we're on to Booleans. Well, honestly, I think this is probably going to be the easiest video that I make, but we're going to go over Booleans, right? Boolean it's a data type that can only hold two values, true or false. So that is what a Boolean is, and we're going to show what exactly or how exactly to imply a Boolean. So we're going to create a val. All right, we're going to use a val to create a variable, and I'm just going to call it is true, right? And we're going to let Kotlin know that this is going to be a Boolean data type, and we're going to assign that to true, right? That's it, right? And then we're going to make a second one and a second variable, and we're going to call that is false, and we're going to also make that a Boolean data type, and we're going to make that equal to false. All right, cool. That's it, right? There's only two things that a Boolean can be. It can be true and false, right? Nothing else. It can't be 0, right? It'll get angry. It can't be 10.1. Nope, it'll get angry. It can only be true or false. So really, that's really it about Booleans. I mean, we can print it out to show that, right? It's true. Oops, missed that. It's true. And we can print out is false. But really, that's it. But Booleans become very important later on in this series because we use it for a lot of you know, comparisons and, you know, making sure whether something is true or false, or whether our logic is correct, right? Because in everyday life, using the word true and false is very awesome. It's a statement that you're doing true or is it false. Like, we use that very often throughout the series, and you can see that it's printing out true or false, or true and false. But when we talk about things like logical operators, while loops, for loops, you know, whether something is true is going to actually check, right? Booleans are very important. So it may seem easy now, but, you know, all a Boolean is doing is holding whether a value is true or false. And we're going to use it a lot later on. But, you know, now you know what a Boolean is. And speaking of Booleans, we're going to go straight into logical operators. And we use these operators to compare you know, whether something is true or false. So we have three of them. We have or, and not, right? So the or operator checks whether if either of the expressions is true. So let's say for instance we have A and B. If A is true and B is false, then the whole thing is true because either or has to be true, right? If both of them are false, then well, they're all false, right? But if either or is true, then, you know, it's true. The expression is true. Then we have ands. Well, with ands, it's true if all the expressions are true. So A and B has to be true. If A is false and B is true, well, they're both not true. So that means it's false, right? So that's the distinction that we have to think about. Or, like, just say it out loud, right? If A or B is true, then it's true. But if A and B is, you know, if both of them are not true, then it's going to be false, right? And if they're false, then they're just false. Now, the not, or the exclamation point, defines a not. It's like a Uno reverse. If you ever played Uno, or just think about the reverse, right? Is not just returns the reverse portion of it. So if it's true, if you put a not in front of it, then it is false, right? But if you put a not in front of a false, then it is true. It just reverses the Boolean. So we're going to see this in action. It's going to make more sense when you actually see it. So we are back to the ID, and I'm going to bring back those very useful variables. So is true, and I'm going to make that equal to true. I know Kotlin's going to be smart enough to imply that this is a Boolean, and I'm going to make that is false, and I'm going to make that equal to false. And we all know that both of these are Booleans. You know, one is holding true, one is holding false. But now we're going to use another println. Printlns are becoming so useful, but we're going to do is true to signify a logical or. So let me just put that as a comment. Logical or. Remember that essentially two pipes. All right. And is true or is false. Remember, the rule of a logical or, let me put that, okay, logical or, is that one of these have to be true to return true. Now, if they're both false, then it's just false. But if one of them are true, then we're good to go. And then the second one is a logical AND, right? And we do that, and that is to AND. And then what we're gonna do is println, and then is true, and we're gonna do the same logic, right? We're gonna do the AND, but I'm gonna make it is false on the other side, right? Remember the rule of AND or logical AND is that both of them have to be true, but if one of them is false, then it's just all false. Or if both of them are false, then it's just false. And then there is the not, and then that's just an exclamation point. And then we're gonna do println, and we're gonna do not is true. Remember, anything that this is in front of, it just returns the reverse of. So is true, I mean, the name is kind of confusing, but is not is true. It's not true. So it's gonna return false. So let's run that. Let's see if my sayings are the truth. Boom, right? As expected. So the first one is true because, you know, one of them was true. Both of them doesn't have to be true. If both of them were true, it still would be true. That's great. But at least one of them just has to be true. Either or has to be true. And then the second one, return false, right? And they're both, you know, not true, right? This one has to be true, and the second one has to be true, right? If one of them is true and one of them is false, then it's going to return false. And is true or not is true is going to return false because not just returns the reverse. Now, if I do is true in this case, right, and I do is false here, right? I make both of them false. I make both of these true, and I'm just going to do is false here just to, you know, change it a little bit. And I run it again. You will see that now it is false because, like I said, one of them has to be true, but if they're both false, then it's just going to be false. But in this case, the logical AND is returning true because they're both true. And now with the not, it's just reversing a false. So now it is true. So hopefully that's useful for you. We're going to be using a lot of this, especially for, you know, future portions of the video. Like, this is going to be useful for conditionals. So just keep this in mind. These do become very useful in algorithms and, you know, and in logical logic that we're going to do for our code. But these are just the initial beginnings that you have to learn before we get to that point. So hopefully you find that useful. All right, so while we're still on the subject of Booleans and, you know, returning true or false, or whether something is true or false, we can get into comparison and equality operators, right? So just looking at the table, you can see that we have many different comparison and equality operators, right? And I put the operator on the left, I put the name of it, and I put the example of what exactly it entails. So the first one is equal to, right? We'll check whether one value is equal to the other value. Now, if it is equal, then it's going to return true. If it is not equal to, it's going to return false. So say, for instance, in this case of x and y, if x is 5 and is trying to do an equal to operator to compare it with y, if y is 5, then it is true, right? If x and y is 5, they're both equal, so it's going to return true. But if x is not the same value as y, then it's not equal, so it's going to return false. So that's essentially what these operators are doing. It's just to compare on whether something is true or not. So the second operator we have is not equal, right? So we have x is not equal to y. So if x is not equal to y, then it's okay. That means that the operator is working as expected. So if 5 is set for x and 6 is set for y, right? That means they're not equal to each other. That means this operator will return true because they're not equal to each other. But if they are equal to each other, and we're checking that they're not equal to each other, then it's going to return false. So if x is 5 and y is 5, then they're equal to each other. That means that this will be false because we're supposed to be checking that they're not equal to each other. And this may sound confusing here, so I'm going to show an example in the IDE, but just see how useful this is, right? See how useful Booleans are in checking on values and how they compare to each other. It's very useful. And the lower operators, such as greater than, less than, greater than or equal to, less than or equal to, if you took some math classes, these are the same. So you can check whether one value is greater to each other, greater to another value, and that would turn true or false. Less than a value, greater than or equal to a value, and less than or equal to a value. And these will all return true or false. So let's hop into the IDE and see it in action. So we are back in IntelliJ, and I'm going to create 2 more variables, gonna still use x and y, and I'm gonna make x equal to 5, and I'm gonna make y equal to 10. If you've been paying attention, for some reason I just like those numbers. 7 too, but we're gonna do a couple of print and lens, and we're gonna use some of the operators and see them in action. So the first one is going to be equal to, and we're going to do x is equal to y. So essentially what this is saying is x equal to y? If it is, then we're going to return true. But if it's not, then we're going to return false, because they're just not equal to each other, right? That will be false. And then the second one will be not equal to. We're checking whether it is not equal to each other, right? If they're not equal to each other, then great. They're not equal to each other. That means we're going to return true. But if it is equal to each other, then that means it's going to return false, because we're trying to check whether it's not equal to each other. So let me write what I expect it to be on the side. So I expect this to be false, because they're not equal to each other. But in this case, for x, I expect it to not equal to, and to compare if they're equal to each other, right, it's 2 equals. But to compare that is not equal to, and remember we learned not in the previous portion of the video, right? If we use not, it's just the inverse or the reverse of it. So we're checking if it's not equal to y, and if it's not equal to, which in this case it isn't, right, x is equal to 5 and y is equal to 10, then this should return true, right? Then the next one will be greater than, right? We're trying to check whether a value is greater than another value. So if it is greater than, then we'll return true. But if the value on the left is less than the value on the right, then it's false. So in this case, we're going to be doing print and len, and in school, actually we're going to use x on the left side, right? And we call it gator mouth, right? If the gator is approaching to the left, then it's greater than. But if it's approaching to the right, right, that means less than. So hopefully you learned that in school, but hopefully that helps. So then x, if it's greater than y, then it's going to be true. But if x is less than y, then, well, it's going to be false. And in this case, x is less than y, so it's going to return false because it's not greater than. Then we have less than. And we're going to do another print len. And that is going to be, x is less than alligator mouth to the right. And then x is less than y. In this case, this will return true because x is less than y. And then we're going to, do the same thing. And I'm just going to copy these over just to save time, yours and mine. Greater than or equal to. So, and I'm going to erase this for now. This too. If x is greater than or equal to y, then it will return true. But if it's not greater than or equal to, meaning that if x is equal to y in this case, then it's going to return as true. But if it's not, then it's also still going to return false. So to signify that, we're going to have to do the greater than sign, but then put an equal at the end as well. To signify that it's checking for whether it's greater than or if it's equal to. And in this case, since x is neither greater than or equal to y, then it's still going to return false. And then for here, it's the same thing. It's going to check whether it's less than or equal to y. And to signify that, then you have to put the less than sign and put an equal to, or equal sign, to signify that it's less than or equal to. And in this case, it's still going to be true because x is less than y. So now we have all of them in succession, and now we can run it. And we'll see if I'm right. So boom, let's scroll through this and see. So we have the first one being false, which I expected. X is not equal to y, so there's no way that was going to work. X is not equal to y, which is true. It isn't equal to each other. Then the third one is that x is greater than y. That is false because x is not greater than y. X is less than y, so it is going to return true as expected. And then greater than or equal to, x is neither greater than or equal to y, so it's going to return false as expected. And then x is less than y, but we're also checking if it's less than or equal to. It is less than y in this case, so it's not equal to y, but it is less than, so it's going to return true. So that is the power of comparison and equality. Now we could change it up, and we could set these equal to each other. So there is a couple that this will pass, so I could reverse it, right? This will be true, right? This would be false. 10 would not be greater than y, right? It'd still be false because they're equal to each other, but neither of each other is greater than each other. And this will also be false because neither are less than each other. They're both equal. But once we get to greater than or equal to, yes, they're not greater than, yes, they're not less than, but they are equal to. So these will also be true. So the initial one will be true because we're checking for equality. They are equal to each other, so essentially this will be false because they're not equal to each other, and they're the same, so they're not greater than nor less than. But once you put in the equal to, then they are. So let's run that again, and then we can check whether I'm telling the truth. So as you can see, the first one returns true as expected, the second one returns false, third one returns false, fourth one also returns false. But then once we start getting to the equality, then we can see that they're both returning true as expected. So that is, like I said, the power of comparison and equality. You'll also be using this later in the course. So just keep in mind, all of this is very important. You just gotta learn them step by step, but they're very useful. All right, ladies and gentlemen, so now let's start talking about characters and strings in Kotlin. We used it a couple times. I printed out hello world. That was, me printing out some text. That's essentially what a string is. But let's break it down a little bit more. So strings are a sequence of characters. So like I said, for example, let me write it out right here. I did println, which, remember, println was to output text, and I opened up some quotes and I did hello world with a exclamation point, right? And if I can spell world properly, but hello world with exclamation point. And all a string is a sequence of characters. And as you can see here, it is a sequence of characters, right? You have H, you have E, you have two L's, O, etc., etc. It's just a combination of a sequence of characters. So that's really all a string is in Kotlin. Now, we can also use this in variables, right? We don't have to just write it in directly into the println, right? We can store a string if we want to, and to do that, we can do right here. We could do var prompt, right? Because this is a prompt, and we can specify that this is going to be a string. So we can say, okay, I want to put a string in this variable of prompt, and I'm going to put hello world there. And to signify that, I do what I usually do, and I put double quotes, and then I will take this println and I'll put it below it, and I'll print out that variable that's holding the string. Really, it's the same message, but now it's being held in a variable. And if I run that, you now see the same message, hello world, like we did before. So that is how you create a string variable. That is what a string is in Kotlin. Now, because I said it is a sequence of characters, right? What if we want to access a character or a specific character within the sequence, right? We could do that, right? So if we want, say for instance, we want to get E, right? You could think of this, like I said, as a row of characters. You have H initially, E, L, L, O, etc., right? And each of them have their own placement in that sequence. So usually we start when we start counting, we start at 1. But in this case, we will start at 0, right? This is going to be the zeros. H is in the 0 place, E is in the 1 place, L is in the 2 place, and you just keep increasing from there. So if we want to get a specific character in this sequence, we will just have to explain, or we would just have to ask for a specific character by using the number of its placement. So say for instance for E, I want E, I have to, and let me just print this out so it can make more sense, but I'll take the prompt and I will open up some brackets and I'll place the number of where that character is. So in this case, I want E, so I know that H is at the first place, which is, just subtracted by 1 for it to make sense, but it's first, so 1 minus 1 is 0, so H is 0, and then E is in the second place, subtracted by 1, E is really in the first place. So if you put 1, you know that you're trying to get E. Right? If I put it another println, right, and I do prompt, and I am trying to get O, right, 0, 1, 2, 3, 4. We know that 0 is in the 4th place if we start from 0. Remember, because I said everything in this case starts with 0, so you start from 0 and you increase by 1. So 0, 1, 2, 3, and then now is 4. So open up some brackets and use the number 4, and I expect to get 0 here. And if we run this, you truly do see that it is a sequence of characters, right? We get E, right? We get the full, first one, we get the full string, but then we get the individual characters by asking for it, right? We're accessing that value by asking for the specific character at that index, right? We call this the index value. So there's E and then there's O, right? So if you want a specific character in a sequence of characters, this is how you ask for it within a string. So strings in Kotlin are immutable, and this means that you cannot change the individual characters of a string. So I know we can access it, and we show that we can access it by specifying the placement in the sequence, but you can't just go in and let me just do this, ask for the first character and try to assign a new value to it. So let's say we wanted it to be Zello or something like that, right? We can't do that, right? It's not gonna let us. We cannot set, or we can't just like build a new string just like that. We would have to reassign it another value. So we could just say prompt now is equal to Zello world, but we can't just change individual characters. So that's just something to keep in mind. If you intend on doing that in the future, it's not possible. And there are ways to specify, like, say for instance you don't want a sequence of characters, you just want one character. There is the char type, so we could just do that right here. So say for instance we create a val, right, and we say that this is 1, right, and we specify that this is a char because a char is a single character. We can do that, and you just make that equal to, and you have to use single quotes, right? When you're specifying a char, use single quotes, and just place a 1 inside of it. So you're specifying that this variable is 1, it's a char, and it will hold the number 1 as a single character value. So this is possible, and we can print that out as well. I like printing things out just to check that I am telling the truth. And let me just print out this second prompt right here. I'll copy this and bring that down just to confirm that this is being reassigned a new value. And let's print that out. So as you can see, we got the initial hello world. We accessed individual characters within the sequence. We got E and 0, and then we reassigned the value of prompt to Zello world, and it worked as expected. But remember, we can't just ask to change individual characters within the string. It's not going to let you, but you could reassign the whole string value. And then we talked about the character type. We can specify that we want a char by just letting Kotlin know that we want a char, and we will place a single quote with the actual individual character that we want to place within that variable, and we printed it out. And in this case, we said that this variable is going to be holding the character 1, which we confirm that is true. So hope you found that useful. Another thing that I wanted to talk about is special characters. There are a series of special characters that we can use. I am going to go over a couple. So the first one is, and let me just print this out. And if I open up some special, and honestly, I'm going to do a little bit of writing here. So I'm going to actually open up some double quotes. And I'm going to put, this is inserting a tab. And right before this, right, I'm going to actually put the special character. So one of the special characters is, a way of signifying special tasks that, that combination of characters does. So if I do a \t, this is signifying that I want to do, or I want to insert a tab, just as the prompt says, this is inserting a tab. \t signifies that, okay, I want to insert a tab at this location. So what I expect for this to be doing is to insert a tab right before it start actually writing out these characters. So that's one of them. So this, let me put a comma here, inserts a tab. The next one is going to be inserting a backspace. So backspace just means that it's going to delete by one character. So it's going to go back and delete one. And let me do a print line here, and I'm going to show you that. So let's just use a simple this, right? And if I do the \b, that just means that I want to do a backspace. So I expect this to be the without the s by the end of this. So this is a special character for backspace. So this inserts a backspace. And there's a series of these, right? And then there's another one, println. And as we know that println outputs, outputs some text, or whatever you place inside of it. It can also be numbers, etc. But it outputs it, and then it puts your, I guess it puts the cursor on a new line. Essentially, it makes a new line after it outputs it. So there is a special character for new lines, and let me show you that. This is on a new line, and then for that to take place, you just do \n, and that signifies that you want to place a new line after this, right? So automatically println is going to put a new line after this, but then now you're going to add another additional new line because we use the special character of \n, right? So this will insert a new line. And then let's do, say for instance, right, we're writing these texts, right, and you want to wrap around a single quote around the word. So like, say for instance, you want like this is, and then you want to signify, okay, I want some single quotes around this new, right? This is put some emphasis on the word, right? Right now you can't really do that, but say for instance, or really you want to put double quotes. Sorry, that was a mistake right there. If you want to put double quotes, right, it won't let you do that because it's gonna get confused. It's gonna be like, wait, this is a new addition, right? Like this, is it two separate double quotes that you're trying to do, or is it just, it's gonna be confused. So to help mitigate that, there is a way of using special characters for that. So if I do println, and I'm gonna open up some double quotes again, and using double quotes, and I want to put some emphasis on double using an additional double quote, all I gotta do is do a \, put the double quote, and then do another \, and then put the double quote. So this will now let the compiler know that, okay, I want to wrap this double around a double quotes, but it shouldn't affect the double quotes that's wrapped around the whole sequence. And it's the same thing for inserting like a \, or something like that, right? You could do the same thing. So you could do println, and then using a \, and right here, for some reason you want to insert the \ between back, right? You could do that. You could just do two backslashes, and that will insert a \ just as it normally would. And another one, and this will be the last one that I show, but there are a series of special characters, and I'll place it in the description below of different special characters that Kotlin support. But you can do the same thing with a $. So say for instance you want to put a $, or you want to insert a $, you can just do that, and that will insert the $, for you. Because $, is used for string templating, which I'll show you guys right after this, but $, is used for other things. So if you want to specify that you want to actually output this in a string setting, then you can use the \ with the $. And we can run this really quick. Let me comment out all of this so it doesn't get confusing on the terminal, and we can see that this is going to be used in action. So let's see. So boom. All right, so we're going to go straight from the top. So right here, this special character of \t inserts a tab, and as you can see, there is definitely a space that we didn't put manually. It was just, we placed a special character and it did it for us. And then there was the backspace, which will do a backspace, right? It's like if you put backspace, like if you click the key on your keyboard, or if you press delete if you're using a Mac, it will delete it by one space going back, and as you can see, it's just this instead of this, like originally. And then there is the new line, right? Println already puts our output onto a new line after, but because we're using println and another special character for a new line, we see a space in between. So that's cool. And say for instance you want to put some emphasis on a word and you want to use double quotes and you're already using a double quotes, you would have to use a backslash quote with an additional backslash quote to do that, because you don't want Kotlin to get confused on whether this is a new entry of, or if you're trying to separate strings, it doesn't know the difference. So it's better to use a backslash with a quote so it knows, okay, you're trying to insert this into the string, and that's what it does, right? It adds some emphasis to the double. And same thing with the backspace. If you want to insert that into your string, you just put a backspace or backslash with an additional backslash, and it will insert that into the string. And then last but not least, if you want to use a $ as well, remember I said that $ are used for string templating, which we're going to be going over right after this. But if you want to insert it into your string, then you do a backslash with the $, and it will insert it right into your string. So these are some special characters that can be used in Kotlin, and I will put a link in the description to more special characters that you can use in Kotlin. But these are the ones that I primarily use, or that I use the most. So I thought it would be very useful for you. So hopefully you find that useful. And on to string templating. Alright, so as promised, it's time to talk about string templating. And this should be relatively short, but it is very useful. String templates allow you to, or allow string to contain template expressions. So we can use the $ to put expressions into a string. So let's see that in action. So I created a variable called the world, and we're going to create another variable, and we're going to inject the world into that separate string using template expressions. So let's do that. So I'm going to create another variable called message, and I'm going to set that equal to a string. So it's going to be if I ruled the, and shout out to an artist called Nas. He made a great song called this, or called If I Ruled the World. And I got to inject world into it. Like, yeah, I can put it in manually, but what if I have a separate variable, right? And that's a variable that I want to change in the future, but I don't know when, right? I want to just inject it into this message, and then when that changes, this will also change as well. Well, I can do that with template expressions, right? So I can use a $, right? And I can put the variable that I'm trying to inject into it. So the world is what I'm trying to inject. So now this will, whenever it runs, it will see that, okay, I have this string of if I ruled the, and then it's going to inject this variable right into it. So right now, this variable of the world is holding the world with exclamation point. So let's see if it's actually going to inject it. So let's print out the message. And then let's run it really quick. So look at that. It says if I ruled the world. Imagine that. So like I said, you can change this to whatever you want. So if you want to change this in the future to the planet, you can do that. You can run it again, and boom, now it says if I rule the planet. Now we don't have to manually go in and do it. If we have a variable that's maybe it's somewhere far away in our application, or maybe it's above an application, we don't have to actually go in and change the message. All we got to do is change the specific word that we're trying to change. It really depends on your use case, but there is usefulness to this, because now we can have strings that contain template expressions just like this. So hopefully you find that useful. If you have any questions, leave it down below. And now we'll continue on to urinary prefix and increments and decrement operators. Alright, so let's quickly go over the urinary prefix and increment and decrement operators. So we have the urinary plus, we have the urinary minus, which simply just inverts the sign, and we have the not, which we went over in the Boolean portion of the video, but in this case it's simply the same, it inverts the value. And then we have the increment, which increases the value by 1. All we got to do is use the double plus in front of the variable, or even after, and it increments the value by 1. And we can also decrement it using the same kind of logic, but in this case it will be minus to decrease the value by 1. So these are the operators that are available for urinary prefix and increment and decrement operators, and let's see some of them in action in the IDE. So I'm going to create a couple of variables so that we can actually get an understanding of what is actually being done. So I'm going to create a variable called x, and I'm going to make that equal to 1. I'm going to have another variable of is true, and I'm going to make that equal to true. I'm going to have another variable called y, I'm gonna also give it a value of 2. So I'm gonna create another variable called result, and I'm gonna make that hold an int, and then there's gonna be a Boolean result. It's gonna hold the result of what I'm gonna do with the Boolean, and that's gonna be of type Boolean. So I'm gonna have result hold the unary minus value, right? Because we said that if we use the unary minus, right, it should negate it. So we have a positive 1 that's in the value that's in this variable of x. So if I do minus or the unary minus in front of the x, we'll see that it should print out the negated version of it. So let's print that out, and then we'll move on. Or in this case, we did learn string templating, so let's do that really quick. So negative x equals, and then we're going to insert that result here. The power of string templating, right? Then we have Boolean results, and we're going to make that equal to not is true. If you've been a part of the series so far, you've probably seen this already, but I guess this will be a refresher. So println negation of, oh, forgot to put quotes, negation of is true, and I'm gonna make that equal to, and I put it outside, but you're supposed to put it inside, Boolean results. There it is. And now let's do some increments and decrements. So let's do println. We have y, so let's do that. Let's do plus or increment y, and I'm gonna do y is equal to plus y, and then I'm just gonna inject that. All right, and then we can just decrement it again. So we'll just give it back its original value. And then we should be good to go. So I'm gonna run this really quick, and then we can go over it together and see the results. All right, so cool. So if we go here or go up, we see that, okay, we expected that, right? Originally it was 1, but with the unary minus, it would negate the value. So it started out as positive 1, and it now is equal to a negative 1. And as we went over in the Boolean portion of the video, if you use the exclamation point with a Boolean, it's just going to negate it. So it started off as true, and now it's false. So we got that expected value. Y was 2, but with the increment using the 2 plus, right, that increases the value by 1, and now y was 3, but then we decremented it back, brought it back to its original value by using 2 minuses. That's decrement. So this will be very useful when we start going into looping, and once we go into looping, this will be used a lot. But this is just an introduction to that. But just remember where it came from when we actually do start going over looping, and we'll need it for incrementing it one by one, going step by step. But yeah, this will be useful. So hope you guys find that useful. And on to the next one. All right, so I wanted to dedicate a nice portion. It's not gonna be long, but a little portion to talk about comments. I've been using comments this whole time to describe what is going on, but let me just dive in just for a little bit about what a comment is. So comments are a portion of the program intended for you and your fellow programmers, your team members, to understand the code. They are completely ignored by the compiler, so it's not ran by the compiler. It's just really for you and your team to be able to read and understand what is going on with that line of code, whether it's under or on top of it. But it's just a way of just describing what's going on. So throughout the series, I've been using just the forward slashes, 2 forward slashes, and just writing out what exactly is going on. But this is pretty powerful because it could describe what exactly is intended on being done in the case of like creating a variable, what the variable is being done for, what is pi, and it's a mathematical concept, right? If for people who doesn't understand that, it's a mathematical concept. It's a constant as well, but maybe your team member may not know that. Maybe you need to put a comment to describe that. Comments are very important for these cases because maybe you have an implementation that you understand, but you think that your team members may not know, or maybe you may need it for yourself as a refresher when you come back, because you may be working on a repo and then go work on another project, and then when you come back, you may feel like you need a refresher to understand what's going on. Documentation probably should be used for that as well, but maybe you need like a slight comment to describe what's going on. Comments are very important for that. So I would recommend that when you guys are writing code, that you write comments whenever you can. Don't make it like your repo full of comments. Like, you should always name your variables and your functions, as when we talk about functions later in the series, but you should always name your stuff in an obvious manner so that you don't have to write as much comments, right? That's one of the rules of clean code. But whenever you do need comments, it's important that you write good comments, and that you don't have convoluted comments all over your repo, because it can make it, I guess, dirty if you write too many, right? You don't need paragraphs and paragraphs, but just a nice statement that describes what's going on. So that's one way of writing a comment. You could also create multi-line comments. So say, for instance, you want to write a bigger comment to describe maybe like a module or something like that. You can use a forward slash, use an asterisk, right? One asterisk, and then open it up and close it with another asterisk with a forward slash, and anything between that will be a comment. So this is a multi-line comment, and I can press enter and write on multiple lines, and this will describe the module. So it can be single line using just a simple forward slash, or it can be multi-line using a forward slash asterisk and then closing it off with another asterisk and a forward slash. So this is I usually see multi-line comments when it's describing bigger functions or modules, and then single line comments are usually describing, like, even describe methods, or they can describe variables, but yeah, I usually see multi-line comments for like bigger portions of the application. So like I said, use them properly. Comments shouldn't be a way to substitute a way of writing poorly written code in English. It should be used to help structure what yourself has written, or your teammates may go in and try to understand. It just help make it a little bit readable, and just to give tips on why that approach was taken. So, but it shouldn't replace of structuring how to properly write variable names or function names, etc., right? It should just be used as a helper. So hopefully you find that useful. There's single line comments, there's multi-line comments, but it's how to use comments, like when to use comments. That's the important part about it. And I found that the book Clean Code really described that well. There's a chapter about that, and I'll leave a comment in the description to that book. But just make sure that you use your comments properly. It shouldn't be like a duct tape for very bad written code. It should be just a helper. Alright, so let's get into if statements, right? We learned about logical operators, and I told you guys that it's going to be important for future logic or code that we're going to do, and it's going to be very important in this case, right? So an if statement is just a way that we can specify a block of code to be executed or ran if a specific condition is passed, or if it's true. Now, if it is not true, then the if statement won't function, right? But if it is true, then the code within the if block will run. So let's see that in action. Let's see what I actually mean by that. So just as the name implies, the keyword for an if statement is if, right? And to create or to pass the condition, you would have to place it within these parentheses. And if the condition within those parentheses is true, then it'll execute or run the code within these curly braces, right? So this is the format of an if statement. All we have to do is put a condition within these parentheses to do the check on whether it's true or false. If it is true, then anything within this curly braces will run. Now, there is a fallback in the case that whatever in this parentheses is false. What is executed after that, right? There's a fallback. So if this code doesn't run, well, then we can use the keyword of else, which if none of this is true, then else run this code instead, right? So if this is false, then it's going to fall back to this else piece, right? And it'll execute anything within the curly braces of the else. So that is an if or else statement. Now, there is something between, right? What if we have another condition that we want to check that is different than the one that was placed within the if statement? Well, we have another one called else if, and just as the name implies, it's literally just else if, right? And then we will open up another parentheses and another curly braces, right? So we can essentially create branches on checking different type of conditions, and if none of those conditions work or none of those conditions return true, then we'll fall back to the final branch, which is else, right? This is the fallback, and it is not required, right? It's only if you want to fall back that this is used, or if you just want to use the if itself alone, you can do that as well. But there are different ways you can create branches to check for different conditions if need be. So there's if, there's else if, and there's else. So let's actually do a couple of examples so that we can see how things like logical operators can be used in examples like this, especially in your code as well. So let's say, for instance, we're having a cousins retreat, right? I'll put a comma here, setting up the story. Right, we're having a cousin retreat, and we have 4 cousins, and they're setting up, meeting together, and trying to make sure that everybody is able to go to specific places based on the age of the cousins, right? So we're gonna have 4 cousins. One is gonna be named Adam, and he's 17. Another is going to be Jim, right? And he is 21. Another one's going to be Sammy, and she is 16. And then the final one is Lindsay, and she's the oldest. She is 24. Now, Lindsay is, just got to the airport, and she's trying to figure out, okay, should I get a rental? Should I get an Uber? Or should I just ask for a ride? Should I call Jim for a ride? Well, Lindsay's 24, and the requirement for a rental in the state that she's in is that you have to be 25. So we can do a check, right? We don't know if Lindsay's birthday is coming up soon, or whether it's already happened, but we don't know that she's 24 yet, right? We just have to check in the code itself whether or not she is either 25 or above 25, right? So to do that, we can create an if statement, and I'll open that up. You remember to create an if statement, you'll open up first use the keyword of if, open up parentheses, and then put the condition inside. So now we're going to take the variable of Lindsay, which is holding her age, and we're going to do a check on whether she is greater than or equal to 25, right? So greater than or equal to 25. Well, this is either going to return true or false, right? And in this case, we see that Lindsay is 24, so we kind of expect it not to work, right? She's not older than 25. But if she ever turns 25, well, whenever she gets to the airport, well, we could print out that it is time to get a rental, because she is old enough to get a rental. But at this time she's not. But if she ever is 25 or older, then she can choose to get a rental. Well, in the case that she is not 25, or she's younger than 25, then we'll have another branch that checks, right, if Lindsay is at least greater than 18. Because if she's greater than 18, then she's okay with taking an Uber. So we can print out, well, let's get an Uber, and this will take her to the house that she needs to get to. But say, for instance, and we don't, like I said, we don't know Lindsay's age. We're just going by whatever's in this variable of Lindsay. We need a fallback, right? If she's any other age, right? And in this case, we're checking if she's greater than or equal to 25, if she's at least greater than 18, or greater than or equal to 18. But if she's younger than 18, well, we'll just call Jim. And that is the branching strategy, right? the first one is going to be, okay, let's check the condition that is Lindsay is greater than 25, then we can just, get a rental. If not, as we're going to check out if she's at least greater than 18. If she is, then, we'll get an Uber. And if not, if all that fails, then we'll have a fallback that we'll just call Jim for a ride, because, Jim has a car. We're in his city. He should have a car. He can go pick me up from the airport. So let's run this really quick. Well, as we can see, Lindsay's just going to have to get an Uber because, she has the app. She's greater than 18. We're good to go on that front. Now, on to the next thing, right? Now we have to figure out, okay, all the cousins are at the house. We need to figure out, what can we do? Should we go to a bar? Should we take the chance to go to a bar? Because I don't think everybody is older than 21, right? I don't think the bar is going to let us in if everyone's not over 21, but we can check. And if not, then we can, try to go to a lounge. They probably have to give out a wristband for everybody else, because whoever is younger than 21 has to get a wristband, just like usual protocol. So let me erase this and start creating the branching strategies for that. Well, actually, I'll leave that for those who need to keep the example, but I'll scroll down a bit. So the first one is, we're going to check if, and we can use parentheses within the parentheses to make sure that it checks each condition alone. And then we're going to use some operators, like the logical operators, to compare each individual condition. So the first condition that we're going to check is Jim is greater than or equal to 21. If Jim is greater than or equal to 21, then we can return true, and that means that we're good to go inside of the bar, right? But we have to check for each individual person, right? We have 4 individuals, and we have to make sure that all of them are greater than or equal to 21. So we can use the AND operator, right? Because remember, with AND, everybody or everything has to be true. Like, both sides have to be true for it to return true. If one is false, then it's going to return false, meaning that this if statement is not going to run the code within the curly braces, right? So everybody has to be older than 21. Everybody has to return true for it to run the code within the if statement block. So now let's check if Adam is greater than or equal to 21. And remember, we're going to use parentheses to make sure that it is, doing that check within the parentheses, and then we can do the comparison between the and. So then we're going to do, and remember PEM does in this case, like, remember how parentheses take emphasis before it does anything else. Parentheses in this case is going to make sure that it does the check of whether or not Jim is greater than or equal to 21, or whether or not Adam is greater than or equal to 21 first, and then do the logical operator check on whether or not both of them are true. So we'll do the greater than or equal to 21 case here, and then remember we have 4, so we got to do it for each individual one. So let's do and here, and let's do Sammy. And I forgot the parentheses again. Sammy is greater than or equal to 21, and the final person is Lindsay, and we got to check if she's greater than or equal to 21. And if all of them are greater than or equal to 21, then the bouncer says, well, you can enter the bar. And if I get that within the function, you can enter the bar. And if not, well, we'll do the fallback. We don't even have to check another condition using an else if, is whether you're 21 and older or not. There is no if, and, or but. We'll just do an else for a fallback, and then we'll print out not there yet, because they're just not there yet. They're not old enough yet, or all of them are not old enough yet, so you're just not there yet. And then I want to do the final check. I want to check whether or not at least one of them is 21, because then we can go to a lounge. If one of them is older than 21, then we can go to a lounge, and everybody else will just have to get a wristband, if anything. Because if you are younger than 21 and you're trying to go to the lounge, they'll just give a wristband to whoever is younger than 21. So I'm going to change this text to lounge. I'm just going to save some time. And instead of using a logical and, we're going to use a logical or, because we just care about if one person is 21, right? As long as one person is 21, as long as one of them is true, then we are good to go, right? For the bar, everybody has to be 21, but for the lounge, only one person has to be 21. And if one person is greater than 21, if one of them is true, then the whole condition is going to be true. That's just the rule of a logical or. And if one of them are true, then we can enter the lounge, right? And if none of them are older than 21 or equal to 21, then they're just not there yet and they can't go. So let's run this and see the power of a if and else branch, right? And using logical operators with them. Boom. As you can see, it's still the original of getting an Uber because Lindsay is 24. She's not 25, but the second condition is that she's at least greater than 18, so that's the same, get an Uber. But then you can see that all of them are not 21 yet. So yeah, I believe Jim is equal to 21, Lindsay's equal to 21 or older than 21, but you know, Adam and Sammy is still less than 21, so they're not gonna let you into the bar. You're not there yet. But for the lounge, you can enter the lounge because of the fact that Jim and Lindsay are both greater than or equal to 21, even though Adam and Sammy is less than 21, right? As long as one of these are true, then they're all true, so that means you get into the lounge, right? So that is just the power of if and else if you need another condition to check for. And you can add that with you know, different operators like logical operators, or even if you want to do the equality operator of checking whether it's equal or if it's not equal, right? That will still work in this case as long as the result is going to return true or false. That can be used towards the condition, then it is perfectly fine. So yeah, man, try it out. Try out a different scenario with an if and else, and see where it goes. So hope you guys found that useful. If you have any questions, you can leave it down in the comment section. Let's get on to the next one. All right, so this should be a relatively quick portion of the video, but I just want to describe or explain the difference between a statement and an expression. So an expression consists of variables, operators, you know, things like that evaluate to a single value. It will return a value at the end of, you know, that action. So let's say, for instance, we have, and let's create a variable of score, right? Or let's say result, and we'll make that an int. And let's say we do result is equal to 100 plus 50. This is an expression, right? Because of the fact that we're taking two values, we're doing an action of adding it, and then we're assigning it to a result. This is an expression. Another great example, and to be honest with you, the example that really made me understand it the most was, let's actually do this really quick. So let's do, we already have a result, so let's do for result 2, and we're going to make that equal to 200, right? And then we're going to have I'm terrible with names on the spot, but let's have another one called big results, and we're going to make this var, and we're going to make that equal to you know, whatever is the bigger result. So we're going to do an inline, like if expression, right? This is an expression because at the end of it is going to return a value. Before we did a if statement because of the fact that all we did was print out something, right? We didn't return a value. But in this case, we're going to do an if expression because of the fact that this if statement is going to do a conditional check, and whatever is correct is going to return a value from that. So the check that we're going to do is we're going to check if the initial result is greater than the second result. If the initial result is greater than result 2, then it's going to return result, right? We want to return, or we want to get the biggest result. And actually, I probably should just put biggest, because that's essentially what we're doing, biggest result. So if result is greater than result 2, then we want the biggest result to be stored. So we're going to return, or it's going to return the biggest result. That's going to be stored into this variable. Else, we know about else, right? That's just going to be the fallback, meaning that result, it is not greater than result 2. It's either going to be greater than, or it's either going to be, less than result 2, or it's going to be equal then. And if it's equal then that's fine. That means the biggest result is going to be it's going to be the same regardless, right? If both of them are 200, it's still going to go to this else statement, and it's still going to make the biggest result equal to 200, which is fine. Or if this is wrong, right? If in this case it is wrong because 150 is not greater than result 2, which is 200, then it's going to fall back to this else statement, which is going to be result 2. So I expect this biggest result to store the value of 200 because of this condition, because of this if expression. And the reason why this is expression is because it does an action that returns a value, and in this case it did a conditional check of checking whether or not this is greater than the other, and it returns a value. So this is why it's an expression. Honestly, this is what made it more clear. If you need any assistance on making that a little bit clearer, just leave a comment down below. But I'll just print this out just to show you guys that it is storing the biggest result. Boom. So it does return 200 as expected, because result is less than result 2, so it's going to fall back to this else statement, which is just saying return whatever is in result 2. So this if expression is perfect. Now a statement is just a way of expressing some action to be carried out. So we talked about if statements, right? It did a conditional check in the previous portion of the video, and it printed out some output based on the condition, right? So the example that we used was if Lindsay was greater than a certain age, then she can rent a car, right? And that just printed out that the fact that she could rent a car, it just did an action, right? But it didn't return a value, right, based on the action. So that's what a statement is. It just does some action to be carried out. So a very simple example of that would be creating a variable, right? We have a variable of grade, and we can assign it a value of a character A, right? This is a statement, right? This statement is just assigning a variable a value of a character A, nothing else, right? Or like I said before, the if statement of just printing out some output to be printed out to the terminal based on the age or criteria of something or condition. So that's the difference between an expression and a statement. A statement just carries out an action, but an expression evaluates it and returns a value based on that action at the end. So hope that was clear. Hope that provided some clarity, and then on to the next one. All right, so let's start talking about when expressions. And you're probably thinking to yourself, what is a when expression? Well, you're in the right place. A when expression allows you to create multiple branches to check if a criteria matches a condition. So I have a little example here at the bottom, and I have a when expression, and to signify a when expression, you will just use the keyword of when, open up some parentheses, place the condition that you want to check, and open up some curly braces and start placing the conditions that you want to check for. So essentially, it'll take the value of x and it will check against the conditions that you set. So in this case, I have a value of x, and that checks whether it's equal to true, false, and if it's not equal to true or false, then there's a fallback condition of else, right? So it's very similar to an if else or if else if statement that we went over previously in the video, because of the fact that there's different conditions that you can check for, and if it doesn't match any of the conditions, then it has a fallback of else. But it's in a more structured approach, right? It's not as big as a if expression or if statement, because of the fact that everything is within the curly braces, one curly braces. So you can use this whenever you want to check, or whenever you want to create multiple branches for a specific condition to check if the value within the parentheses matches any of the conditions that you set. So if x is true, then it's going to return a string of is true. If it's false, then it's going to return a string of it's false. And if it's none of those, or if it's not true or false, then it's going to have the fallback of else, which is going to return x is neither true or false as a string, right? And we can place that within a print, or we can have that stored in a variable, whatever you want to do with it. But just know that it's gonna check against these conditions, and we're gonna return a value based on the condition that it matches. So that is the use case for a when, right? So instead of creating a huge if else if branch, right, you can create a when, or you can use a when and set your conditions on what you want to check for, and it'll return a value based on the conditions that it checked against. So let's see this in action in the IDE. It's gonna make a lot more sense, especially with a better example. So yeah. All right, so I'm in the IDE, and let's actually create this example. I'm gonna create a variable called a, and set that equal to 100. Make another variable called b, and make that equal to 75. And then I'm gonna do a prompt, right? I'm gonna do a println, and I'm going to say enter operator. Either it's going to be a plus, it's going to be a minus, it's going to be a multiply, a division, or a modulus. So essentially we're making a calculator, right? And for the user to be able to enter the operator in the terminal, I want to use another Kotlin method or function that it provides to take in user input called readLine. So to be able to store whatever the user places in or whatever the user inputs, I'm going to use another variable, and I'm going to call this operator, and I'm going to set that equal to readLine, because this is going to allow us to essentially, when it gets to this line of code, it's going to say, okay, we're going to read the line or whatever the user inserts on that line, and then we're going to store that into this operator variable. And then now we can use the when expression to calculate, based on the operator that the user put. So if it's a plus, then we're going to have a condition that checks if the user put in the operator of a plus, and then do that math and store it into a variable. So, and we're going to do that for each operator. So let's create that. So we're going to create a variable called res, short for result, and then create the when expression. So remember, like I said, expressions are when you do an action and it returns a value. So that's the reason why this is an expression, because of the fact that this is going to return a value after it does the check on the operator. So let's do when, open up some parentheses, and then place the operator, right? Because this is the this is what we want to check for, like what's exactly in this value, and does it matches any of the conditions that we're about to set. So let's open up the curly braces and start setting the conditions. So the first one I want to check is if it's a plus. If it is, we're going to use an arrow. So just do a dash and a arrow, or greater than sign in this case. Put it together and it looks like an arrow, and then a plus b, because that's the two variables that we have. We could also, if you want to make it a little bit more fancy, you could make this also read line and this also read line. Just make a prompt on letting the user know that, okay, enter a value for A, enter a value for B. I would say that you have to check that the user actually puts in a actual numeric value, instead of like they can put in gibberish. You don't want that. But if you want to create your own project for that, or you want to test out your Kotlin skills, you can do that as well. Create a read line for each individual variable, and do this one expression and check the result. But we'll I'll let you do that. Let's make it simple, and I just placed the value already in there. So then let's do minus. Oops. It's dash, and then a minus b, and then multiply a times b, and then new line division, and then do a divided by b, and then last I am going to do modulus, and do a modulus b. And then I want to fall back, because there is a case where they don't, like I said, they don't put what we expect, right? You're always going to have a user that may try to test your application, or maybe they do it by accident, right? So there's going to be the else, and that's going to be the fallback, and I'm going to say invalid operator. Use the following, and I'm just going to tell them, hey, use one of these. And then we are good to go. Now we can just print out the result, and I'm going to say the result, and I'm going to use the string template and put the res in there, and then put a colon, and then we should be good to go. So now we have what we expect, right? We have a some variables that we want to use to check the addition or whatever operator that the user chooses, and to actually let the user choose the operator, we use readLine, which will take the input of the user and place that value into the operator variable that we created. And then we created a when expression, which will take whatever value that is returned from this expression back into results. And what we're doing with this when expression is we're checking based on the operator that the user chooses or chose to do some math logic, right? So if it's a plus, then it's going to do addition. If it's minus, it's going to do subtraction, etc., etc. And if the user chooses not to do any of those operators or use any of the operators that we expect, then there's a fallback of else, which will let the user know that that's an invalid operator. You should use the ones that we expect. And if they did use the one that we expect, then it's going to return the result. or if they didn't, then it's going to return a message of invalid operator. So this is the case that we can use a when expression. Imagine if you had to do an if or else for each individual one. That kind of get annoying. So this is why, depending on your needs or depending on how big the conditions are, it's probably better to use a when, because if it gets too big, then it's probably better to have a more structured approach with a when. So let's run this really quick. So as you can see, it's waiting for us, right? It's waiting for us to place an input. Usually for a regular application, if the application end, you'll see that there's a line that says exit code 0 or something like that. But in this case, it didn't exit quite yet. It's waiting for us to place a operator, right? It's waiting for us to put input. And in this case, I'm just gonna do a simple plus. Boom. As you can see, now it says exit code 0, but not without putting the result that we want. So in this case, we know that A is 100, we know that B is 75, so A plus B is 175. So that's awesome. And now let me just test that that it actually falls back as expected, right? If I don't put a operator, if I put a random string, what exactly happens? So let me run it again. All right, we're back into it, and let me just put a J. Boom. As you see, the result is that it's an invalid operator. Use the following, right? Because I just put a J, and that doesn't match any of the conditions that I have checking against operator. So let me try one more, right? All right, so let me do modulus. Oops, wrong one. Modulus, boom, 25. Because like I said in my previous portion of the video, that it essentially returns the remainder, right? So we know that 75 can go into 100 once, but we can't put 75 into 100 twice. So what is the remainder after putting 75 into 100? It's 25. So the result is going to be 25 as expected. So hope you guys found that useful. Hopefully now you know what a when expression is, and you know when you can use it. I think this is a pretty awesome way of using it. So hope you found that helpful. And if you have any questions, go ahead and leave that down in the comment section, and let's continue on. All right, ladies and gentlemen, let's talk arrays. And what is an array? Well, arrays allow a user to store multiple items of the same type under one variable. We talked about variables right in the beginning of this video series, and we talked about how a variable is essentially a box of information, right? It's stored somewhere in memory, but if we take that name and we ask for it, it's going to return whatever is in that box, if there's anything within that box, right? But with arrays, it allows us to store multiple items in that one label. So you could think about a label but spreading out multiple boxes using that one label. So that can be very convenient based on what you need it for, right? So to give a real life example, right? Say for instance you're moving, you have kitchen items, right? Everything belongs in the kitchen, so you put the label of kitchen right on the boxes, but you spread it out, right? So one could be for the pantry, one could be for the refrigerator, one can be for the counter, right? But we don't want to put it in where the garage stuff is, or we don't want to put it where the bedroom stuff is. We still want it to be related to kitchen, but you just want to spread it out within a couple of boxes. So it kind of is like that for array. And as I start to go over the properties, it'll make more sense. So the properties of an array is that the data is stored in contiguous memory locations, and all that means is that each data box is stored next to each other. So say for instance we have 4 items within an array, because like I said, it can store multiple items. They'll be next to each other. So it can use one box can store 8 bits, then starting the next 8 bits, it'll be right next to each other and next to each other. So they're all the memory locations are close together, they're next to each other, so they're not far from each other, right? We can retrieve the next item because it's right next to each other. The second property is that we can access data like we do with chars in a string using an index. So when we went over what a string was, we talked about how it's a sequence of characters, right? And if we wanted to grab one item from a string, all we had to do was use brackets and specify the index. So it started at 0 up to the length of the string minus 1. So say for instance we have the string box, right? That's BOX, right? To retrieve B, we would have to specify the index, which B is the initial character, so we'll use 0. To get O, the place that is at is the index of 1. So it starts at 0 up to the length of the string minus 1. So for instance, box is the length 3, but to access the last character, it'll be 3 minus 1, which is 2. And that will get you x. So we can access data like that. So if we wanted to retrieve one box, just like in the picture, we see that each box has a number value, right? So if we want to grab the second box, all we got to do is specify index, which in this case is going to be 1, right? Or if we wanted to grab the third box, it'll just be 2. So always, since it starts at 0 instead of 1, you just subtract by 1. So if you want to get the first one, it'll just be 0. If you want to get the second one, it'll be 1, etc., etc. But that's how we can access data within a array, and I'll show that in the example coming up. But another property is they are mutable, meaning we can change the elements within. So for each item in the box, we can change the value of whatever that box is storing. So initially, maybe it's holding a spatula within that box, but we want to change it to store the salt shaker instead. We can change that, right? We can remove the spatula and we can put the salt and pepper canisters into the box, right? We have the ability to change it from within. But the last property is that the sizes are not dynamic, meaning if we ask the array to be of 6 items, right, 6 boxes of information, then it's going to stay at 6 boxes, right? We can't add a new box unless we create a whole new array, but it's not going to be the same array, so it's not dynamic, and that's more of a property of a list. So if you want, something that's have the ability to add items, ability to change, then that's a list, and we're going to talk about that in the future of this video series. But for now, just know that arrays are not dynamic, it's fixed. So make sure that you know what size you want your array to be, because that's what it's going to stay at. So now that we talked about properties of array and what array is, let's dive into the IDE, because it's going to make more sense once you see it in action. Alright, so we're in the IDE now, and now it's time to give an example of how to create an array in Kotlin. So luckily Kotlin makes it very easy to make an array, and it provides a function called array_of, which we can just call it and provide it whatever we want to store into the array, and we can have that stored in a variable. Because remember, like I said, array just allows us to store multiple items of the same type, and we can put it under one variable. So what we're going to do is I'm going to create a variable called nums, and I'm going to make that store an array of numbers. So array_of is the name, and like I said, I'm going to put some numbers in here. So I'm just going to do the usual 1, 2, 3, 4, 5, and 6, and put a space in between there, and now we have an array of numbers. So right now Kotlin is inferring the type, which in this case are numbers, but we can also make it a little bit more strict, and we can use the chevron and inverted chevron sign, which is the greater than or less than sign, but apparently they're called chevron signs, and specify the type of that we want to store within this array, and in this case it's an int. So if we try to say, oh, this is going to be a string, it's going to be like, hold up, wait a minute, this is not a string, these are definitely ints. So if you want to make it strict, just place the type here. And there are also other ways that we can create an array using using the functions that Kotlin provides. So it's for the primitive type, so we can use things like int array and open that up, or we can use bytes array, we can use short array, char array, and last but not least, long array. So all of these will work. So if you wanted to make an array of ints, you can use int array. If you wanted to make an array of bytes, you can use byte array, short array for shorts, char array for chars, and long array for longs. And if you're gonna store only of that type, then you can use that. Or if you're going to store a string, then you can just specify a string as the type within here and start placing strings within there. So there are different ways that you can create an array in Kotlin, and yeah, hopefully that was helpful with that. So let's see how we can access and modify data within the array that we just created. So let's try to get information from this array. So we can go the old school way of let me print it out, but like I showed with strings and how we access a char within the string, we can do the same thing with the array. So we know that, like I said, it's a series of items in contiguously in memory, so essentially they're next to each other. So all we have to do is use an index to retrieve each one. We know that the size of this array is 6, and like I said, it doesn't start at 1, it starts at 0 to retrieve an item from an array. So essentially, one, like the first item in an array is not going to be 1, it's going to be 0 because it starts at 0. And it's not going to end at 6, even though the size is 6, it's going to end at 5 because it started at 0. So always remember to subtract by 1 so you know the right place or the right index to retrieve what you want to retrieve from an array. So let's try to retrieve the first item. Like I said, it's not going to start at 1, right? It's going to start at 0 because 1 minus 1 is equal to 0. And that's just how an array, that's where an array starts from, right? Or if you wanted to get the second item, remember it's just going to be 2 minus 1, when in this case it's going to be 1. So, but let me retrieve the first item, which is 0, and let me run that really quick. So as you can see, it grabs 1 from the array as expected, and it really matches what we did before, right? What we did with a string and grabbing a char. And we can also get it another way, which we can use a method that comes with this. We can use the dot get, right? So if we do dot, right, and do get, now it's asking essentially for the index that we're trying to get from the array, right? It says right here index of type int, and for this one we want to get the first one, so we'll use 0 again. Or actually, let me use another example, right? I want to get the last item in this array, and like I said before, the size of this array is 6, so if I subtract 6 by 1, it's gonna be 5. So that should get the last item in the array. And also, if you're not exactly sure, right, you can do nums dot size, right, and that will return the size of the array, and we can just subtract it by 1, and that will be guaranteed to get the last item within the array. So you can see there's a lot of things that, or a lot of helper methods that an array come with to help make your life easier, right? We can use the dot get to remember that, okay, we want to get a specific index, whatever is in that index. Or we can even use dot size to know, okay, how big is this array? And if I subtract it by 1, I know I'm guaranteed to get the size of the array. So now let's run that again and see what it brings. And boom, as you can see, it gives us 6, the last item within the array. Now, remember when I said that you have the ability to change the elements within the array? Like, we can't add to the array, but we could definitely change what's already within it. So how do we do that? Well, we could do what we did with strings, right? We can always access it, so we can get the index where we're trying to change. So say for instance we're trying to change the first element, right? So that's going to be 0, and we're trying to change it to another value. So say for instance we want to change the first value to start at the number 0, or even make it negative, right? Let's make it -5, right? We could do that, right? We just have to access it and then assign it, right? Assign it another value, which in this case is going to be -5, right? Or we can also use another method that arrays come with, which is nums.set, right? We just use get, so there has to be essentially a setter, right? So we can set a value at an index. For the first thing that it's going to ask for is the index that we want to change. So let's change the third value. So in this case, it's going to be 2. And then because it's 3 minus 1 is 2, so it's going to get this 3 right here. And then it's going to ask for the value that you want to change it to. So let's make it a big number so it's kind of obvious, right? I'm kind of messing up the in order values of this. Like it started at 1, it goes to 6, but I'm going to mess it up a bit. So let's say that, okay, I want to change the third item to 100. All right, so now I'm going to get the first number, and I'm going to get the third number and see what the values are. So boom, as you can see now, the number is -5 for the first value, and the third value is going to be 100. So we see that it does have the ability to be changed. All right, so let's try to see the values within the array, and we can use a for loop for this. So we'll use the keyword for. We'll give it a variable that we want to use to signify each individual item within the array. So like this I is going to signify, okay, we're at the first step is going to be 1, the second step is going to be 2, 3, 4, 5, 6. Well, in this case, it's going to start at -5, then it's going to be 2, then it's going to be 100, then it's going to be 4, 5, and 6. So it's going to go through each item, and we're going to print it out to see what's currently within the array. And I'm going to say from I in the range of 0 to the length, or essentially the size minus 1. So I'm essentially creating a range, and this is going to go from 0 to, in this case, there's only 6 items in here, so it's going to go from 0 to 5, right? Because we know that arrays start at 0, and we want it to end at 5. And then now we're going to open up a curly braces, and now we're going to use what we learned, right? We can access a number within the array by using, brackets and the index. So let's, println, and let's do nums, and let's open up the brackets. And we know that each step, the value is going to be an I, so we're going to put I in here. And let me comment these out, because we're going to have a for loop that iterates through it and print out each individual item at the index, and it's going to end when it gets to the end of the array. So let's run it. So boom, now we see, okay, our changes are proper, right? We see -5, we see 100, and we see the rest of the numbers that weren't changed, right? So we can use the range of 0 up to the size, or we could also just specify, because like I said, Kotlin comes with a lot of methods already ingrained in arrays. So all we gotta do is nums.indices. And this is essentially saying, okay, we're gonna get the indexes of all the numbers within this array. So it's gonna start at 0, and then it's gonna go all the way up to the size. So now we don't have to specify a range ourselves. If we want to make it more specific, we could, right? So say for instance, we wanted to just make it from 3 all the way up to the size of the number, or the end of the number. We could do that. But if we know that we just want it to be all of them, right? All of the indices of the nums, we can just use .indices, and that's gonna return essentially all, or the range of the whole array. So if we run this, we should get the expected result, or the same result as what we just did with the range. Boom. As you can see, it's the same thing, right? We got all the indices, we're iterating through it, and we're using it to access each item within the array. So now, what if we have, an array, and we want to check, if a number is within the array, right? Well, we can do that too, right? Arrays are just awesome at this point. And we already talked about if statements, right? If statements, you need a condition that returns either true or false. And in this case, we're trying to check if a number is in the array. So that should return true or false, right? Whether the number is in it, which is true, or whether it's not, which can return false. So let's check, right? We have an array, and we know that we changed the initial value to -5, and we changed the third value to 100. But is the number 10 within this array? Well, we can check that, right? We can do is 10, right? Because that's the value you want to check for. Is 10 within, or in this case we're going to use in, is 10 in nums, right? If 10 is in nums, then, well, we can put that out. Well, 10 is in the array, or in this case, let's make it generic so we can check for any number. So we can say number is in the array. Else, and honestly, if you want to make it really nice, let's do, and let's put 10 in here. Is num, right? Is the number in nums? And right now num is equal to 10, and then we can use some string templating, and we can say that we could pass in the actual value of num. 10 is in the array. Else, and then we can have another message, and then print that out. We can say that, and do some more string templating, and say num is not in the array. And now we can print this out. We're essentially checking if a number is within an array, and now we don't have to go through it and use a for loop and check, right? Because you can do a for loop, and we can use an if statement within the for loop to check if it's in it. But now we don't even have to do that. We could just use the in keyword to check if that number is in the array. And 10 is not in the array, which is true. Like 10 is not in the array, but we know for a fact, right, because we changed it ourselves, that -5 is within there. So let's see if this logic is working for that. So let's run it again. And as you can see, 5 or -5 is in the array, so it's passing this case, right? It's passing that num is in nums. So that's what you can use if you have a series of numbers or strings or chars in an array, and you want to check if that's within the array. We can use the in keyword. Like, there's a lot of cases where in is used. You can use in for a for loop. You can use in for checking for this. So yeah, there's a lot of things that you could do with the keyword in, but in this case, you can see that it can be used to check if a value is within an array. Awesome. And I've been talking about how great Kotlin, or how useful Kotlin is in regards to creating helpful methods that we can use with the array. Another one that we can use is checking or not whether a array is empty. So we can use nums in this case because it's holding numbers, and we could check, is it empty, using is empty. And if it is empty, then it's going to return true, and if it is not empty, then it's going to return false. And we can use the if statement right here and open that up, because like I said, if statements, the condition has to be true or false, and in this case it is checking whether or not is empty or not, and it is returning a boolean. So let's print that out. If it is empty, it is empty, and there's the fallback with the else for ln, it is not empty, right? And let me just comment this out and let me run it. And as you can see, it is not empty because nums is not empty, right? It's it's not. So but what if we want to actually remove stuff from the numbers, right? And then check if it's empty. Well, another useful method that Kotlin comes in regards to arrays is drop, right? So we can use that to drop a certain amount of values from an array. So to do that is just be dot drop, and we can specify how many items we want to drop from the array. So say for instance we do drop dot drop, and then we place the value of 6 within it. Then we're literally just telling Kotlin that we can drop all 6 values within the array, and then we can do that here. We can also append that, right? So we can drop the 6 and check, is it empty? So let's run it again. Boom. So as you can see, there were originally 6 items within the array. Drop allows us to drop a certain amount of values from the array starting from the initial beginning. So if we said drop 2, then it's going to drop the first 2 items. It would have dropped, in this case, the first item is -5 and the second item is 2. It would have dropped those 2, and then it would have kept 3, 4, 5, and 6. Well, in this case, it's 100 because I changed it to 100. It'll be 100, 4, 5, and 6. But since I said drop 6, it's going to remove all the items within the array, and then I'm saying, okay, check if that is empty, and it is empty. So it's going to return or print out it is empty. So, and I can even print that out. Let me print out nums after I drop 3. Let's drop 3 items, right? And I put a hash, but let's drop 3 items and see what happens. Boom. You can see that it returns what's after it drops the initial values that you specify. So if you drop 2, it will return 4. In this case, it will return 4 items that is left. But in this case, I told Kotlin, okay, let's drop 3 items. So it's going to return whatever is left. So in this case, it's 4, 5, and 6. So now I have a question, right? And I'm going to show you guys the answer. But yeah, we told nums to drop 3, but does it affect the original nums, or does it take a copy of it, drop the first 3, and return whatever's left over? So that's a question for you guys. Let me see if you guys know the answer. Well, to confirm that, I am going to take this for loop, bring it down to the bottom after I choose to do the drop, and we'll see in live view whether or not this is taking a copy of nums, dropping the 3, and returning what's left, or is it actually removing it from the original variable. So let's run this and let's see. Boom. So as you can see, it's dropping the first 3, and it's returning 4, 5, and 6. But when I do the for loop, you're seeing that it doesn't drop from the original array. It's actually making a copy when it does the drop here, and it's returning what's left from that copy, but the original variable is safe. So when you're doing this, you don't really necessarily have to worry about that. You can just drop and it's going to return a copy, and if you need to store it in another variable, you can do that as well, but the original array is safe. And yeah, there is that. And one last thing that I wanted to show, let me comment this out, is if you took a algorithms course or data structures course, you would have probably heard about a set, right? A set meaning there are no duplicates within a range of data. So in this case, we have nums, and what if we want to make all of the numbers unique, all of the numbers distinct, right? There is a case where we could, and let me comment this out, we could have, duplicates, right? We could have multiple ones, we could have multiple threes, like we could have multiple of each individual value. But what if you don't want that? What if you want each item to be unique? Well, and this will be the last method that I go over, but we can create a set of distinct values within an array. So to do that, I'll create a variable and I'm gonna call it no duplicates, and I'm gonna set that equal to nums, right? Because we want it to be equal to nums but without duplicates. So to do that, we just use dot, and then we're gonna use the method called distinct. And essentially what that's gonna do is gonna go through the arrays and see whether or not there are any duplicates, and only keep the distinct values, only keep one, right? We don't want any duplicates, and we can confirm that by printing it. And let's print out no duplicates, or actually let's use a for loop to get each individual value. And let me see, yeah, actually let me get the first one. Yeah, that works. I'm gonna use the one with indices, and then 4, and then let's do no duplicates, and then we'll access it using just to make it fancy, use .get, just so you guys remember that it's available. .get, and then remember I is going to be each individual index of whatever is in no duplicates. They're going to use .get to get the value at that index, and then we're going to run it again. So as you can see, originally we had 1, 1, 3, 3, 5, and 6, but when we use .distinct on it, on the array, we get distinct values. Now we only have 1, 1, 1, 3, 5, and 6. 5 and 6 wasn't changed because we only had 1, 5, and 6, but we only have one of 1 and 1 of 3. So now they're all distinct. It's sets. There are no duplicates, and that's just the power of array. So if you want to store multiple items in contiguous memory that you can use to, and access using an index, then go ahead and use an array. And arrays are used a lot. If you have experience with other languages, you know that it's used a lot. If you do interview questions, you know it's used a lot. So that's just how you use an array in Kotlin, and how you can access it, how you can modify it, and some of the methods that you can use. There are many methods that you can use. So I would advise using the Kotlin documentation to go over what are some different methods that you can use to make your life easier. But I went over some of the powerful ones, and there is even sorting ones and stuff like that. So hopefully you found this useful, and let's continue on. Alright, so before I get into talking about for loops, I thought it would be smart to talk about what is a range, right? So when you think of a range, you automatically assume numbers, which in this case you would be correct. But in Kotlin, there is a way of using range for different cases, right? So let's show what a range actually is, or how we create a range, right? So like I said, it is a range of numbers. So to specify a range, what you have to do is specify two endpoints, essentially. So where you want to start and where you want to end, and it's going to be including both endpoints. So if you want to say, for instance, do 1 to 10, you can do 1 dot 10, and this signifies a range of numbers from 1 to 10, including 1 and including 10, right? In some cases, ignoring the numbers, the initial point and the ending point, but for range in Kotlin, it's including the initial point and the ending point. And when we get into for loops, we'll talk about different ways that we can exclude numbers out of a range, or we can iterate through numbers in a range. But I just want to describe this alone, right? Extract it from the loops, because the range is used a lot when it comes to loops, but people never really explain exactly what a range is. So in this case, it's just a range of numbers. It's going to go from 1 to 10, and even beyond loops like we're going to talk about, you can even use it for an if statement. So remember, with an if statement, whatever you put between a parentheses have to either be true or false, right? So say, for instance, we have a variable, right? Let's say it's 20, right? Or let's make a var age of 20, and we're trying to check if this person is old enough. Like we made an example before of if this person is old enough to enter this bar, they have to be 21 and up, right? That's an American thing. I don't know what country you guys are watching this from, but you have to be 21 or older to enter a bar in America, or some bars in America. So I want to check if that person's age is within a range, and we can use this variable to check that, right? And we can use a range to also check that. So we can see if age is in, and there is a keyword of in because it's going to be used to compare whether a number is in a range, right? So that's the cool thing about Kotlin. There is an in keyword. It just makes it easy. So we're going to check if this person is at least between 21 and the age of 130. I don't know if there's an individual older than 130, so, but if there is, that's awesome. But I'm putting 130 as my last age that I expect a person to be. And if the person is from 21 to 130, then they can enter. Well, else, then you have to wait. So just put that. So let's run this really quick. And as you can see, that person has to wait because the person's age is 20 and they're not 21. They're not within the range of the number set, right? The range of numbers. But say for instance we're in Europe or something, and in certain places in Europe, the age that people start drinking is 18. So let's change the range from 18 to 130, and let's run that again. Well, now the person can enter the bar because that person is within the range of numbers, 18 to 130. That 20 is definitely within that range. So you see how powerful range can be. I mean, we don't have to check each individual number like we did in the if statement. We can just specify a certain range, or maybe we want to check if a person's elderly, or if the person's youth, or if the person's adult. Like, we can split it up by different ranges of numbers. So there's different examples that you can use a range for, other than the example that we're going to do next, which is with a for loop. I just wanted to exclude that from the for loop because there's other ways that you can use range. Range is pretty powerful, and there's keywords that you can use to test against the range. So hopefully you guys find that helpful. If you have any questions, leave it down in the comment section. And if you guessed it already, the next thing we're going to talk about are for loops. So stay tuned. Alright, so as promised, let's talk about the for loop. Well, in Kotlin, a for loop is used to iterate through ranges, arrays, maps, and so on. Really anything that has an iterator. And we talked about ranges, we talked about arrays, we didn't talk about maps yet. We're going to talk about that later in the video, so stay tuned. But like I said, it can be used to iterate through ranges and arrays, and we're going to show an example of that. So let's create a for loop really quick, and just as the name implies, we're going to use the keyword of for. We're going to open up some parentheses, and we're going to specify a range, right? And for this range, we want to check, or we want to make sure that we extract that number within that range. So for I, right, I'm going to give it a variable name of I. It can really be anything. It could be Q if you want it to be, but usually it's I or J, right? Let's do J. If J is in 1 through 10, right, we're going to open up some curly braces, and we're going to print out J, right, or print ln, because I want to put on a new line. So essentially what this is going to do is it's going to go through the range of numbers, and it's going to set the value within that range of numbers to J, right? I know for the if statement we use this to check if J is in the range, but in this case it's going to be used to iterate the range, and it's going to place that value while iterating into J, and then we're going to be able to print that out step by step. So let's run this really quick and see that in action. So boom, we can see that it starts at 1, because we know that for a range it's going to include the initial point and the ending point. So it's going to go from 1 all the way to 10, and J is each value within the range. And honestly, since we're only doing a one-liner, we don't even need the curly braces. We can literally take out the curly braces and just have the print ln. And let me run that again so you guys see that I'm not lying. And boom, as you can see, 1 through 10 again. Now let me comment that out. Now let me comment this out, and now let's create another for loop, right? And like I said, we can use the for loop for arrays as well. right? Anything that has an iterator, which we'll talk about another time. But things like arrays, things like ranges, things like maps, like I said, we didn't talk about maps yet, but we're going to talk about maps. But let's create a array really quick, and we're going to call this program languages, and we're going to set that equal to an array. And sorry if you hear a rain outside, this is like a huge thunderstorm outside. But we're going to set this to Ruby, we're going to set this to Java, we're going to set that to Kotlin, and let's do Python, which is personally one of my favorites. And then we're going to create a for loop, right? So we're so used to just using ranges of numbers, right? Because we've been using that for the last few minutes. But you can actually iterate through an array, and we can use a for loop like we just did before. And then we can use another variable name. It can be anything. It can be I, it can be J, it can be something more specific, which you should make it specific and make it language, right? Because we're going to be iterating through an array of languages, and we're going to be, in this case, printing it out. So for a language in program languages, we're going to do something, right? So we can, if it's going to be multi-line, then we can use the curly braces and, you know, execute that code within the curly braces. But if we know it's going to be only one line of code, let's just, you know, extract the curly braces and then just do the println, and then just print out what we want to print out, which is going to be the language, right? So for each language in programming language, we're going to iterate through it because we're in a for loop. That's what a for loop does. It just iterates, right? So for each language within the programming language, and in this case there is 4, is going to take each individual string of languages and it's going to print it out. So let me do that again. And boom, as you can see, we see each individual language that was in the array of languages on its own line, right? So we have Ruby, we have Java, we have Kotlin, and we have Python, and each one will signify as a language while iterating through the for loop, right? And went step by step. Now, let's also look at strings, right? Remember when I described what a string was? It is a sequence of characters, right? So if we wanted to extract R from Ruby, we'll just do, you know, in this case, let's say that hypothetically the variable language was holding Ruby. All we have to do to access the first character is open up some brackets and place the number 0, and that would say, okay, I want to access the first character because it starts at 0, it doesn't start at 1. I want to access the first letter within that string, which in this case, hypothetically, like I said, language is holding Ruby, so the first character in Ruby is R, right? But remember I said characters or strings are a sequence of characters, so we should be able to iterate through a string as well if we need to. We can hypothetically, well, not hypothetically, we can actually iterate through the sequence because it is a sequence of characters. That means we can grab each one individually. So let's do that really quick. So let's make a var, and let's make that equal to a prompt, and I'm gonna make that a sequence of chars, right? And then I'm going to iterate through it. So I'm going to make a for loop again, and I'm going to make this character, and for character in prompt, I want to print out that character, and I'm going to comment this out because it's going to be pretty long, but I am going to run it now. So boom, it is rather long, but you can see that it actually prints out each individual character on a new line. If we wanted to be on one line, we could have just used print, but just to show that it actually worked, I use println. It's going to print out each individual character on a new line, and we can see that it's sequence, right, of chars, and it ends the program. So it's a sequence of characters. We can iterate through each one if we need to. So if you ever need to iterate through a sequence of characters, then, or a string, then you can do that as well. Alright, so now another cool thing that we can do with strings is the fact that we can actually get the index of a string, or each individual character in a string, and use that either to access a value in a string, or maybe we just want the index of a specific character. We can do that as well. So let's do that really quick. So let's do for, and we're gonna do index, because we're going to get the index of the sequence of characters. So index in prompt dot indices, because that's just going to grab the index of all the chars, and then we're going to iterate through it. We're going to open up some curly braces. I'm going to do println. I'm going to do index, and then I'm going to print out the index, but then I'm also going to print out the char just to make sure that we can see that it's grabbing the index and the actual char at that index. And then let's do some string templating, and I forgot to put the $sign here. And let's do the prompt, and let's access the individual thing at that index, and we should be good to go. And let's run it, and boom, we can see that we're iterating through each individual item in the sequence of characters, or the string, and it's showing that 0 currently is S, which is the first letter, and it's even counting the empty spaces in the string. So even empty spaces count as a specific char, and it has an index for itself, and the ending one is 16, which is the last character, which is S. So you can see the power of this. If you just want the index, you have the index, or if you want to access it at the same time, you can do that as well. But that's just another way that you can use a for loop. And let me show you different ways that you can use range, right? So we just showed range as just a sequence of characters, but say for instance we want to iterate through it using different versions. Like we don't want to go one by one, but we want to step through it by 3, or step through it by 2, right? We want to go from 2 to 4 to 6 to 8. We don't want to just go 1, 2, 3, 4. Or maybe we want to go in reverse, right? There's different ways that you can use a for loop to iterate through a range of numbers. So let's start with reverse, right? We want to do reverse a range, right? We can do that. So to do that, we'll just open up a for loop, open up the parentheses, and like I said, it's the usual I or J or whatever you want it to be really, but I'm gonna do I. And if it's in a range that we're gonna specify, but instead of doing the usual 1 to 5 or whatever range number that we specify, we start at the ending point, right? So usually it's 1 to 5, like I said, but if we're trying to do reverse, then we gotta start at the end and go down to what we need to go to. So that can be 0, that can be 1, but you can choose an ending point that you want to reverse to. But in this case, I'm gonna do 5, and I'm gonna go down 2, and I'm gonna choose the ending point that I want to reverse to. So I'm gonna choose 1 in this case, or in this case, I'm gonna choose 0, right? And then, like I said, if you're only gonna use one line or have a one-liner within the curly braces, just exclude the curly braces and just put the one-liner next to it. And in this case, I just want to print it out just to show you guys that it's working. So, and I'm honestly just gonna put on one line just to make it easier to see. And then I'm gonna print out I, and let's run that. Boom, as you can see, it's 5, 4, 3, 2, 1, and 0. Honestly, I probably should have just put that using println, but we can see that each individual one is here and it's reversing. And yeah, it's working as expected. You can reverse a range. You can also skip numbers if you want to. Like say for instance you want to go from 5 to 3 to 1, and then that's it. You can do that, right? So let's skip or iterate, or yeah, let's say skip numbers. So to do that, and we can even still stay in reverse if we want to. So let's do for I in, and let's choose a bigger number. So I'm gonna choose a bigger range. So from 10 down to 0, I want to skip a step. So how do I do that? Well, I'm gonna step by 2. I'm gonna step or iterate by 2, and then I'm gonna print ln because I'm gonna make it look a little bit nicer. I'm gonna print out I, and let me comment this out and run it. So boom, as you can see, it's still going to reverse. It starts at 10, and then it goes to 8, goes to 6, 4, 2, and then to 0, and it doesn't do anything after that because we specified the range from 10 down to 0, but we're going to be skipping or stepping by 2. We're going to use the keyword of step, right? This is important. After you choose a range from 10 down to 0, because that's how we do a reverse, we choose, or we let Kotlin know that we're going to step by 2, or we're going to skip by 2. It doesn't have to be 2. It can be 4. It can be 5. It can be a number as long as it's not bigger than the range, because if it's bigger than the range, then you're just going to be skipping out of the range. But yeah, you can choose a number to skip by and go by that. And remember, it's not exclusive to just reverse. You can also do the regular range, right? So I'm going to take the range from the top, skip forward, and then I'm going to do the 4, and it's going to be j from the range of 1 to 10, and we're going to skip by 3, or step by 3, and then that's going to skip or iterate 3 numbers forward starting at 1, and I'm going to run this. So boom, we're going to start at 1, we're going to go to 4, we're going to 7, then go to 10. 10 is the end of the range, and it's going to end there. So that's how you skip forward, that's how you skip in reverse. And we saw how we could reverse period without even skipping. And last thing that I want to show is how you can exclude the last number. Maybe you not, like right now it's including 1 all the way to 10, but maybe we don't want the last number. Well, we can skip that as well. We can exclude the last number. So let's do that. So let's do a 4, and I'm even gonna, let's get fancy here. Let's do z. For z in 1, and instead of doing the dot dot or the down to, let's do until 10, right? So it's gonna go from 1 until 10. So we're gonna see that it's gonna exclude the last number. So let's see, let's print out z and let's run it. All right, so boom, as you can see, it goes from 1, it still includes 1, but it excludes 10. It goes up until 10, but not including 10. And you can even see that Kotlin puts the little signs here that shows you less than or equal to, but here it doesn't make it less than or equal to 10. It makes it less than 10, so it's not going to include 10. So hopefully you found that useful. It was rather long, but I wanted to show you guys the power of for loops and ranges. And as we start to go into things like maps and collections, we can see how really powerful the for loop is. But we showed range, we showed how to iterate through strings, we showed how you can iterate through or reverse using a for loop. So later on we're going to use it a little bit more, but for now, hope you found that useful, and let's continue on. Alright, so the while loop. We kind of already are becoming experts when it comes to loops. We know that a loop is used in programming to repeat a specific block of code until a certain condition is met. So we went over the for loop, and the for loop is defined by specifying a range, and once it gets to the end of the range it stops. But in this case, right, the condition evaluates, or it keeps going as long as it evaluates to true. So it's kind of like the if statement, but it just keeps going, right? So as long as the condition is true within the expression, then the loop is going to keep going. And this test expression is inside of parentheses, and it's got to convert to true or false, right? If it's false, then it's going to stop. If it's true, it's going to keep going. So the structure of a while loop is towards the bottom of this page, where you have the keyword of while, you have the parentheses, and then you have a expression or condition that gets evaluated each time. And as long as it's true, everything within the curly braces run, and then it goes back to the top, right? Is the expression still true? If it is, then it keeps going. Now you want to make sure that the expression eventually does end, unless you want it to go forever, which, I mean, if you want it to go forever, that's on you. But just make sure that if you don't want it to go forever, then you have the expression evaluate to eventually go to false. So the statements inside the while loop are executed as long as it's true, then the expression is evaluated again, and if it's true, then it keeps going. But like I said, be careful for unintentional forever loops. Now if you want it to keep going, let it keep going. But if you want it to stop, then make sure it stops. So let's go into the IDE and actually create a while loop and see this in action. So we're back in the IDE, and we know that the structure was using the keyword of while, opening up the parentheses, is going to have some type of expression in here, open up the curly braces, and within these curly braces is going to be code that you want to execute as long as the condition returns true. Now if it's false, then it's going to stop, or if it even starts at false, then nothing is going to be evaluated within the curly braces. But if it is ever true, or even if it's true once, it'll run the code once. If it's true 5 times, then the code within here is going to run 5 times. So that's how you try to configure your conditions to be. If you want it to run a certain amount of time, then you set it to run, or you set the condition to last for a certain amount of time. So let's do that really quick, right? So let's create a variable, right? And it's going to be equal to I, or I is going to be called I, and we're going to make that equal to 5. And if you're starting to notice, or we're going to make that equal to 1. And if you're starting to notice, I is used a lot for loops, I, J, X, Y, Z, but it can be anything that you want it to be. I just like using I, especially for very simple ones, right? Because I'm not necessarily doing it, but actually, you know what, let me go against the grain, right? Let's make it a counter, because that's essentially what I'm creating in this case, right? And I want this counter to keep going until it is equal to 5. So let's do counter, and as long as this counter is less than or equal to 5, right? Because when it's at 5, I still want it to, to go, but once it gets past 5, then you can stop, right? So as long as this counter is less than or equal to 5, then we can print out the count. So let's open up a string, and I guess use string templating, and I'm just gonna say count is equal to counter, right? And we learned about incrementing, right? We learned about decrementing and incrementing variables in the previous portion of the series. So let's actually use that here, right? Let's actually increment, right? Because I want to make sure that this eventually stops, because if I just keep it as it is now, it's going to cause problems, right? Imagine me keeping counter at 1, and we're saying, okay, as long as counter is less than or equal to 5, then we're going to print this out. Well, if counter never increments, if it never increases in value, then it's always going to be less than 5, and this is going to continue on forever, which will be terrible when it comes to, the memory stack, right? Or handling, all that going on, right? Because it can be relatively fast. It can continue going on for a long period of time. So we want to make sure that you eventually get over 5. In this case, if it was less than 5, then as long as it's 5, then it will stop. But since I'm doing less than or equal to 5, then it would have to go over 5, because I'm including 5 for the case, right? Because if counter is less than or equal to, remember, if it's equal to 5, then it's okay, it's true. But once it's over 5, then that means it's not less than 5 or equal to 5, so it's going to stop. So always think about the expression that you're putting, or the condition that you're putting within this parentheses, and get it to stop. And then so now let's increment counter to make sure that it eventually stops. So we're going to do the plus plus counter, and then remember, once it gets to the end of, or gets to this ending curly braces, it's going to be like, oh, this is a while loop, let's go back to the top and check if this is true. Now when it gets to false, then it's gonna be like, okay, we're done with this while loop, we're gonna just get to this end right here. And just to prove that, I'm gonna put gotta go inside. We are outside the while loop, right? And now that that's done, let's run this really quick. And as you can see, the count, it starts at 1, so because counter started at 1, and it goes all the way up to 5 because I said less than or equal to 5. So if it's equal, then you can still print out what you need to print to, add to the counter, and go back to the top. But once you see that the counter is over 5, because we incremented right here at the bottom, it's going to say, okay, we're done with this while loop, let's go to the next line. What's after this curly braces? What's on the next line? Well, this print at len is on this next line, and it's saying that we are outside the while loop, so let's print that out. And then boom, so it does the while loop, right? It makes sure that it completes the while loop, right? And then it make sure it goes to the next line. Now if we mess up and have this continue on forever, it's never going to get to this next line. So you want to make sure that there's an ending portion to it. I know I talked about it like 5 times already, but trust me, there's a lot of projects that crash or break because of the fact that people didn't do their due diligence when it comes to checking if this condition actually ends. So unless you're intentionally trying to do it, some people intentionally try to make it go on forever, but if you're not and you want to eventually get to the next line, then make sure that you're choosing the proper condition. Make sure that you're incrementing the variable that you're using, or whatever scenario that this is going to be true or false. Make sure that you're doing it properly. So hopefully that gave you an understanding of a while loop. If you have any questions, leave it down below. Let's continue on to the do while loop. We talked about the while loop, and we talked about how it has to be true for it to execute code within the curly braces, but it has a sibling, right? And that sibling is a little bit hard-headed, and it just runs the code at least once, so it doesn't really care about whether it's true or false initially. It just runs it at least once. So yeah, that's the do while loop, right? I'm just gonna do it no matter what, and then I'll worry about the while loop. Is essentially how I like to name it. But the do while loop is similar to the while loop with the one key difference. The body of the do while loop is executed once before the text expression is even checked. So it's gonna run the whatever's within the curly braces once, and then it's gonna check the condition. So if you know that you want it to run at least once, right, and then you want to test on whether it's true or false, then you use the do while loop. But if you know that you want to check the expression on whether it's true or false from the beginning, then you use a while loop. But if you want to run at least once before checking on whether it's true or false, then you use a do while loop. So it really is based on needs. So let's see this in action. Let's go into the IDE and see the distant cousin of the while loop. So we're in the IDE, and now it's time to create a do while loop. And we saw the expression or how it's created or how it's structured for a do while loop. It'll be the keyword of do. We open up the curly braces, and no matter what, this is going to run at least once. So anything within these curly braces is going to run once, and then after that it's going to check the while portion of it, or check the while condition. So after the curly braces, we're going to put while, then it's going to have some type of condition within the parentheses, just like how we did with the while loop, and then that's it. We can end it right here. If the condition is true, then we'll go back into the do, and we're just going to do whatever's in the curly braces. And if not, if it's false, then it's just going to go on to the next line, and we're going to continue on with the application or whatever's after the do while loop. But if you want to check it at least once, then, or if you want to check it once without checking the condition or the expression for the while loop portion of it, then you use a do while loop. So let's see an example, right? Say, for instance, you made a calculator, right, and you want it to keep going until the user messes up, right? And we learned how to take input from a user a while back, right? And that's using the reline function, and we can do that again, right? Let's do print, and let's do enter a number, right? And let's say we want to check if the input, or let me do for input, I'm going to make this a string, right? And then what we're going to do is we're going to take the input and we're going to read the line. All right. And what this is saying is, well, it can be null. So we're going to use these two exclamation points. So we're going to talk about that later when it comes to Kotlin safety. But essentially what this is saying is if the user doesn't put anything, then we can just crash the application. You do not want to do this, but just for this example, or it's going to return a null exception, which if you came from Java, then you know what a null exception is. But essentially, if you don't put anything, it's going to return a null exception. So, and we're going to explain what that is later on if you don't know what it is. But just for now, we're reading information from the user. If the user doesn't put anything in, then it's going to just return a null exception, essentially saying that the user didn't put anything, so we can stop the application. But then we're going to take that, and I said we're going to do a calculator. We're just going to sum the number. We're going to do plus equal. And remember, input right now, because we're taking input from the user, is going to be string by default, but we want to make this into a number, so we can cast it, and we're going to do to int. Essentially what this is saying is we're taking the string value and we're going to turn that into an int. And honestly, I forgot to make another variable called sum, and we're going to make that equal to 0. So now we're going to take the input from the user. If it's a number, then we're going to set that to add to sum. Now if the input is ever equal to 0, we know to stop. So let me just put a disclaimer. Enter a number and enter 0 to stop. Or actually, my mistake. If it is not equal to 0, then we can continue on, right? As long as the input is not equal to 0, then we can do whatever is within these curly braces. But it's going to run this at least once just to start it off. But if it's not equal to 0, then it's going to keep going, right? If it ever is equal to 0, then we're gonna stop this. And you know that input is a string, so that's why I'm checking if 0 is a string, because input is read from the user as a string, and then we're converting it to an int by using the dot to int, and then we're adding it to the sum. And then when we get to the end, what we want to do is we want to print out the sum. So the sum is, and then we're going to use string templating, sum. Cool. So let's run this really quick. All right, so it's saying enter a number, or enter a number and enter 0 to stop. So I don't want it to stop, so I'm gonna do 5. Enter a number and enter 0 to stop. Well, I don't want to enter a number, so I'm gonna put 10. Or I don't want to enter a 0, so I'm gonna put 10, and then 3, and then 2. So now it's 5, 10, 3, and then 2. That should equal to 20. So I can stop now. The sum is 20. So as you can see, if you have a game, or if you have a prompt that you want to continuously keep going, and the initial point is important, then you can use the do while loop, right? Or you can even use a while loop if you want to. Maybe have a checker to see if if a value is equal to a certain number in a while loop. But to make your life easier, just use a do while loop. You want it to run at least once before continuing on, and if everything is okay, if it passes the condition after running at least once, then you keep going until the expression here is false. And in this case, I had the expression check if a input is not equal to 0, then it can keep going. But if the input is ever equal to 0, or in some cases you could put -1 to exit out of the application. I probably should have chose that. But if you want to exit out, then you can use a false expression. So and also in this case, it's probably not a great now that I look at it, it's not a great condition. You could put, if a value is not numeric, or if it's less than this, a specific range. Like, there's a lot of things that you can do with this expression here, but just to show you the usefulness of a do while loop, if you want to run at least once, use it, and yeah, go from there. So that is the distant cousin of the while loop, and let's move on. Alright, so back in the IDE we are. So in this portion of the video, we're going to talk about breaks, continues, and labels. And honestly, I actually learned something new when doing this portion of the video, because I did not know what labels were prior to making this video. So when learning about it, I'm like, wow, this is very useful. I'm actually surprised I didn't know about it. So hopefully this can be helpful for you guys, because I think it's very useful. But let's talk about what a break is. So what a break does is that it terminates the nearest enclosing loop. So we just learned about for loops and while loops, and when it comes to something like a for loop, we can have nested loops, or we can have regular loops as well. But what a break does is when we get to a certain point and we use the keyword break, like how you spell it here, break, it will essentially terminate the loop, right? Or if we have a nested loop, it will terminate the nearest loop. So it will terminate the nested loop inside of it. So we're going to see an example of that. And then the continue keyword, right, proceeds to the next step of the nearest enclosing loop. So if we have one loop and we get to a number that we want to continue from, it's going to essentially skip that number and continue on with the loop, where if it was a break, it would just stop the loop, right? So that's why it's continue versus break, right? One breaks and just stops, and then one continues on while ignoring the previous one. And then a label essentially allows you to put a label at a specific point of the loop, which will allow us to jump back to that specific portion of the loop and run either break or continue. And in the future, we're going to learn about another keyword called return, which we'll learn about when we talk about functions. But just not to confuse you guys, we can use labels to essentially jump to a specific point in a loop. And I'm going to show an example of that right now. So let's say, for instance, like I said, we have a for loop, right? We do the usual for loop. We have I in 0 to 10, right? And I'm just going to make a range from 0 to 10, including 0 as well. And we're going to open up some curly braces, and we're going to do the usual print, right? Print, and then let's print out I, right? We expect it to print out each time while going through the loop the number. But what if we have a conditional, right, that checks if if we get to a certain number, we want to break out of it, right, before even printing out the number, right? We could do if I is equal to 4, right? We can break. We use the keyword break. Essentially what we're saying is that we want to terminate the nearest enclosing for loop, and since this is only one for loop, we know that we want to just terminate this one for loop. So if we run this, let's see what happens. So as you can see, it does 0, 1, 2, and 3, but when it gets to 4, we break out of it. We terminate the for loop. We don't continue on, right? But if we use the keyword of continue, right, and we run it, then, well, it's going to still continue on. It's going to do 0, 1, 2, and 3, but it's not going to stop and terminate like we did, or like it did with break. It's going to continue on. So, but you see that it continue on without actually printing out 4, because, if we do continue on before printing it, then we're just going to continue on to the for loop without actually getting to this line, right? It's going to continue on and go to the next one, and the next one is 5, 6, all the way up to the end. So that's the difference between a break. A break which is terminated, while a continue it will skip that step, but it's going to continue on with the code. Now, what are these labels? Like, what exactly is a label? Well, I didn't get to show what a nested for loop was when I talked about for loops, but let's talk about it now, right? We could do a for loop within a for loop, right? We can have nested for loops, and it can go deep, right? Obviously, the deeper you go, the slower it gets, right? Like when you learn about the time complexity, you start to learn about that. And there's not a series about that. Maybe I could make another series about that, but now usually you deal with for loops, and the more for loops, the slower the application can get. But in this case, I'm just gonna make another for loop, it's gonna be a nested for loop within, and I'm gonna call this J, because like I said, when it comes to looping, I, J, X, Y, and Z are pretty famous variables. You don't have to use those variables, but it's pretty, it's used pretty often. And I'm gonna just do a simple 1 to 5, right? I want to just first. So let me just open this up. So essentially, what this is gonna do is, while I remove this, what this is gonna do is gonna run a for loop from 0 to 10, but before it can go back and run I again, it's gonna run this for loop, and J is gonna print out the range before it can go back up to the I. So it's gonna do, say for instance, let's do one loop out loud, right? So it's gonna be 0 for I, and before 0 can become 1 again, or go to the next number, which is gonna be 1, it's gonna run this for loop of J, and J is gonna go through from 1 to 5, and then once that's done, that means it's gonna get out of this for loop, and then it's gonna go to 1, and then it's gonna be 1 now. Then for 1, J is gonna print out from 1 to 5, or it's gonna run the for loop from 1 to 5, and then it's gonna go to 2, and then it's gonna continue on until it gets to the end of the range. So, but now you have some code that's being executed from within the for loop, so that's why it's a nested for loop. But just like the same thing, right? What if we want to break out of a for loop at a specific number, or continue on with the for loop when it gets a specific number? We want to skip that, right? Well, we can still do that here, but it can kind of get confusing, because it's like, what if we're in this for loop of like this J for loop, right? This nested for loop, but we want to skip I, but we're within here, right? Remember, with a break, it breaks out of the nearest enclosing for loop. So how will we reach this outer for loop, right? Or even with continue, right? It's gonna reach the nearest enclosing for loop. So we're gonna continue on with this the next number within this for loop, because it's the nearest one. But what if we want to call it from within this for loop to continue on with I, right? To skip that step of I, right? Well, we can use a label, right? So we can give this for loop on top a label, and to do that, we can just choose a label name. So in this case, I'm gonna choose loop and put an @ right? So essentially, this is saying this is the name of the label at this for loop, right? And from within this range, and I put 3 dots, that's why it's giving us swiggly, but I'm gonna put 2, and that's how you create a range from 1 to 5. And within this for loop, I'm saying that if I, right, if I is equal to 3, right, I just want to break out of it, right? But to break out of this whole thing, right, because if I do break from here, all this break is going to do is it's going to terminate this J for loop, but it's still going to continue on with the I, and it's going to go to the next I, but we don't want that, right? What if I want to go, and actually let me print that initial one just so you guys can see, right? So if I equal 3, I'm just going to break. It's going to break, and I'm going to print out as long as it's not I, right? If I is not equal to 3, then I'm just gonna print out I is, and then some string templating, and then J is, and then some more string templating. And I'm gonna make this less because I don't want it to go on for a long time, so I'm gonna make this 4, and let's run it. So as you can see, we printed out 0 because it starts at 0. The I starts at 0. We started at, and then we go to 1, then we go to 2, and you can see that it's printing out 2, and then it's doing the inner loop of J. So we see I is 2, then J is 1. It's still staying at I is still staying at 2, but it's making sure that J is gonna be 2, 3, 4, and 5. And then once that internal loop of J is done, it's gonna start the next I value. But in this case, if I is equal to 3, it's gonna break out of this for loop, like this internal for loop. It's not gonna stop the topmost for loop, right? It's gonna stop the for loop that's nearest that keyword. So break is closest to this inner for loop, so it's gonna say, okay, I want to break out of this for loop, so I'm just gonna skip I is equal to 3, right? So we see that I is never equal to 3. It's gonna skip it, and then it's gonna go to 4, and it's gonna print out everything within J for the 4 for loop. So now, what if I say, okay, I just want to stop the for loop at 3 period, right? If 3 is equal to 3, I just want to break the whole for loop, and I just want to get out of the for loop. And let me see, let me put a print out here to show you guys that I am outside the loop. And remember, we made this label, right? And what this label is essentially saying is, we have a point to jump to if we need to. So all we got to do is specify, okay, we want to break at this loop, not the closest inner loop, but we want to break at wherever this label is, right? Break at loop. And we see that this loop label, right, is at this for loop at the topmost for loop, right? This could be any name, right? This could be even be label if we needed it to, but we're gonna name it loop, right? Because it makes the most sense to me. And let's run that. And as you can see, now it does that I is 0, and it does I is 1, and it goes to the inner loop, and it does that I is 2, and it does the inner loop. But now instead of just breaking the inner loop and then going on to 4, now when it sees that I is equal to 3, it goes and jumps to this for loop at the top with the label, and it just breaks the whole for loop, and now it's outside of the loop. Now it's not even going to do 4 and 5, or it's not going to do 4 because it stops at the range is supposed to stop at 4. It doesn't do 3, and it doesn't do 4 because we're going to break out of the topmost for loop instead of the inner for loop, right? So that is how powerful a label can be. And remember, a for loop or a nested for loop could be as deep as you want it to be. So a label can be pretty important if you know that you want to break out of a loop at a specific point. So you can use a label for that. And the same thing can go with continue, right? So if we did continue, and let me just take out this label so you guys can see the action of what continue does, and let me run that. We see that continue kind of does the same thing, right? We see that it gets to I is equal to 3, and then it's gonna skip that instance of 3. But it's gonna continue on with the loop, right? It's gonna continue on to I, and then it's gonna do, in this case, 4, and iterate through the loop. But if we do continue at the loop, right? Because we know that break is used to terminate, but continue only terminates that one instance that one condition that we specify, right? But it's going to continue on with the loop because we're letting it know that we want to continue. We just don't want to do that specific instance or that specific condition that we're checking for. So as you can see, if I is equal to 3, it's not going to do 3. It's going to skip it, but it's going to continue on with the topmost loop. So break would just break, right? It will break at this topmost loop, and then it'll go outside of the loop. But continue will break at 3, or it will stop 3. It won't continue with 3, but it's going to continue on with the rest of the loop. It's still going to go to 4, and it's still going to print out the inner loop of 4. And then after it gets to the end of the range, then it's going to print out that I am outside the loop. So that is the power of labeling. That is the power of continue and break. If you just want to just stop it, use break. If you want to just terminate it, use break. But if you want to just skip that condition or that specific instance and then continue on with the loop, then you can use continue. And then you can use labels if you want to, stop at a specific for loop. Like if your loops are nested, then you can use a label and pass a label to that specific for loop. And then when you see a certain criteria, then you can use this label again to either continue or you can use it to break. And in the future, we're going to learn about return when we start talking about functions, which we're going to talk about next. So that is the power of labels, and that is the power of break and continue with labels. So hope you guys found that useful. If you have any questions, leave it down in the comment section below, and let's continue on. Hopefully you don't break. All right, ladies and gentlemen, let's start talking about functions. Well, a function or functions are used to break large programs into smaller and modular chunks, and they provide reusability, right? So we can create a function that essentially breaks our code into smaller pieces, and we can reuse those smaller pieces of code by just calling the function by its name. So to create one, we use the keyword of fun or fun, and we made that apparent in the first video that I created about this series or in this series, because we created the main function. So to create a function, you just use the keyword of fun, and then you provide a name afterwards. And functions are pretty important, right? You want to divide a complex program into smaller components to make our program more organized and more manageable. And there are two types of functions in Kotlin. There's the Kotlin standard library function, which we've been using pretty often. We've been using println for everything, and println was used to print out messages using the standard output. And then you have other functions that Kotlin provide, like even the square root, right? If you want to return the square root of a number, you just use the square root function that Kotlin provides, and you provide a number that you want within the parentheses. So that's one type of function, which is the Kotlin standard library function. And then there's user defined functions, which are functions we create ourselves. So as you can see in the example to the right, you see a function called call me, right? So if you want to create that, you'll just use the keyword of fun, provide a name of call me, and then open up some parentheses and open up the curly braces, and then whenever you call me, anything within the curly braces will be ran, right? And then we're going to talk about parameters and how to take all that user-defined information inside of the function to be used. But that's just the structure of a function, a very simple function, right? It would just be fun, the keyword, the name of the function, and some parentheses and curly braces. And if the function is only one line, you don't even need the curly braces. So yeah, that's the cool thing about functions is that exactly that. It's just so easy to make, and you can have one that you can use the one that Kotlin provide, or you can define some yourself. So now we're back in the magic place, the IDE, and let's create a function. All right. So let's do that really quick. So let's do call me. All right. Let's do fun is the keyword, call me, open up some parentheses, open up some brackets. And then we're going to use a Kotlin standard library, right? We're going to a library function, and we're going to run or print out you called the call me function. And then now to call me, all we got to do is simply use the name. So call me, open up the parentheses, right? And then press run. So call me outputted some information, but it doesn't return a value. Like, yeah, it outputted information, but it doesn't return like a 5. I can't just print out call me and it will print out 5 because it returned the value of 5, or it's not returning a string, or it's not returning a char. It's just printing out some information, but it's not returning a value for itself. So in Java, that's considered a void. If you came from Java, that void just lets us know that a function doesn't return a value. But in Kotlin, it is called a unit, right? So I can even put it, like, if you want to specify what type of function this is, all you got to do is put a colon, and you can put the type that it's going to return. But in this case, it's not returning anything, so it's called a unit. And if you hover over it, it should say unit. And even if I didn't put, specify that it's unit, you should see that it's still considered a unit, because Kotlin can see that this is not returning a value. It's just printing something out, but I can't. I'm not getting a number from this. I'm not getting a string from this. I'm not getting a char from this. I'm not getting a Boolean from this. I'm not getting anything from it. Just the fact that it's just going to do an action within it. So that is a unit in Kotlin. It's just simply saying that it's not returning a value. So what if I want to create another function, right? and I do want to return a value, I want to do something with it, right? I want to take in some values, I want to add the numbers together, and then I want to return the number. Well, I can do that. So all I gotta do is use the fun keyword again, and then we can specify a number, or not a number but a name, and I'm going to specify that I'm going to add some numbers. So, you know, like I said, just the same thing with variables, the same thing with functions. Try to give it a name that makes it make sense. Like if somebody else comes on your project or works on your application, they should know, okay, this function is called add numbers, so I can assume that it's going to, you know, add some numbers together. So try to make sense with the names, right? Like it should pretty much name itself. And I know I want to add numbers, so that's why I'm calling it add numbers. And I want to take in some numbers from the user, right? Or I want to take some numbers from the application. And what I need to do first is let, you know, the person who's going to use the function know that I'm expecting some values within the function. You know, I'm expecting values to be inputted for me to do the calculation of adding numbers. And just like with println, you see that for println to output information, is expecting someone to place a string, or expecting somebody to put a number, or it's expecting somebody to put, you know, a boolean, even if they wanted to. It's the same thing for here. I got to specify that, you know, I want someone to place something within the function for me to do something with it. So to do that, I just got to give, you know, a thing called parameters within these parentheses, and I got to specify the parameters, like what type of information am I expecting to be placed within here, and how many of them am I expecting. So to add numbers, I just want 2, and I want them to both be doubles. So I will do that. So I would give it a name, right? And I'm going to give it a name of n1 because it's just going to mean number 1, or just to make it more specific, num1. And I'm going to make that equal to a double. I'm expecting a double from the user or the application to be placed within the parentheses when I call it. So like from here, when I call the function, I want to place, you know, 2 doubles, right? It could even be 5.0. I'm expecting 2 doubles, right? And I want the user to know that. So to do that, all I got to do is specify, okay, put a colon and put the type, and I'm expecting a double. But I'm also expecting a second one, so I could do num2, and I can specify again that I want it to be a double. And yeah, that's pretty much it. Open up the curly braces because that's where we're gonna, you know, create the code using the 2 numbers that the user specified. And now I want to add the numbers. So I'm gonna create a val, and that's gonna be sum, or actually, one thing is, just like here, I specified that it's going to be a unit. In this case, I'm going to let the user know that I'm expecting to return a double, right? Because if I'm getting 2 doubles, I'm expecting the output to be a double. So unless I'm, you know, going to change it to another value, but in this case, I'm not. So I'm going to specify using a colon that I'm going to return a double. It's not going to be unit because I'm actually expecting to return something. And you can see right here, Kotlin saying, you made a promise, right? You just told me that you're going to return a double. I don't see the double yet, so I'm going to give you a red squiggly until you return a value. So let me do that really quick. Let me return num1 plus num2, and then now Kotlin should be happy, and we should be able to call that function. So right after this call me, I'm gonna do add numbers. I'm gonna give it 2 doubles, and I'm gonna give it like a weird, like 4.5 and 3.2. But you can see that, okay, it's setting 4.5 to num1, and for num2 it's gonna be set it to 3.2. And if we run this again, we should see the magic in action. And I just realized I didn't actually put a print, right? It's returning a value, but and I'm pretty sure it works, but I didn't actually, you know, print it out, right? It's just calculating it and not doing anything with it. But the result will be this. So let me just do some string templating. Put a $, open up the curly braces and put the function within it, and then put the quote, and we should be good to go. Let's run it. And as you can see, I'm not a mathematician, but 4.5 plus 3.2 is definitely 7.7. So we got the result that we expected. And we can also, if we don't want to put the whole function within a println, because we know it's going to return a value, we could just set it, you know, make a variable and set that what is being returned to an actual variable. We can even use this variable in other places if we wanted to, instead of, you know, keep calling the same function over and over again. That's just the power of functions, right? We just took math, like we just took this line, right? Instead of having to do, you know, num1 plus num2 or whatever everywhere, all we got to do is call the function. We can use different numbers each time. It doesn't matter how many times we call it, what numbers that we use. We can use that anywhere, no matter what. So that's the cool thing about functions. It takes a piece of code and it, you know, structures it, and now we can just use that number or that name that we specified, pass in the parameters that we specified, and we can just call it, and we can even assign it to variables. And now I can place that within the same paren, and I can run it, and it should return the same result. And boom, as expected. And another thing is, and another cool thing is that, you know, sometimes people can be nasty, right? Maybe if we're taking some input from a user, right? Like we did, you know, previously in this series, and maybe they don't put a value for the first number, but they put a value for the second number. That could be a problem, right? Like it's expecting two numbers, and the user didn't put two numbers, and now it's causing an issue. But the cool thing about Kotlin is that it lets you define default values. So we can, you know, specify in the parameters that, okay, we want to start with a default value of 0.0. So all we gotta do is put equal 0.0 next to the parameter, and now, so I can also do the same thing for the second one. And let me see really quick. If I remove both of them, now it's not even gonna get mad at us. It's like, wait, hold up, I got default values anyway. So if I just run this without any values, right, I could fall back on the default values, and I know that number 1 is 0.0 and number 2 is 0.0. So what would that add up to? Well, it's going to add up to 0.0 because both of them are 0.0. So if you need a fallback, if you know you have some nasty users and they intentionally want to break your code, well, you can put default values, and that could be one set of protection. Hopefully there's other type of protections, but that could be one protection. And we could also specify, like, if we don't want to put it in order, right, we can specify the order, right? We can specify the param that we're given a value to. So say for instance we want to put num2 first, right? We could do num2 equals to 4.2, and then we could put a comma and put that num1 is equal to 1.1. It doesn't have to be in order as long as you specify the parameter. So I know here it's saying that num1 is first and num2 is second, but if you put the name of the param, which you're allowed to do, right, you can put num2 is first and then num1 is second. It doesn't really matter, and you can run it and it should work as expected. Granted, this is a plus, so it doesn't really matter what order you put it in, but just for future reference. And boom, it made it a big boy though. It made it 5.3000001 precision. But yeah, you can see that it doesn't necessarily matter what order you put it in. It works regardless. So yeah, that's the cool thing about functions. That's how you create a function. And then there's the return keyword. I forgot to explain that, but it's just essentially saying that we're going to return this value of num1 plus num2, which essentially, you know, throwing that back to the function, saying you're now equal to this, right? This function is going to return this value. So cool. Hope you now understand how to create a function in Kotlin, and you know how to specify parameters, how to specify what type of information a function is going to return, whether it's a double, whether it's a string, whether it's an int, a boolean. You guys know the types. I know you guys are you know on top of these things, but now you know how to make a function. Now you know what's a unit. You know, you can assign a function to a variable, especially when it's returning a value. You know how to call a function now. So now you know the ins and outs of a function. Let's go on to the next thing. Let's continue. All right, ladies and gentlemen, let's take a look at a class. We're starting to get into that territory of, wow, we're becoming Kotlin experts. But let's learn what a class is. So a class is a blueprint for the object, and we're going to talk about objects separately, but you can think of it as a blueprint to create something, right? And the example that I like to use is a house, right? For a house, like, you can go into a neighborhood and sometimes you see a house, you know, and outside they look very similar, right? They pretty much use the same blueprint, right? But we can create many versions of that house using that one blueprint. So you can think of a class like that. You can think of it as a blueprint to create an object. Now, it could be any object. It could be a house, it could be a skyscraper, it could be whatever, but at least we have a blueprint that we can use, or if we need to adjust it, we can use that specific blueprint to create an object. So Think of a architect, think of the blueprint that they have to create a house. Think of a neighborhood that have similar houses, but doesn't necessarily mean that all the houses are the same. They can have a different amount of doors, they can have a different amount of windows, different amount of bedrooms, but essentially they're still using the same blueprint. So think of it like that. A class is a blueprint for the object. So let's take a look in the IDE on how we can create a class for the creation of an object. Now we're back in the IDE, and we have this function of main, but it's not in a class. So let's actually create a Kotlin class. So let's go into this Kotlin folder that's holding main, but we're going to right click Kotlin. We're going to hover over new. We're going to click on Kotlin class / file, and we're going to leave this under class, because before we use file, but in this case we're going to use class, and I'm going to call this house because I just talked about house. I thought it would be a great example to use. And you can see that the IDE creates a class for you called house, right? So all you need is this keyword of class. Essentially, it's letting us know that it's a class, and then you give it a name. In this case, we're using a house. Usually, the name is capitalized. So then we're going to open up the curly braces, and we're going to start defining properties of the house, right? We're going to start defining some of the things that make a house, right? The properties that make a house. So one property that make a house is the number of bedrooms. So and let me put the comment down, right? So we could create a class. What it tells a class is properties, right? What is properties of the house, like the doors, the windows, all that good stuff. What entails, and what does the object entails, right? And then there's nothing that is included in a class, which are member functions, right? These are things that define an action for the class, or when creating the object, what defines an action for the object. So in the example of a house, right, we have doors, right? So we need to open the door, we need to close the door, or say for instance we have a specific color of the house. Let's paint the house. That's an action, right? We can create a function that changes the color of the house, or we can have a function that closes the window of all the windows in the house. So these are member functions that define actions for the class in this case. So yeah, that's properties and that's functions. So let's start defining some properties within the class. And one that I want to define is, I want to define a color. I'm just going to make an empty string for now, and we can specify that as a string. But by default, it's going to be empty. Or we can define blue if we wanted to. Like if you want a default value of blue, cool, the house started at blue. That's fine. Or if it starts at white or beige, whatever you want to choose. And then you can have another variable called amount of doors. And the reason why I make it a var is because color can change, right? It's not something that's forever. Even the amount of doors can change, or the amount of bedrooms can change. You can add a bedroom in the back, or you can add a windows if you wanted to, if you break down a wall. So sometimes for certain things you make them variables, but these are things that you have to think about when you create a property. Certain things might be a val, meaning that they stay constant, but for the most part some things can change. So you have to think about whether it's going to change or it's going to stay constant when making that specific object using this blueprint or using this class. So let's think of the amount of bedrooms. All right, that's important, right? And initially that's going to start as 0 for me, because I know that this is a blueprint, or I'm gonna make it 0.0 actually, because remember, there's some bedrooms that can be, it could be, or actually no, bedrooms I'm gonna make it 0, but when I'm thinking about bathrooms, I'm gonna make it a double, because I know there could be 2.5 bathrooms, or they could be 2.5, or it could be 3, or it could be whole, or it could be a decimal, because of the fact that some bathrooms are considered half a bathroom, or 0.5, because of the fact it doesn't have certain functions that a normal bathroom will have. So some bathrooms may not have a bathtub in it, so it's considered half a bathroom instead of a full bathroom. So those are other things that you got to think about when creating your properties of certain things. So for a house, you got to think about that piece of like, okay, there can be half a bathroom, so we should make this a double instead of an int. So in this case, I'm going to specify that I want the amount of bedrooms to be int, but when I create the amount of bathrooms, then I want to make it a double, and I'm going to start it off at 0.0, and I got to spell double properly. And there it is. And then there's member functions, which I'm, just there's gonna be functions that define an action for that specific class. So in this case, I want to change the color of the house. So I can create a function from within called change color, and I can take in a value, right, or a new color, and that could be a string. And then I'm gonna open it up, and then I can make sure that color is now equal to new color. And this is gonna not return anything, so it's gonna be a unit. But you can also specify. You also don't have to put unit, like you can all it's inferred by Kotlin. But yeah, that's just one thing. So now, when I create a house, I can change the color using this member function. So instead of it being white, I could be like, okay, on the creation of this house, change the color to red or change the color to blue. And the same thing, like if you, and we're gonna talk about visibility modifiers later. Essentially, if you want to hide these properties, which we can do, like you don't want the user to be able to modify these directly, you have to use a function to modify it, and you can have some logic to do some checking on whether it's proper or not. You can do that as well. So that's gonna be later on in this series. I probably just confused you a bit, but yeah, this is how you make a property in a class, and this is how you create functions within a class. They can be used to do actions for the property or for the class. So in this case, if we want to change the color, we could do that. If we want to change the amount of bedrooms and bathrooms while construction is being done, you can do that as well using a function. And right now it's wide open, meaning that I could just directly communicate with color, amount of bedrooms, and amount of bathrooms using just a little dot notation, because this is wide open. Right now it's public, which we're going to talk about that soon. But in the next portion of the video, we're going to talk about visibility modifiers, which we can hide this information. So hopefully that makes sense. Let's continue on, but I'll be back soon. So I started talking about visibility modifiers a little bit in that class video, but let's dive in a little bit deeper, right? So visibility modifiers just mean essentially how visible is things within your application are going to be, right? So how can they be accessed? So there's a series of visibility modifiers that can either protect or not protect your code, or hide or not hide your code based on the modifier that's being used. So the 4 modifiers that are in Kotlin, are, and the first one is private, which by the name implies it's private, right? It's only visible, or can only be accessed from within the class only. So if you're from outside the class, like we just created a class called house, right? And we created a house class with properties and functions within the class itself. Only, they can only communicate with each other from within the class, but anything on the outside, if we have another file, it cannot directly communicate with whatever is private from within the class. And we're going to see an example of that, but just know that private can only be accessed from within the class only. Public can be visible everywhere, just like like usually, like public is usually public, right? Anybody can see it. It's visible from everywhere. Then there's protected, which is visible to the class and its subclasses, and we're going to talk about inheritance later on. But just know that protected just means that it's visible to the class, just like private, and to its subclasses. So you can think of it like, you have a parent and you have a child, right? The child has access to whatever the parent has. So that's essentially what a subclass is to a class. It's like a parent-child relationship, right? And like I said, we're going to talk more about that later on when we talk about inheritance. But just know I got a little piece of private to it. So it's not exactly public where everybody can see it. It's protected, right? And then there's internal. Any client inside the module can access it. So by module in Kotlin, we mean a group of files that are compiled together. So these are the 4 visibility modifiers, right? Now, depending on how secret you want to be, or not secret, or just subtly secret, depends on what modifier you use for your code. So that is visibility modifiers. All right, so we're back in the IDE, and I want to use what we just learned, right? I want to use the visibility modifiers to change the information or hide the information from the outside. So what I'm gonna do is I'm going to go here in color, because like I said, I don't want everybody to have access to it. Like if I'm creating a function to change the color, why would I want anybody to just be able to change the color? Because right now it's public. Anybody has access to this variable. They can change it if they want to, but I want to make this private. So to make it private, all you got to do is put the visibility modifier name in front of it. So private goes right in front of this variable declaration. And now this is private. Now I can't just be accessed from anybody. Now to change the color, I literally have to call this change color function, right? I'm gonna leave this public for so that the application has the ability to change the color, because remember, if we want to change a property that is private, it has to be within the class. So I know I have a function here called change color that's within the class, so I know I can change it from within. But if I make this function private and I make this property private, that means there's no way that I can change the color. So if you want no way of changing the color, just make everything private. But if you want a way to change the color, then we can have a public function, all right, and keep the variable private so that it's not publicly accessible everywhere, but we have at least one way of changing the color, and only one way. And so now that we have the class itself, right, we made a color private, we made a function to change the color, let's actually see this in action. Let's actually create an instance of this class, right? Essentially, let's see this creation of this house and use this blueprint to create a house, right? We're going to create an object, right? And this object in this case is a house, an instance of a house. So let's go back into our main function and create a house, right? So let's create a mansion, right? A mansion is still a house, by the way. And we're going to make this a val, and we're going to call this a mansion, but it's going to be a house, right? A mansion has the same properties or similar properties of a house, right? It has a bedroom, it has a bathroom, and it has a color, right? I would hope it's not transparent. But now to create a house based on the blueprint that we created, right? We created a blueprint with all the properties and a function, right? A member function. Let's actually make that equal to the creation or instance of that blueprint. So we're going to actually use that blueprint to create one. So to do that, all you got to do is use the house name, open up some parentheses, and boom, that's how you create a house, right? It's created now. And now with that created, now mansion is now equal to a house, and we signify that this mansion is going to be holding an instance of a house, right? So we explicitly set it, but we don't have to. Just like it says, right, it's explicitly set, but we don't have to. So we can let Kotlin infer it, and that'll be fine as well. But now that we have an instance of a house, now with the variable mansion, we can use dot notation and see what we have access to. So we see change color, which, like I said, is this function right here, and it's public. So if we want to set color equal to new color, we can use new change color, and we can pass a color to it, and let's say we call that blue. But now we know that mansion will have a new color, or we'll change that color to blue. And then we have amount of bedrooms and amount of bathrooms. Those are still public, meaning if I go into mansion and I use dot notation meaning I use a dot right after the name, and I should see what's inside of it, right? Or what I have access to. And there's a series of functions that I have access to, because by default Kotlin gives many functions to an object. But the ones that we created, the properties that we created, and the functions that we created, we can see the public ones. So amount of bathrooms and bedrooms is right here. So I can get the amount of bathrooms, and I can set it equal to a new value because it's public. Everybody has access to it, and I can say that this is a mansion. So let's say, mansion usually has an outrageous amount of bathrooms. So let's say it has 10.5 bathrooms, and let's get the mansion's bedrooms. And usually with a mansion, the bedrooms will match the bathroom. So we'll just say that it has 6 bedrooms. So now we have changed the color. We have a different amount of bathrooms compared to what we started with, because remember, before we started with 0 for the amount of bedrooms and 0 for the amount of bathrooms, but now we're setting it equal to 6 and 10.5 because they're public, we have access to it, but we couldn't see color. Remember that we had to change color using a function. All right, so let's see if what we're setting and what we're changing the values to actually work. So let's use a println, and let's see, okay, the house, and because the color is private, we don't even have access to color. So what we could do is we could create another member function, and we could call this get color, to be honest with you. And we're going to set that equal to a string. And because we're not setting anything here, we can just remove the parameter, set this to a string, and then return color itself. So what it's doing is it's a function that's going to allow us to get the color. It's just, with this is going to return a string because color is a string, so we just return color. So let's go back over here. House, use the string templating. Mansion, or actually I keep saying house. It is a house technically, but let me put mansion. And let's put properties, and then put a colon, and then it's going to be mansion dot get color, and then bedroom. I'm just going to put bedroom as short so it does not go completely off the screen, but I'm going to do mansion dot amount of bedrooms. Let me see if I can put this on a new line. Yeah, I could. And it's gonna be bathrooms, and I'm gonna make that short as well, and I'll put a colon, and then the mansion dot amount of bathrooms. So boom, now we're getting the color. Because it's private, we had to make a function that will allow us access to that specific color, that will allow us to get the color, right? Because we don't have direct access to the property like we do with amount of bathrooms and bedrooms. And we, just to let you guys know, it is a good convention to make it private, so you should still make the amount of bathrooms and bedrooms private, but just to show you guys what happens if you make it public. You will see that you can change it from anywhere, which is not good convention. So make everything private whenever you do make a class, unless you want it to be public. And then to get the color, since we don't have direct access to it, we have to make a function to get it. But since we have direct access to the variables here, we don't even have to do it. We could just use dot and the property name like we do with the bedrooms and the bathrooms. And let's run this to see if it's actually creating the mansion how we expect it to create it. So as you can see, I see mansion properties. The color is blue. The bedroom is 6 as we specified here, and the bathroom is 10.5. So as you can see, we define properties, we create a function, or we made the visibility modifier for the color private. So we had to create some member functions to do actions, right? To either change the color and to get the color. And the ones that we left public, we're allowed to change, just by asking for it, right? Which is not good convention. But just to show that, what happens if we create it public or we make it public, we still was able to change the amount value, and we're actually able to retrieve it or get it and print it out. So that's how you create a simple object using the class blueprint, right? We created a class blueprint of house, and we use it to actually create a house or actually create a mansion, and we define some properties and functions or actions for it. So we're going to go over a little bit more on what an object is, but this is a very simple use case of it. And also, you can also use multiple ones. So if you wanted to make another mansion, just go down below here, make a mansion number 2, and now we're good to go. We can start defining properties for the second mansion if we wanted to, using the same blueprint but just different values. So that's just the power of classes and objects. Alright, so we learned about classes, we learned about objects, we created an instance of a class, which is an object of house. We created a mansion variable to hold the house because we were creating a mansion, right? And we changed the color, we created some member functions for that house, and we created some properties for that house. But now let's talk about constructors, right? Because before, what we had to do was we had to use dot notation to set new values for the bathroom and the bedroom, and to change the color we had to use a member function. But what if there's a cleaner way of initializing values of an object, right? Well, there is. So let's talk about constructors. So a constructor allows us to initialize class properties on the creation of an object. There are two types of constructors. There's the primary constructor and there's the secondary constructor. But we're going to talk about the primary constructor first. So let's create a new class. Let's go into this Kotlin folder. Let's create a new Kotlin class, and I'm going to call this class person, right? Because we're going to make a blueprint for a person, right? So like I said, a primary constructor allows us to initialize a class or create an object in a clean way by allowing us to pass in properties or initialize properties on the creation of an object. And to do that, we have to create a primary constructor, And to create a primary constructor, all we got to do is go into the class, go to next to the name, and after the name, open up some parentheses. And within this parentheses, we're going to start defining the properties of the person. And this is where the primary constructor is, right? This parentheses is the primary constructor. So now when we create an object, we're going to inject the same parameters that we're setting here in this parentheses is going to be the properties that we're going to assign or pass to initialize the properties that we're creating here, right? And there can only be one primary constructor, right? That's what's called primary constructor. Is the main constructor. So we can only create one, but when we start talking about secondary constructor, we can create multiple. But let's focus on one thing at a time. So primary constructor, what makes a person? Well, when I think of a person, the first thing I think about is, what is your name? So I'm going to make this first name a val, which I'm just saying that once you assign me a value, you can't change it, but I'm going to make that a string. And then the second thing I think about is, what is your last name? And usually when you get married, you know, your last name changes. So I'll make that a var, and I'm going to make that a string. And the third thing I think of is, how old are you? And, you know, usually age is int, because I don't think about, oh, this guy is 23 and a half, or this woman is 25 and a half. No, it's you're 23 or you're 25 until you turn 26 on your birthday. But these are some properties that I want to define a person, and that's what I expect the application or a user to pass in when they create a new person. So this is how you create a primary constructor. That's how you pass in properties. And when you're thinking about, you know, making properties for a class, think about, you know, whether like how I just thought about it. Okay, what makes a person? Is this person allowed to change their name, their first name, their last name? Is the age going to change? These are some of the properties, or this is how you think about creating properties for a class. So now let's actually create a person. So let's go back to the main. Before we had mansion. I'm just going to erase all of this. Remember though, we had mansion, but we had to use dot notation to, you know, pass in values to those properties. But now let's make a person. So delete that, and it's going to be file person, and it's going to be equal to person, and open up some parentheses. And now you see a right squiggly, because we defined some properties for this person, it's expecting us to pass in values for the parameters that we just set, or for those properties that we just set. So let's do that really quick. So let's do the first name, which is going to be Geo. Let's do the last name, which is going to be Doe. And then the age is going to be 40. So now we have properties assigned to person. Now we're able to do, or let's print it right now, println, and let's get the property, right? Because we could do person now, and we can see that all the properties that we set first name, last name, and age. Let's get the first name, and let me print that out. Now, as you can see, it is now showing Geo because we set the properties from the primary constructor, and we assigned it, or we initialized it when we created the object. So now it's able to see all the information that we set right away. So we see that Geo is the first name, last name is Doe, age is 40. So person, our first name, we can still use dot notation to get it. So first name is going to be what we assigned it. And if we want to set it, we can still set it. So if we want to do person dot last name, and we want to name it as I don't know, let's give him two first names as the last name, right? So it's going to be Geo Jim, and let's say that his birthday passed, right? And his age is going to be equal to 41 now, right? Happy birthday. Let's print that out. It's a person dot age, and run it again. Boom, we can see that Geo is the first name, which we printed out initially, and then now we set a new value of age, which was originally 40. We set it to 41 and printed it out, and we see that 41 has now taken its place. So you're not restricted to just, you know, initializing it and that's it, right? Or maybe you want to initialize it, right? And before we talked about visibility modifiers, maybe we want to hide this right after we initialize, right? We don't want the user to have access to these properties after initialization of those properties, right? So we can still make these private, right? By default, it was public, but now we can make it private. So the nature of private is that it is you know, only accessible within the class, right? So if I go back to the main, we're gonna have some problems. We're gonna see red swigglies everywhere because it doesn't like that. But Kotlin still allows us to write code within this class, or we can still define properties within this class. So yeah, we're taking in properties from the primary constructor, and we're able to use it like we did in main. But say for instance we want to just allow the the application or the user to initialize, but we don't want them to retrieve the properties that they pass to the parameters or pass to the primary constructor. We can still create properties here, which I'll do, and I'll call the first one fname, and I'll make that a string, and I'm gonna make that equal to an empty string, and then there's gonna be last name, or I'm gonna call this L name, and that's gonna be a string. I'm gonna make that also an empty string, and let's make this also for I'll just call this inside age, and then I'll make that an int, and I'll make that equal to 0 for now. But we're still able to do that. We're still able to make properties inside of the class, and we can still use these these properties from within the class. And another cool thing about Kotlin is this thing called Init, and I like to think of it as initialization code, or initialization block, really. And what this is going to allow us to do is it's going to allow us to use the keyword of init, open up some curly braces, and right after the primary constructor is ran, or right after it is initialized whatever parameters that the user passes in or the application passes in during the initialization of the object or the creation of the object, we can run whatever code that we place within these curly braces, right? This is going to be the initializer block, right? It's going to allow us to essentially initialize properties, but we can also write other type of code within these curly braces. So if you want to print out anything, or if you want to create something, that can be done from within here. So what I'm going to do is, yes, we made these variables private, right? And we're not allowing the users to access it, but we can take the values of first name, last name, and age and pass it within this initialization block, and we can assign those values to these properties that we created within the class. So say for instance we have fname, we can make that equal to whatever the user or the application passes through the primary constructor by making it equal to the name, the first name that was passed. And you're probably thinking to yourself, what is the point of this, right? Why are we making this private, and why are we making this open or public, and just assigning it to each other? Why not just make everything public and just allow the user to retrieve it from the beginning? But another thing that is awesome about the init block is, like I said, you can run code from within here, right? With the primary constructor, you cannot run code, but with the init block, you can. So say for instance, you're making this class for it to communicate with the database, right? We want to store information regarding a person to a database. Well, we can make sure that first name, when being initialized on the creation of the object, is in the structure that we expect. So say for instance we want first name, or all first names, or all names to be lowercase before being placed into the database. Well, we can do that here, right? We know we're getting this first name, but we don't know if it's lowercase yet. But to make sure that it is lowercase, well, we can go into this init block, right? We can open it up. We have this property called fname that we're going to assign a value to, and we're going to make sure that the first name that was passed is lowercase by using a method that is provided, right? We could use dot to lowercase, and I see that it seems like it's deprecated. It doesn't seem like Kotlin likes that anymore, but let me see what they recommend. All right, so it's showing a cross through, and I'm just going to replace it with whatever they recommend. So in this case, it should be dot lowercase and local dot get default. So I guess that's fine. And I'm going to do the same thing for last name. So let me actually just copy this method really quick, and then I'm going to make L name equal to L, or last name, and I'm going to just paste the same thing that I did with first name. So now I know that whenever I pass in or create a person with first name and last name, I want to make sure that before I put it into the database or wherever I'm going to use this object for, that the first name and last name is lowercase, and I'm assigning it to a new property of fname and lname. So I can go back and double check that. We see that, yeah, it's showing a red squiggly. It doesn't like the fact that we're trying to access something that's not open to the public. But now that we created some new properties, we can use fname, and I'm going to take that out because we're using the primary constructor to assign the values. And then I'm going to see, okay, what is the L name, right? And let me run that really quick. So as we can see, it is Gio with a lowercase g, different from the uppercase one here, and last name is now lowercase d as well. So yeah, that's what we can use the init block for. We can use it to get the properties internally, right? We can block out them having access to the properties that we pass from the primary constructor, make properties internally, and then use the int block to run some code on the properties that was passed through the primary constructor using properties that we created ourselves, just so that we can have more control, right? And we still have the ability to make these private as well, right? Maybe we don't want this also as well to be accessible from the outside, right? We can still make this private, change what it is internally, and if we need to make another member function, right, create some member functions, and we can make a function to get the first name, right? And all that would do is return fname. That could be done as well. So there's a lot of ways. Let me see, and you gotta make sure that this is a string. All right, cool. And yeah, that's a way that we can help make sure that everything is hidden, but at the same time we still have access to it. So there's many ways you can go about it, and just how we did get, we can also make a way of creating another member function to set, just like we did with colors, right? So there's many ways that we can do this. Set, take new name, make that a string, and then fname is now equal to new name, and then it will return fname. So there's a lot of things that we can do within it. We can make the primary constructor private, we can make the internal properties private, and then we can initialize it to make sure that we pass those values to the properties that we made, and then we can make some member functions to have access to it or to set new values. And if we want to block out certain strings within these setters or getters functions, right, then we could do that as well. So there's a lot of control that we can do with these classes and objects, and even with these values, right? Say for instance the user doesn't, say for instance for some reason the user doesn't pass what they need to, right? We can set up default values for these properties. So if we want to just make it an empty string as a default value, or maybe we can literally just do capital John and capital Doe and set the age equal to 0, we could do that as well. That's no problem. And then if we go back to the main, right, and remember we made them private, but I'll use the function that we just created, right? I'm just gonna erase this last one, and then I'm gonna do get first name. I'm not even gonna put any values in here because I have the default values. I don't have to. It sees that, okay, you don't want to put a value, well, I'll just use the fallback values or the default values that we set. And if I run this again, we'll see the init work in action, and we'll see what we're able to retrieve, because everything is private. So we're gonna have to rely on the member functions to get the value from the object. So as you can see, it's returning John. If I go back to the class, we see that, okay, a user didn't pass any information through the primary constructor, but if we go back, we have some default values, and the default value for the first name was John, the last name was Doe, the age was 0. They're private though, but the one that we do have access to using the member functions is the first name. But remember, when this was initialized to the primary constructor, what's ran after the primary constructor is the init block, right? This is what we can use to change up the properties or initialize some code if need be. And what we did with the primary constructor values is that for first name and last name, I take the lowercase values, because when I store into this database, or when I store into wherever I need to store this information, I want the first name and last name to be lowercase. So I make sure to do that within the init block. And then when I need to get that information after, because like I said, init block is run after the primary constructor, and after that I'm actually to get the first name, and after this init block is ran, the name is now lowercase, so now John is lowercase. It started off as uppercase or all capitalized, and now it's switched over to lowercase within the init block. And whenever I get the first name, it's all going to be lowercase. So that is the power of the primary constructor and the init block. And like I said, we reverted back to making everything private to make sure that all our information is hidden, or certain things are hidden, and using some of the member functions to retrieve from it. So that it all came full circle on how we can make a class, use visibility modifiers, use the primary constructor, use the init block. And now let's talk about the secondary constructor. Alright, so we went over the primary constructor and we went over how to make the init block and how to access information after utilizing the primary constructor, or even not even providing information for the primary constructor because of the default values. But now it's time to talk about the secondary constructor, and let's create a new class to go over it. What I want to do is I want to create an error logger, right? So essentially I want to create a log for whenever there's an issue with the application to log a message, so that I can see what's going on. So I'm going to create a new Kotlin class. I'm going to call this error log, and I'm going to press enter. And here what I want to do is I want to utilize the secondary constructors to create an object, right? So the primary constructor, we were used to utilizing open parentheses right from the header, but for the constructor we don't do that. We go within the curly braces and we use a keyword called constructor, right? And you open up some parentheses here, and what we want to do is pass in parameters within these parentheses that we can pass in to create the object, right? So we want to make sure that when we utilize this class to create an object, we got to pass in a message, right? And we want this message to be a string to define what type of error that this is going to log out. And we're going to open up some curly braces after utilizing the constructor keyword and specifying a parameter, and then we're going to write some code within here. So you can write code in here, and we have access to the message that the user is going to pass when creating the object. And I'm going to create a property within here, within this class, called error message, and make this a lowercase e, make this a string, make this a default value of an empty string. But then when the user creates this object, I want to assign error message to equal to the message. Now if you want to have a checker prior, like we can check the structure of the message before even assigning error message to message, but in this case I'm just going to assign a message to error message. I'm just going to do happy path, right? Everything is okay. Now the difference between a primary constructor and a secondary constructor is the fact that with a primary constructor we could only create one of them, but with a secondary constructor we can use multiple, or we can create an object with multiple secondary constructors, right? So there may be cases where we have an error and we only have one message, but there may be a case where we have an error and we have a code and a message. So if you ever utilize an API, or if you ever went on a website and it's down, you've probably seen a 400 error or a 404 error or a 500 error because the backend is not working. Well, that's the code that's being returned from the backend, and there's usually a message with that, right? So maybe in one case we may not have the code, so we're just passing in the message, but there can also be another case where we have the code and the message, so we can create an object that utilizes or can be initialized using the code and the message. So we're gonna create another constructor or another secondary constructor, and we're gonna utilize the code because we actually have, or there are actually cases where we have the code and we have the message as well, and that's going to be a int for the code and a string for the message. And we're going to open up the curly braces, and now I'm going to make another variable called code, and I'm going to make that an int, and I'm going to make that equal to 0, and we're going to do the same thing that we just did. So we're going to make error message equal to message, and we're going to make code, and let me make this error code, or it could be code, and we can just say this dot code, essentially saying the code that belongs to the class, right? This instance right here is equal to the code, right? That's being passed through the parameter. So if you don't want to change the name to whatever you want it to, this way it doesn't match to the parameter, you can do that, or you can make sure that this right is talking about the property that belongs to the class is equal to the code, which essentially is the one that is coming from the parameter. Whatever works for you, right? You can change the name, or you can use this to signify that it's the one that belongs to the class. And yeah, now we have two ways that we can initialize an error log. So if I go back to main, and I'm going to take this out, and I'm going to call this error log, and I can see it here, error log. I'm going to make this of type error log, and it's going to be equal to error log. But now we can initialize it using two ways. We can pass in just a message, or we can use a code and a message. So that's just the power of a secondary constructor. Now we don't have to just use one way using a primary constructor. There are various of ways that we can create an object. We can use just one way, or we can utilize two parameters. So let me show that. So there's one way using a message, and then there is a second way, and then we just call this error log 2, make my life easy, and we're going to pass in the code. So like I said, it could be a 404 error, and using an error message. And now since it's public, we could always go in and do println error log. Or actually, let me go in, right? We're using a constructor, there's curly braces, we could just print it on the creation of the object. So let's do println error message, and then use string templating to print out the error message, and then do println here, and error message is going to be error message, and error code is going to be error, or it's going to be code. We'll do this.code. So now when I create the object, right after it assigns the values to the internal properties, it's going to print out the message and the code, and for the first constructor it's just the message. So it depends on which constructor I'm going to be using when I'm creating the instance, right, of the object. So let me run that. So boom, as you can see, the error message is using an error message, or using a message, and the second one, you can see that it's printing out from the second constructor, right? It's printing out from the second constructor. The error message is using an error message and an error code 404. So that's just the power of secondary constructors. We can, have multiple ways of creating an object, and I call this constructor overloading, because we have multiple constructors, and all we got to do is make sure that we're not using the same amount of parameters. Because if we're using the same amount of parameters, it's going to be like, hold up, you have another constructor that has that same type of structure. But if we continue to keep adding parameters, then we're good to go. Because then right here we can have another parameter called resolution, and we can make that a string. And now we have another parameter that we can use. We can either print that or use that directly, or we can create another property for that to hold resolution and do some logic with that. But now we have another constructor, and now we have another way of creating this object. So that's just the power of secondary constructors. And if we want to, you can also create a primary constructor while using secondary constructors, and even use the init block if needed, right? We can still use init, like you're not restricted to just using secondary or primary. So we can create a primary constructor right here, and I'm gonna say let's do, like, I guess date, right? So I'm gonna do, or time, right? So let's do a val, and then I'm gonna make that equal to a date. We could use a date type, but I'm just gonna use a string. But now, because we have a primary constructor, it's gonna expect for the secondary constructors to take in that date, and we have to pass, whenever somebody uses a secondary constructor, we have to pass that date to the primary constructor. So we still have the responsibility of using the primary constructor if we want to use a primary constructor with a secondary constructor, right? We could choose not to use the primary constructor, but if we choose to use a property within the primary constructor, even when using a secondary constructor, we have to pass a value to the primary constructor. And in this case, it's saying like, hold up, wait a minute, hold up. It's saying we have a case where in these two matches, right? This is a date and this, but it's a string, and this is a message and it's a string, so there's a conflict anyway. We would have to use date, right? We would have to use another type so that they don't overload against each other. But then in this case, like I said, you still have to pass a date to the primary constructor. So that means it would require a value to be passed to the primary constructor. And to do that, what we had to do is use a colon, use the keyword this, just like how we did below with this.code. It's just meaning that this is, this is gonna assign a value to the primary constructor. It's essentially saying this, like this class, this primary constructor, we're gonna pass a value to it. So we need to pass a date. So I'm just gonna use a new date in this case each time. That should work. Or if we're taking a date as a parameter, like say for instance we had a constructor and it was dates and dates, we can just take that and just pass it to this primary constructor. That's essentially what it's saying, that this primary constructor, we're passing that value to here. Same thing, but in this case I'm just going to make sure that every single time somebody utilizes this secondary constructor, we're going to create a new date. Essentially it's going to say that at this time, like at this current date, the error log was created. So that should be fine, and we have to do it for each one of these, right? And even for this, like for this one, I'll put resolution date, and I'll make it of type date, and I'll open it up with a colon, use this, and I'm gonna make sure that resolution date gets passed. Let me bring it to the new line, make it easier to see. Resolution date, and essentially it's saying, all right, the parameter that we're passing through this constructor called resolution date, we're going to pass it to this primary constructor. So now date here is going to be the resolution date. So if you want to utilize the primary constructor with the secondary constructors, you can, or if you want to use it by itself, you can just remove the primary constructor. Or if you want to change the primary constructor values or initialize something prior to even getting to the secondary constructor, you can utilize the init block. So there's a lot of things that you can do with the primary secondary constructor and utilizing the init block. So that is the primary constructor and secondary constructor in Kotlin. If we go back to main, it's the same thing. Or if we want to make an error log 3, we can go down below here, call it 3. I can pass in a new date, right? And I got to import that. Right? It's dates. It's coming from the Java util library, and then I can print ln. And now that I have access to the error log 3, right? And I didn't make anything private. Remember, you can always make all of these private and create member functions for it if you want to. I didn't for the secondary constructor, but it is still possible. But if you go now, you can see that we have access to the date because of the primary constructor. And I can print that out and let me run it really quick. So boom, as you can see, the current date at the time of me, doing this is June 17. And you can see that I'm able to print that out because I passed in the dates as a parameter. And I'm able to get .date because if I go back to error log, that is the property that is here. If I made this private, right, I wouldn't have access to it, right? It's saying no. But because I made it public, right, I have access to it, and I am passing that date, right? Because if I go to the secondary constructor, right, it's initially, let me see, it's initially the resolution date, but I'm passing this, meaning like this class, this primary constructor, I'm passing the resolution date as that date. So hopefully that makes sense. If you have any questions, leave them down below. But that is the primary, secondary, and if you want to use the init block, we went over the init block as well in the primary constructor section. So hopefully that was helpful. Alright, so we went over how to create a class, we went over how to create an object or initialize an object using the class. And we also talked about the use cases of, creating a class and creating an object, and hopefully interacting with things like a database, like storing information that we created the object for, like a house or a person, right? But Kotlin has a special type of class that we can use to essentially hold data for those scenarios, and that class is called a data class. And a data class is just, like I just said, it's used to hold data, right? And it has pretty amazing methods that come with it right out of the box. So in this portion of the video, we're going to be going over how to create a data class and going over some of the methods that make it so useful. So hypothetically, we're going to be making a data class that will be holding information regarding a user. So let's right click on Kotlin folder, let's do Kotlin class, let's scroll down to data class and create one called user. And then now you already see a little bit of the difference is that the first thing that we see is the keyword of data in front of class, because it's essentially letting Kotlin know that this is a data class and the name of it is user, and it opened up parentheses because we're going to start defining some of the properties of this data class. And it's already saying that a data class must have at least one primary constructor, so we have to use the primary constructor. And within that primary constructor, we'll start defining some of the properties that this data class will hold, right? So the first one is going to be ID, because hypothetically this is going to be used for a database. So to make it unique, we have to have a primary key, and you don't have to know anything about SQL or anything like that, but just know that this is going to be identifier for the person, right? And this is going to be a long, and then the second thing that I think about when thinking about a user is a username, right? So I'm gonna make that a string, and then I'm gonna make that a var because I want it to be changeable. ID can be valid because I don't want the person to change their identifier, and then I'm gonna make the last one age because I want to make sure that the person is old enough to do whatever that we're gonna be doing with this application. So that's gonna be a short. It doesn't have to be an int because we don't want to make it too big. It could be in byte as well, but maybe someone might get lucky, right? So we'll make it a short just in case, and then yeah, we're good. Now we have a user data class. Now we can go in and create a user really quick. So that's gonna be user equal user. We have to pass in the parameters that we just set. So ID is gonna be, this is the first user, so I'm gonna pass it 1. The username is gonna be Geo, and then the age I'm gonna put is 40. And then now we have utilized the data class. Now we have a way of holding information, and that was much faster than creating the normal class, right? But that's not what makes a data class a data class. Yes, it holds information, and that's great. That's one of the properties of it, but it's the fact that a data class has so many useful methods that we can use because of the nature of it. So let's do println really quick, right? Let's print out user, right? If you ever try to print out a normal object that's not utilizing a data class, it's just utilizing a regular class. When you print out an object, right, the instance of the object, it's usually like some type of gibberish code, but in this case, and let's see this really quick. The data class has a toString method, right? And with the toString method, it will allow us to see what is going on within this object, like what information that this object is storing in a very nice manner. So in this case, we see that user has the ID of 1, username is Geo, age is 40, and that's a complete difference compared to using a regular class that is not a data class, because if we just print out a regular class, it'll be some type of gibberish. I can see that. I can show that really quick. So let's do var or val, quick house, and that's just going to be utilizing a house class that we created before. No parameters are needed, but if I print out house right after this and I run it again, we'll see the difference. So boom, as you can see, there's some hash code with it. It's house at some type of hash code or some code at the end. But with a data class, you can see that with the toString internally, is essentially going to put it in a format that we understand and that we can see what's going on within the object itself. So that's the difference right there. That's one difference between a regular class and a data class, right? It comes with so many useful things that we can do. Another useful thing is, say for instance we have another user, right, and the username is, you know, different and the ID is different, but the age is the same, right? We don't feel like creating a whole new user, you know, like we did before. We could just simply do file user2, and we can utilize another method that comes with a data class. You know, that's one of the properties that it holds, is the copy method, right? It just as the name implies, what it does is it will allow us to copy another object, right? So right now we have this object of user that's holding an instance of, you know, this user of, you know, Geo, and now we can create a copy, and if we need to change anything we could. So all I want to do is change the username, because I'm assuming the username will be unique, so they can't have the same username. So we can do Geo1, and then the ID has to be different as well, because if it's an identifier, it has to be unique as well. So we'll just make this ID 2, but the age is the same. So if we print that out, we can see that we're able to make a copy of the user without having to create a whole new user like we did above here. So as you can see, I made a whole copy of user, but I changed the ID and the username, but the age stayed the same, right? And that could be useful. In this case, you probably think it's useless because we had to change 2 of the 3 properties. But imagine, as you know, these objects, or as these classes get bigger with, you know, more properties, it can be useful if you have matching you know, properties already. Like, you only have to change a couple things, but you have so many other properties that it's probably easier just to make a copy, right? That's one case, and I'm pretty sure you can think of another. But another useful thing that we can use with the data class, or another property, is the component end functions, which is going to allow us to retrieve the properties within the data class easy, right? So before, what we had to do to get information from an object is we got to use dot notation, right? We have to do user, and we got to, you know, do dot ID, and then another line we have to do user dot, you know, username. Like, you would have to do it one by one, but with data classes we can, what I like to call it is destructure the properties from the object. So and that's using the internal component end functions. So what this will do is, now we can just, you know, create a variable, open up some parentheses, and start defining what are some of the properties that we want to extract from the data class or from the object. So I know that this object has ID, username, and it has age. So I want to retrieve the ID, the username, and I want to retrieve the age from user, right? And what this will allow us to do is, now we have 3 variables that we can utilize for whatever we want to do that is being extracted from user, right? We don't have to do it on a line using dot notation for each one. We can now extract it using destructuring by opening up some parentheses and defining what we want to extract from that object. So if I do println and I do ID, or I can make a prompt, let me just do that. ID is, let me just use a colon, and then use some string templating, username, and then username, and then age, and age. So now if you have a loop and you're going through a series of users, now you can just have this one liner right here, extract the information that you need from the user, and then print it out, and then go on to the next user. So let me run that really quick. So boom, as you can see, I'm getting the information that I expect. Users right here, ID is 1, username is Geo, age is 40, and right here you see that I'm able to extract that information using one line, right? Open up some parentheses to find what I need to retrieve from the user, and I'm printing it out. So the other classes can be so useful. So you can see that I'm able to copy, I'm able to destructure and get the properties that I need easily without using dot notation. I'm able to copy, and it even comes with some more, like we can compare if one object is equal to another. So I can use conditionals to, you know, take if user dot equals another object, so I can compare with user 2, because I'm like, wait, I made a copy of it, are they the same, or are they equal? We can check that. So if they are, and I'm just doing a print, I'll just do it on one line, I'm just specify that they are equal if this method that the data class provides say or returns true. Let me run that really quick. So as you can see, it didn't print out anything out, so that means that they are not equals. But if I'm just going to do a little check. If I put the same thing there and I run it, you can see that they are equals, obviously, because it's the same thing. They're both the same object. So it comes to dot equals, and if you want to even get the hash code about the object, you can literally just do user.hash code if need be. But yeah, that's what comes with a data class. It comes with so many properties, and remember that a data class is great if you need to hold information. The benefits include, these methods, but the use cases are for storing data. And say for instance you need to interact with a database, whether it's requesting data from the database and storing it into a data class, or even DB retrieval, right? So there are so many things that you can use a data class for. Just keep that in mind. So that is all about data class. If you have any questions, leave it down below. Alright, so we've been utilizing getters and setters to get the value of a property. This whole time we've been learning about classes, objects, and just to refresh your memory, let's do that really quick. So if we do val house and equal house, right? When we do house dot and we do amount of bedrooms, right? We're essentially saying, okay, we're getting the amount of bedrooms, right? It's open to the public. We're trying to get the value of the amount of bedrooms, or the set portion of it is changing the value, right? So getting is getting the value of the property as the name implies, and settings or setters are used to set the value of the property. So we can set the value equal to 5 or set the value to equal to 10. So it's essentially changing the value of a property. So getting the value is getting what the value is currently stored in that, in this case, an object. And setting the value is, setting the property equal to like a 10 or 11 or 12, like whatever we set the value to. Whatever we change the value to is what we use to set the value, right? But you know how in the house class we created a member functions to, because our color was private, we don't have access to gets or sets, right? We had to get the color using a member function, and we had to set the value or change the color of the color property using a change color member function, because we made it private. We don't have access to it. So that wasn't required for here. We had to manually create it. But for amount of bedrooms, it's created automatically. Kotlin has getters or setters internally that gets the property for us when we use dot notation, and sets the value for us when we assign it or use the equal to sign to whatever value we're trying to set the value to. So that is done internally in Kotlin, but we have the ability to extract that internal logic and manipulate it in a way that we want it to. So that's what we're going to do here using getters and setters. So we're going to take that auto-generated code and try to manipulate it in the way that we want. So let's do that with this amount of bedrooms, right? So let's go down here, and to have access to the auto-generated get function, what we got to do is we go under the property that we're trying to change and write out get. And as you can see, IntelliJ is already giving us the structure of that, but we're gonna do it ourselves. We're gonna open up some parentheses, and you can see that it tabs it for us, and then we're gonna have that equal to fields. And this is the normal, the normal setup of a getter that is auto-generated by Kotlin, right? It's essentially saying when a person use dot notation to get access to whatever values in here, is going to make that equal to the field, and this field is simply whatever values within that property right now. So at this point, this field will be equal to 0, and then when we go into main and we set that value to 12, now this field is going to be equal to 12. So what if we want to get or change the logic a bit differently to make it get a different value? So like I said, right now we're setting it to 12, but what if when we get the value we want to add 1, right? Maybe by default we want to let the user know that there's always going to be at least 1. So initially it might be 0 plus 1, or whenever the user set a new value, it's 12 plus 1. Well, we can see that in action, right? We manipulated the auto-generated get function to do something else other than return the field. Now we're adding 1 to it, or we could do whatever. We could add 5, we could add 10, we can multiply, we can do other code with it. But for this one, I'm just gonna add 1. And let's, print that out. And what we're gonna do is we're gonna get that property. So we're gonna do house dot amounts of bedrooms, and what that's gonna do is it's gonna automatically run that get portion, right? So let's run it and see that in action. So boom, as you can see, we set the value to 12, but now for some reason when we get the value, right, using dot notation, amount of bedrooms, it is now 13. Well, that's expected because when we go back to the class, we can see that whenever we try to get something, we're adding 1 to it. And it doesn't have to be a one-liner. If we take away this equal, we can open up some curly braces, and then we can put that in here, right? And like I said before, and we have to return it actually. And like I said before, we can do whatever logic we want here. So if you want to add some custom logic here, right? And whatever we get, maybe you want to check the value or whatever. If it's a 0, then assign it a new value. You can do that. Like if you can do some conditional checks, like if amount of bedrooms is equal to 0, then return 1 or something like that. We could do that. And if we run that, it would do that. So let's go back to the main and make that equal to 0, and let's run it again. So boom, error on my part, and it's saying house KT, and let me see what this says. Replace with field. That is correct. So if fields is equal to 0, because we can't just say, okay, amount of bedrooms. Like, no, the field is whatever amount of bedrooms is holding. So if field is equal to 0, let's run that. Then we return 1. Mistake on my part. Because essentially say if we try to get the value, then it's going to keep going back in the loop. That was bad. But now if field is equal to 0, then it's going to check for 1 because it is 0 right now. But if we make it 12, as we saw before, then it's just going to make it 13. So let's see that again. So boom, 13. So that's how you can create custom logic for your getter portion of it if you need it, but it's an option now. Or there's 2 pieces of it, right? We did get, and even here we did set because we changed the value, so we're setting, and we have the ability to change that as well. So if we go into here, go into the property, and do sets, you see that it's trying to auto populate it for us, but we'll do it ourselves. It'll tab it for us, but we do sets, and then it's expecting a parameter, right, of value. It could be anything. It could be j. Just know that it's a parameter that's being passed, because remember, when we're trying to set a value, we're trying to change a value or change it to a value, and that value is going to be here. So in the case right here, when we're assigning it or making it equal to 12, this value right here is going to hold the value of 12, right? Because that's what we're trying to set it to. And in here, go open some curly braces, and usually it'll be that field is going to be equal to value. Remember, field is essentially amount of bedrooms, but now it's essentially saying we want field equal to value, values being whatever we're passing it in. This is how it's normally structured. But say for instance we want to do some other logic, like maybe we want to times it by 2, or we can do some checking prior using some custom logic, right? We can do that, but you would have to do it yourself, or you have to set it up yourself within these curly braces, and assign the new value equal to fields, right? Before it was returned, but we can do fields here. Assign the new value equal to fields, and if we run it, we can see that. Or actually, let me go back to main. We'll see that originally it was 12, but when we get the value, we'll see what the new value is. That should be interesting. I'll let you guys guess that before the answer comes on the screen. So boom, it is 25, and the reason why is because we set the value first, right? So when we set the value here, the logic is we're timesing it by 2. So 12 times 2 is 24, and then after that we're trying to print it out by getting the value. So when we get the value, we're adding it by 1. So by the end of it, the amount of bedrooms is 25 for some reason. So that is how you can manipulate the internal auto-generated getters and setters. Obviously you can go the private route and create your own member functions for it, but if you're trying to use the own internalized or auto-generated getters and setters, you can do that as well. Now I would have a good reason to do it, honestly. Like you can probably check the structure of it if you need to, have a good reason for changing it, but just know that it's possible if you need to do it. So that is getters and setters in Kotlin. All right, so now that we've learned about objects and classes, now it's time to learn about some of the principles of, or a very important principle of object-oriented programming. So we're gonna learn about inheritance, right? So just before I dive into like the code aspect of it, let's look at the real life example of it, right? So we have on my screen two parents, right? We have a father and we have a, a mother, right? And we have three kids, right? Usually, if everything goes well, the family's going well, kids are made, right? And usually when you have kids, there's usually an aspect genetically that they take, whether they have the same hair color or whether they have the same eyes, the same nose, the same ears. There's usually something that your child inherits from you, or maybe they might even inherit something way farther from something from your father, your grandfather, right? But there's something that they usually inherit from a base place, whether that's your father, your mother, your grandmother from your mother's side, your grandmother from your father's side. There's usually something that the child inherits. So it's very similar to that aspect in programming. So inheritance in programming allows us to create a new class, which is called derived class, from an existing class, which is the base class. So we'll have a class that acts like a parent, essentially, and then we'll have a subclass, a derived class, that will derive properties from the base class. So essentially, that's inheritance, right? It's inheriting properties or information from an initial class down to the subclass, the derived class. So the derived class inherits all the features from the base class, and it can have additional features. So just like with these children, yeah, they may have properties about the parent, but we can add new things, or new things are added to the child that makes them different than their parents. So an example that I'm going to use, right, is of a building, right? There's many different types of building, but usually all buildings have similar properties. So we can have a house, right? We can have a house, we can have a skyscraper, we can have an office building, but they're all essentially buildings, right? They all essentially have windows, they all essentially have doors, right? Because you have to enter it. They may have additional properties like a fence, or they may have a different amount of bedrooms or rooms in general, or they have a different amount of bathrooms, but at the end of the day, they're still a building. So they can still inherit from a base class of building, just like how a child inherits properties from a parent, right? From a base parent. So we're going to go into the code IntelliJ and we're going to go over that step by step. So let's get going. All right, as promised, we are in the IDE. And what we're going to do is we're going to create a base class and a derived class. So I talked about it in the previous portion where I said that there are scenarios where we can have a base class like a building, which a building can be many types. It can be an office, it can be a house, it can be a skyscraper, but they all contain properties of a building because they are buildings, right? They all have doors, they all have windows, they all have bathrooms, rooms, whether it's a bedroom or a room for like the CEO, like an office room. So they all hold properties, but if we need additional properties to make them unique, such as a skyscraper or a house or office, then we can do that from within the derived class, right? The derived class will take from the parent class, and we can add additional properties within the derived class to make it unique to what it is, right? So let's show an example of that. I'm going to create the base class first, which is going to be the building, and then we're going to create some derived classes such as the skyscraper class. The house class is going to take on the building, or is going to inherit from building, and we're going to create an office class as well. So let's do that really quick. So let me right click on Kotlin, new Kotlin class, and we're going to make a building class. Now, by default, this is marked as final, so it's not going to allow any other classes to inherit from this building class, but in Kotlin, there is a keyword called open, which we can put in front of this class keyword. So it's going to be open class and the name of our class, which is in this case is building. And what this is essentially saying is that this is open to be inherited from. This is now going to be the base class, the parent class. So now we can start defining some properties of this building. Now previously, when I created a primary constructor for a class, what I used to do was I put val, I put the name of the property. So in this case, I'm gonna make a property called rooms, and then it's gonna be of type int, and I'm gonna create another one called bathrooms, and it's gonna be of type double, right? Because like I said before, bathrooms can be 3.5, 4.5, depending on the architecture of the building. So I'm gonna keep that as double. But like I said, you don't have to like put val or var like I've done before. You could remove them and then write the properties down below here. So whenever you write val or var within the primary constructor, it's essentially saying that we're declaring the property inside of the class. Now, if I don't put it, right, it's not going to break. It's not going to break if I don't put the val or var here. It's just simply saying that we're expecting some parameters to be passed when creating an object, but we still have to initialize the properties manually ourselves instead of it being created through the constructor. Well, we can have our rooms property created here after the user passes in or the application passes in those parameters, right? But if you don't want to add the properties on another line, then you could just put val in the constructor and it'll create those properties for you, right? It's really up to you, right? But in this case, for this example, I'm going to create the property separately because I'm going to show you some different things about this class or this open class. But I'm going to create the properties separately, and I'm going to make this equal to rooms, and then I'm going to make another one, or actually I'm going to make it more specific, amounts of rooms. I feel like that's more specific. And that's going to be equal to bathrooms. So now we have two properties, right? We're taking in rooms, we're taking in bathrooms. We're going to pass that to the amount of rooms property for the class and the amount of bathrooms properties for the building class, because we know that every building should have a certain amount of rooms and a certain amount of bathrooms. So, and if we want to give it default, we can give this a default of 1, give this a default of 1.0 if we want to, or you can just give it 0. It's really up to you, right? Just in case they don't pass it. But yeah, now we can create, or actually this has to be 0.0. Yeah. But now we can create our second class, and this is going to be the derived class because it's going to be deriving or taking or inheriting information from building and using it within itself. So let's do new Kotlin class, and I'm going to call this skyscraper. All right. And then what I'm going to do from the start is I'm going to inherit. So to inherit, you just use a colon and you specify where you're trying to inherit from. So in this case, I'm going to put the parent class or the class we just created or the base class, and that's going to be building. And remember, we just created the fact that we have to specify, or we could pass in 2 parameters through the primary constructor. As you can see, we have default values, so it's not going to get angry if we don't. Say, for instance, I didn't put a default value. Then by removing it, you're essentially saying, okay, we need something. But by having default values, we don't necessarily need to. It's not forcing us, but we should. And then for this one, for the skyscraper, we can start defining some properties for this skyscraper class. And in this case, I am going to use val, and I am going to put val rooms, and I'm going to make that into an int. I'm going to make a var bathrooms, and I'm going to make that a double. And then I'm going to do a unique property for a skyscraper, I would say, is the fact that there's a outrageous amount of stories for the skyscraper. So what makes a skyscraper is the fact of how tall it is, right? So I'm going to say that it is going to be certain amount of stories. So usually like 40 stories, 41 stories, something outrageous like that. Then the rooms that I'm getting that's being injected, or the property that's being injected, I can pass into the primary constructor of where we're inheriting from, right? So essentially this is injecting rooms and bathrooms into building. If I go back to building, then now the amount of rooms that the building is going to be the rooms that we're injecting, and the amount of bathrooms is going to be the bathroom that we're injecting. So it comes full circle. And another thing that we can do with building, right, is we can create some functions, like some member functions within it. So say for instance we want information regarding the building. Well, I can make a prompt, right? Whether you're going to put this on Zillow, or whether you just want to explain to somebody or give information or display information to somebody, you can do that here. In this case, I'm just going to print it, and I'm going to say the amount of rooms is, and then use some string templating, amount of rooms, and then put a comma, and then bathrooms, and I'm going to put amount of bathrooms. So perfect, right? So now if I call this information function, then it's just going to print out the amount of rooms of the building and the amount of bathrooms for the building. So that's useful. And remember, this is inheriting from this base class, so I don't have to make that myself, right? I can inherit from it. So if I go into the main KT and I do file and I do skyscraper of type skyscraper. Oh, I spelled skyscraper wrong. Skyscraper. And I make a new skyscraper object, right? And now it's expecting me to pass the amount of rooms, bathrooms, rooms, and stories, so I can do that. So let me see. So it's expecting rooms first. I'm gonna say that this has something absurd like 150 bathrooms, because usually there's more bathrooms than rooms. And then the amount of stories is 40, or actually this has to be a double, so 150.0. Actually, let's be obnoxious and put 150.5. And then the stories is 40. So now I can do skyscraper dot, and boom. You're probably like, wait, how does skyscraper see information, right? When I go into skyscraper, information is not there. But we know that because this is inheriting, right? Because the whole point of inheritance is that it's a base class that has properties that are very similar, or can be similar to other things or other types of objects, right? But instead of having to have duplicates of those properties in every single class, well, we can have a base class and we can inherit it from that base class, right? And now that we're inheriting from this base class, if we go into the base class, we see that there's an information function here, and we have access of that information function from skyscraper because of the fact that we're inheriting from the building base class, because skyscraper is a derived class, right? It's a child class, just like we talked about in the beginning portion of the video with inheritance. Like, you have a parent and you have a child, right? The child can have properties from the parent. Yes, it may not have everything, like the child may not have everything about the parent, right? Because that would make the child not unique, but we can inherit some properties from the parents and still utilize it. So they may have the same amount of eye, or the same eye color, or the same hair color, or the same hair texture, right? But doesn't mean they're gonna be the same height, doesn't mean they're gonna have the same feet size. It just inherits certain properties from that parent. Just like in this case, like, yes, building has rooms and bathrooms, but doesn't mean it's gonna have the same amount of stories. But we can still utilize some of the properties and some of the functions from the parent class. And in this case, we're gonna utilize information. So now if I run this, we can see that we see the amount of rooms and we see the amount of bathrooms, right? It's 100 and 150.5. But wait, skyscraper has stories too. What if, as a person, I want to know how many stories? Maybe I'm interested in buying this skyscraper, but like the amount of rooms is great and the amount of bathrooms is great, but how many stories is it? I don't want a skyscraper that just has 39 buildings. I want a skyscraper that has 40 stories, right? So how do I see the amount of stories? Like, the building doesn't have the property of stories, and I don't want to give it a stories property because of the fact that other buildings may not have a great amount of stories, or there's certain properties I want to keep unique to skyscraper, right? So how can I adjust the information function, specifically for this skyscraper class? Well, we can do that. So just like how we made this building class open, right? We can make this information function open. And by declaring a function open, we're essentially saying that this function is open to being overridden, right? This information function, or this function, is open to be changed, right? Based on what we need, based on the specifications of the class that's inheriting it. So it can be adjusted to the child class that needs it. So now that this function is open, what we can do is we can go into building, or we can go into the skyscraper that's inheriting building, and we can use the keyword of override. And you can see IntelliJ already sees it, but it already sees the open function, so it's gonna allow us to pre-populate it for us. But essentially what this is saying is we can override, or essentially change, this information function to what we need it to be. And what we need it to be is, I still wanted to print out a prompt, right? But I wanted to print out a prompt that includes the amount of stories. So what I'm going to do is I'm going to put a comma, and I'm going to say stories, put a colon, and put the amount of stories. Boom. And I'll put this on a new line, make it easier to see. So now we have rooms, we have bathrooms, and stories that is unique to skyscraper, because what we did is we made this function open in information, or we made this function information open, and what we did is we went into this skyscraper class and we overridden it, meaning that we changed it to fit what we need it to be. So if I run this again, we should see the difference. So boom, now we see that there is rooms, bathrooms, and stories. Great. Now it's actually changing it, or it was overridden to be what we needed it to be. And initially you probably saw when I let IntelliJ populate it, auto-populate it itself, because I didn't write it, I let IntelliJ do its thing. So originally when IntelliJ populated this function for us, this override function for us, which we could have wrote it by hand, but I just saved some time by just pressing enter. You probably saw that it was showing something like super, information, and open and close parentheses, and you're probably wondering what was super, right? What is super? Well, super is just essentially saying super is the base class, right? And you can probably see that I'm hovering over this, and building is shining in itself. But essentially what super is saying is we're essentially saying we're calling the building, right? We're calling whatever we're inheriting from. That is super. So if I do super.information, it's going to be calling the original information function, right? It's not going to talk about or take this information function, but it's going to be saying that super, which is essentially a reference to the base class, we're going to be calling this information function. So let me run this so you guys can see. So boom, as you can see, it's showing rooms, bathrooms, but stories is not here. But the second line, which is this line, is going to show stories. So essentially super is a reference to the base class, and it's calling the original information's function, and then afterwards it's printing out what we created, or what we overridden for ourselves. So this, in the main class, it's referencing the one that's attached to skyscraper, while the one that is using the super keyword and dot information is referencing the actual information function from the base class. So if you still want to reference the base class, just use the keyword super. But if you want to create your own that fits the current class, and use the override and create what you need to internally. So that's why I erased it, because it's not needed, because I don't want to reference the base class. I want to create one for myself. So hopefully that was helpful. If you have any questions on that, leave it down below. Now I want to create one more example, and I'm going to use the office class to specify the example that I want to show. So I'm going to do new Kotlin class. I'm going to call this office, right? And I'm going to save some time, right? I'm just going to go into skyscraper. Let me copy some of the properties, because they are going to hold the same properties. Let me go back to office, open up the parentheses, and then close it. So now I have an office. It has rooms. It has bathrooms. That's to be expected. I'm going to inherit from building. So I'm going to use a colon building. I'm going to pass the parameters, right? We don't have to. Remember, I put a default value. So it could be, equal to 0 for rooms and bathrooms if I wanted to, but I don't want it to. I want to pass rooms and I want to pass bathrooms. So when I do pass those properties on the creation of the office, the base class of building has a reference to rooms and bathrooms. And then what I'm going to add to make office unique is I'm going to add the amount of stories, because the office building could have many stories as well. So I'm going to do stories. But I'm also going to put, is it for sale, right? So I'm going to put is for sale, and that is going to be a Boolean. So boom, right? And that's also a property that can fit a building, because we could sell a skyscraper and we could sell, whatever other building that inherits from this, right? So if it's a house, we could sell a house, we could sell a skyscraper, we could sell a building. So let's add that property to the building's base class. So what I'm going to do is I'm going to create a val or var, and I'm going to make this is for sale, and I'm going to make it a Boolean, and I'm going to make it false by default. And what I'm going to do is I'm going to make this variable open, or this property open, just like I did with this function, right? Essentially what this is saying is I can override this variable, right? It's starting as false, but I can override it to whatever value I want it to be. In this case, it's a Boolean, so the only thing that you can override it to is for it to be a false or a true. So it's either going to be for sale, or if it's not going to, it is going to be for sale. So if I go back to office, right, and let's see what it says. So it's essentially saying I need to override this, right? So what I'm going to do is I'm just going to make this a param, but within the office, right, I'm going to do override is for sale, and I don't want to put the getters and setters, but I'm going to override it, and I'm going to make this equal to is for sale. So by default, I'm going to make the parameter false, but if the person puts a new value like true, then it's just going to override it to is for sale, or whatever value that is for sale has. So if it's true, then it's going to be true. Now if it's false, then it's false. That is what it is. And then I'm also going to override information. I'm going to write this one out. Override information. Open it up. And then what I'm going to do, and let me see what this says. It doesn't make it. I was saying override nothing because I'm not putting anything in there. But let me take essentially the same prompt, and then I'm going to add it on the fact that is it for sale. So, and honestly, this is misspelled actually. Put comma is for sale, and I'm going to inject that. And there's many other properties that you can put in the base class. Like you could put the price, because every building has a price, right? The amount of land. There's a lot of things that you can do with it. But in this case, I'm just making it simple. And I guess that'll be a project for you guys. You guys can go in and add properties that make sense for you. But in this case, I have what I need. So now when I go into the main, what I'm going to do is I'm going to create a new object, and I'm going to call this office building. I'm going to make this a type of office, and I'm going to make that equal to a new office, a new instance of an office. And then all I can do, or all I have to do, is do office.information to learn more about the office. And then I got to inject some parameters. So the amount of rooms, I'm going to say that this office has 20 rooms. It has 25.5 bathrooms. It has about 4 stories, and it's indeed for sale, right? It's tough times. We got to sell the office building. Everybody's working from home. Everything is remote. And then let's run that and see some information regarding that office building. So, boom, right? We see that, the original skyscraper has 100 rooms, 150 bathrooms, stories is 40. But now we have this office building with 20 rooms, 25.5 bathrooms, 4 stories, and it is in fact true for is for sale, because when we go back to office, we're taking in rooms, bathrooms, and stories as properties because we have val and var in front of it. Remember, if we remove it, then they're not properties. We're going to have to create a property internally within the curly braces and assign it to it, just like we did with is for sale, because you can see that is for sale doesn't have a val or a var, essentially saying we're taking it as a parameter, right? We're taking it as a parameter, and now we're going to assign it to the property. And the property in this case, we're overriding from building, and we're marking this is for sale piece to whatever value that we're getting in as a parameter. So in this case, we marked it as true. So this overridden property is now going to be true, and we prove that by printing it out in this prompt. So that is just the power of inheritance. If you're going to have different classes that have very similar properties, you can create a base class, right? So you don't have to create duplicates for each item every single time. You just go in, inherit from the base class, and then override what you need to override and add additional properties to that class that makes it unique. So in this case, we had skyscraper, we had office, and we could have even did the same thing for house, right? We could have add some logic, or we could have inherited house pretty easily, add the amount of, because we already have amount of bedrooms and we already have the amount of bathrooms, just pass that in as a parameter to building and add on additional properties, right? So I'll leave that up to you guys. If you've been following the video, you should already have the house class, and I'll let you guys play around with that. If you need any assistance with that, leave that in the comment section, and then I'll help you guys with it. But that'll be a nice little project for you guys to get an understanding of inheritance. So hopefully that was helpful. This is a very important concept. It's used a lot. I'll tell you that. And yeah, it saves a lot of time, saves time with duplication. So yeah, let's continue on. All right, ladies and gentlemen, while we're on the topic of object creation and inheritance and all that good stuff, let's talk about the object keyword, right? So the object keyword allows for the creation of a class and an instance in one go. So it allows us to create anonymous classes, and these classes don't need explicitly the keyword of class. So we're so used to seeing, for example, a house, right? We have this keyword of class, and then we can use that to make an instance of a house, right? So you go to a new instance of a house. But with the object keyword, we don't necessarily need that, and it's very useful for things like utility classes. And if you came from Java, right, and you have some experience with design patterns, it's essentially saying, or essentially is a static instance, right? There's only one single instance of that object. So this is probably not making any sense. So let's create an example really quick. So I'm gonna right click, I'm gonna make a new Kotlin file, right? Not a class, because we don't care about the class keyword with an object keyword. So let's create a new file, and I'm gonna give it a name of helper util, right? So now, instead of using the usual class keyword, what I'm gonna do is I'm gonna use the object keyword, right? And I'm gonna use the same name, helper util, and open up some curly braces. So now I can start creating some helper utility functions. So if you come from a coding background, or even if you don't, it doesn't necessarily matter. But usually when you create utility files, like, they're used as utilities. So you can think of it as tools. So one thing that you use a utility file for is to connect to a database, or to do some mathematical functions in one place. Like if you want to do square root multiple times, you can create a utility function for that and call it whenever you need it, right? That it's in one place and there's only one single instance of it. So, or if you want to generate something like a token, right, for authorization. So if someone logs in using a username and a password, we need a place to generate a token that is unique to that user, right? So this can all be done using the object keyword, and you can give it a name, right? So in this case, I'm calling it helper util. It can be database util. It can be anything really, but I try to give it a name that I know is very obvious for whoever picks up the project or for myself, right? So helper util is going to be utility functions that will help me. So the first one I'm going to create is a generate JWT, and I'm going to open up a curly braces for this because it's a function. Unless it was a one-liner, then I don't need that. But in this one, I'm not going to actually generate a JWT. That's going to need some initial setup. But what I want to do is I'm going to make this a string, and I'm going to return or act like I'm going to return a JWT token. So it's going to be some crazy looking thing. But if it was a real utility function, then you could have some logic here and then have it return a value here. And how we can get access to this, essentially, right? We can go into this main. And before, remember what I said that if you use the class, you have to create an instance of an object. Well, for the object keyword, right, I told you that there's only a single static instance, right? It's great for the creation of a class and an instance in one go, right? Meaning we don't have to do this. We can just call it, right? We can just call it based on its name. So it can be helper util dot, you can see the function that we created, generate JWT, and let me put ln here. So you see the difference, right? Now we don't have to create an instance of a object using the class that we have. We can literally just call it based on its name and do dot generate JWT. And if I run this, boom, it returns some gibberish that we created in our helper util, right? But like I said, if you need it for something like generating a JWT, like that the user passes in a username password, you can just pass it in as a parameter for this and return the token based on that. Or if you need another function that does square roots, or if you need another function that capitalizes your name, like if that can be done right now, actually capitalize name. It's a name string. All right, and then let's just return name dot capitalize. And honestly, Kotlin has been deprecating all of this stuff lately, so let me see. I just saw that it deprecated, or they had a strike through. It didn't show any example of what it want me to use, so I'm just gonna use it for now. It shouldn't be broken, right? So let's see if I'm able to do it. Println helper util. We just gotta use the object name, right? Use dot, and now we can see that it has capitalized name. I'm just gonna put all lowercase geo and see what happens. So boom, now we see that it's capitalized. It's capital G, I, and O. So that's the power of the object keyword. It creates a single instance in only one instance, just like if you were in Java, it's essentially a single static instance. But it allows us to create a class and an instance in one go. All we got to do is specify the name, and we can essentially create whatever we need to. Even if you wanted to create constant values in here, right? And you know that you want to just grab it using the name, we could do that as well. So we could do helper util dot, and I lied. Let me see. It doesn't like that. Whoops. All right, now that should work. When you mess around with too many languages, right? So now I know that if I do helper util.py or whatever variables that I create within here, it will accept that. So that's the cool thing about objects. If you just need to have a utility function, or if you want to do some setup, an object will be perfect, right? So object versus a class, there is a difference on the setup of it. The object will allow for the creation of a class and an instance in one go, and we can utilize that by just specifying the name. Hopefully that was helpful. All right, in this video we're going to talk about companion objects. So in languages like C, Sharp, Java, we have the keyword, like the static keyword, which will allow us to declare members of the class and use them without making an instance of an object, right? We just call them by the name like we just did with the object keyword. But in Kotlin, there is no keyword like static, but there is companion, right? And I kind of like that name. It's like, companion, like right alongside, type of thing. But let's take a look on how to create a companion object in Kotlin really quick. So we're going to use the house as an example, and it's kind of stuffed in here. Still got the getters and setter actions in here. So we're going to scroll down a bit, go all the way towards the bottom. And to create a companion object, right, and it's essentially saying without creating an instance of a class, right, we can call whatever is within this companion object, just like we just did with the helper util. If you watched the previous portion of the video, we created this object helper util, and we were able to call everything within here without making an instance of the helper util like we did with house, right? With house, we would have to make an instance of it and set it equal to house here, but we created an instance right here. We didn't have to do that with helper util. All we had to do was do helper util dot, and we had access to everything within it. Same thing with the companion object, right? So with the companion object, and to make a companion object, all you have to do is spell out companion, which I'm having trouble doing, and object, and you can give it a name. So I'm going to give it a logger object, because usually in the real world, what I usually use a companion object for is logging, right? I usually create like a function within the companion object, and whenever I need to log something for the specific class or specific object, I can just call it from within here. So let's do the same thing here, right? We're going to make a function called logger, and we're going to expect a message type string, and usually there's some type of internal log manager that I use, but for this case I'm just going to use println. And you're not restricted to just using println. I know I use println for a lot of examples, but you can do some custom logic here if you need to, but for here I'm just using a println, and I'm going to call this logger or house log, and put a message, right? Let me see. Oh, gotta put it inside the double quote. String templating. All right, perfect. So now we have a companion object called logger object, and we created a function called logger that will essentially allow us to log messages from within the house. So let's go into the main and see how we can use that. So to use it, all we got to do is use the name house dot, and we can see logger, right? Isn't that perfect? All right, so now all we got to do is put a message, and the one I'm gonna do is we created a house. Nice. And if we run that, boom, house log, we created a house. So now you see the power of it, right? With the companion object, we have access to the members of the class by only specifying the class name, right? All we had to do is use house, and now we have access to things like what we created within the companion object, which in this case is logger. Well, we can put other properties within here if we need to, but in this case that makes it so much easier. So now we just have to use the instance of the class name, and now we have access to everything from within. So here house dot, and now I can have access, so I can get access to the logger object itself, and then if I want to call a logger like that, I could, but that seems long and convoluted. So house dot whatever we're trying to retrieve from the companion object works just fine. So that is the companion object in Kotlin. Alright, so in this portion of the video we're going to be talking about interfaces. So an interface just describes what a class needs. So with inheritance we extended a base class, but with an interface we implement an interface, right? So it needs to create the item specified by whatever is within the interface. So let's create an interface really quick so it makes more sense. So we're going to right click here, and I'm going to call this and we're going to go to Kotlin class/file, scroll down a bit, and I'm going to choose interface. And what I'm going to do is I'm going to create a test interface. So in test interface, and boom, and you can already see that the keyword that an interface uses is interface, and then we use we put the name that we just specify, so test interface. So an interface can contain definitions of an abstract method or non-abstract method. So what does this mean? Well, abstract means that it's not being instantiated, but when we implement it, we would have to give it meaning. We would have to give it a definition. We have to give it some code structure, right? Well, a non-abstract method is already created, already has some code, some logic, right? So let me write this out so it makes more sense. So something like a var name string, right, has no definition. There is no equal something, right? It's just var name string. This is abstract, right? And in the case of a method, right, we can do function test, open close parentheses, define the return type. So I'll just make this a string. This is an abstract method. So this is an abstract variable, and this is an abstract method, right? Because this has no definition. It's just a variable, right? We gave it a type that is it's going to return, and we have a method or a function that we have the type that's going to return, but there is no internal definition on what it's actually doing inside. So, and then something like a prompt, right? And we use prompts a lot, but we know that this is going to return hello world, or we're going to make this function return hello world. This is a method with implementation, so it is considered non-abstract because it has something that's being returned. It has a definition. So that is the difference between an abstract method and a non-abstract method, or abstract versus non-abstract. So cool. Now let's actually implement this interface. We have this interface. We gave it a name, or we gave it a variable of name. We gave it a test and prompt function. One is already implemented, right? It already has a value, but while the other doesn't. It's abstract, so it doesn't have anything assigned to it. So let's actually create an implementation of it. So let's create the new Kotlin class, and we're going to call this test implementation, right? And what we're gonna do, or what I'm gonna do, is I'm gonna implement the interface. So the way to do that is the same thing of how we extend a base class, right? But it's not the same thing, right? We're implementing instead of inheriting, right? So what we're gonna do is gonna still use the same colon and then provide the name of the interface. So in this case, it's gonna be test interface. But now you see a red squiggly because of the fact that the nature of an interface is that we have to utilize whatever we created within an interface. Because like I said, the class that implements an interface needs to create the items that was specified by the interface. So what we could do is we can go here, hover over it, and implement as constructed parameters. So I'm going to take that for name. So I'm going to override the name, and then I'm going to override the function for the the test. And honestly, I'm just gonna have that return a string, nothing crazy. And for the name, I'm just gonna have the person put the name on the creation of the class or the object for test implementation. So they'll pass the name, and that will create, because it has var and var. If it had val, remember, whenever it has var or val, it's gonna create the property for us from within the primary constructor. So I don't have to put it on a new line like this from within. So that is how you create an interface, and that's how you implement it. You'll use a colon and the name of the interface. Now, another distinction between inheriting and implementing is the fact that with inheriting, we can only inherit from one base class, while with implementation or with a interface, we can have multiple interfaces, right? We can put a comma and put another interface. When inheriting, we can only have one base class. We can't put another one. So let me create another interface, and I'm going to call this log interface. And I'm just going to just create two abstract values. So one is going to be a method and one is going to be a variable, and I'm going to give this one of var log event. That's gonna be a string, and then it's gonna be log message. And I expect that person to put a message. And that's gonna be a type string. And I'm gonna make this be a unit. I don't want it to return anything because I'm just gonna print out the log message, and we're good to go. Now if I go to test implementation, I have test interface, but now I can just put a comma right after, and I can put log interface right after this, and the rest quickly should show up again, and it's expecting for me to implement some of the items. So I'm going to also put that property within the primary constructor, while also overriding the log message. And what I'm going to do is I'm going to just print out whatever message that is provided. So log message, and then pass the message from within. So if you know how you want your classes to be created, or give a specific structure of a class, you can already create an interface and have that class implement those interfaces. And now you know that, okay, I want these properties from within that class based on the implementation that I have. Maybe at that point I might not know the structure that I want, so I can create some abstract methods and they can implement it from within, but at least I know that I want these items from within that class. So that's really the important concept that an interface can have, right? A lot of interfaces are used for things like services. When you start going into back-end technologies, a lot of interfaces like Spring Boot you can use an interface with a service, and you can have a class that has specific functionality that you can implement interfaces to have to make sure that that class have a specific format, and you can adjust it based on your needs, or you can override functions and properties based on your needs. So let's talk about type checking and casting in Kotlin. We have the is operator and the as operator. So the is operator checks a particular value, and it checks if it's a certain type. So for example, we can have, a var of age, and we can have that to be 20. And say for instance we don't know yet, right? We can have a conditional check, and if age is int, right, then we can do some mathematical logic with it, right? But just to prove that it is an int, I'm just gonna print it out. I like printing lens. It is an int. Well, we can see that even without specifying that it is an int, Kotlin can infer that it is an int and pass that to this age. And now that when we check in the conditional statements, we can check that age is in fact an int, and it was printed out because that works. So that is the checking part of it, or that is type checking, right? It checks if a particular variable is a certain value. So it can be anything really. It can be, you could check if this is a house, right? You could check if this is an office, right? We're just checking if a particular variable is another type, and obviously we can see that it isn't, right? It's incompatible already. It knows that this is an int, so why are we even checking this, right? But there are many cases where we can have, we can even use a when expression to see if this is a particular type, where we can have various amounts of checks for that. So that is in Kotlin. If we want to check, or we want to have more control on whether a certain particular value is of a certain type, then you can use the is operator. Then we have the as operator, right, in Kotlin. And as for casting, and what as does is it casts a value to a certain type. So it doesn't necessarily work for everything because of the fact that Kotlin does a smart job, or a great job, of inferring the proper type. So like I just showed, age is already set to an int even though we didn't specify it. So if we try to do like val description, set that equal to age as a string, because I said it's an as operator, so it's spelled as. It's saying that this cast can never succeed. I mean, we can try and see. We could print whether or not age or description is a string. And if it is, then it's going to return true. And if it's not, then it's going to return false. Boom, it breaks. Because it's throwing a class exception, right? Integer cannot be cast to a string. So this does have limited functionality. Obviously, if it's more obvious, you can do more money, more problems is what I'm going to put for this. But obviously this will work if it's obvious, but you wouldn't even do this as a cast if you already know that it's going to be a string. You could also do it for other types as well, but like I said, this is not nearly as one-to-one as you would expect it to be because of the fact that Kotlin does a great job of casting variables or casting to the proper type using smart casting. So but I just wanted to make you guys aware of the fact that as exists, but it's usually not used because of the fact that Kotlin is very smart with how it casts variables to a type. So on to the next one. Alright, so let's talk about null protection in Kotlin. So Kotlin's system is aimed at eliminating the danger of nulls in its system, right? Because one of the biggest problems in many programming language, and if you're coming from Java, it's a pretty big problem in Java, is that accessing a member of a null type will result in some null exceptions, right? Some null. You've probably seen the null pointer exception a lot. There's some memes on there as well if you're into memes. But yeah, null pointer exceptions can be a problem, right? It can crash your application if you're trying to access something that is null, right? So in Kotlin, the type system distinguishes between references, right, that hold null, or if it can hold null or not hold null, so non-null references. So let's see an example really quick. So we're going to have a variable called first name, right? And that's going to be a string, and that's going to be equal to geo. But then we're going to have another variable called middle name, and that's going to be a string. But not everybody has a middle name, right? So this could be considered nullable because not everybody has a middle name. Some people might put it as an empty string, but in this case, I'm going to make it nullable. And by default, if we don't specify that it's nullable, then Kotlin's going to get angry. So if you try to assign first name to null, it will get angry. It's going to be like, hold up, wait a minute. You said this is going to be a string of a non-null type, right? Meaning that this is going to be a string that cannot be null. So change it back to an actual string, please. And I will do that. But in this case, to make something nullable, meaning that we can assign it to be null, you have to put a question mark after the type. And essentially what this is saying is that this is okay to be set to null. So in my case, and in this case, I don't have a middle name, so we're going to set that to null. And that's okay, it won't get angry because we have this question mark at the end saying this might be null. This is going to be a nullable type of a variable. So if we need to assign this to null, then like we just did, then it's no problem. Or even if we had this as Bobby for middle name, and later, right, because this is a var, maybe I don't like my middle name anymore and I want to eradicate it, right? I want to get rid of it. I can set this to null with no problem because this is a nullable type of variable. But the thing is, accessing data in first name it's pretty safe because we know for a fact that this is going to have a value in it, right? We know that for a fact, whether it's geo now or whether it's another value later, it's going to be a string. Where with middle name, well, it could be a string, but it can also be a null value. So it's not as safe since it can be null. Now with these pitfalls now, because it's nullable, there are different operators that Kotlin provides that can make it safer, with 2 quotes around it. It can be safer to call these type of variables that are nullable. So one type of operator is the safe call. So let me just comment that, put safe calls, and it uses an operator. The safe call operator uses a question mark and a dot, right? So if we need to access something within this variable, right? So say for instance we want to print out the length of the middle name, right? And we're not sure if there's a value within it or not. Well, we can use the safe call operator, which is the question mark and the dot, and try to use one of the methods that a string come with. So let's say for instance we're trying to get the length. Well, this can either return the length of this middle name, or if this is null, then it's just going to return null instead of it exploding on us, right? So let's run this really quick. Middle name currently is Bobby. So let's see what happens with this safe call operator. So as we can see, we get the expected length of 5. But what happened if we make middle name equal to null and run it? Boom, then it's going to return null. So it's either going to return, if it has a value, it's either going to return the value, or if it doesn't have a value and it's null, then it's just going to return null. Instead of just, in Java, it just throw a null pointer exception, and that may cause issues, right? So if we try to do this, I think right now Kotlin is smart enough to see that this is always going to be null, so it's not even going to let us, try to do that. But if you're running an application, or if you have your application running in a backend, it's a backend server, and there's a lot of information coming in and out, and by chance one of these values are assigned a null and you don't have a check for it, that can cause an issue to your application. So things like this, knowing that this is nullable and having checks for it, is pretty great by having a safe call operator being used, which is a question mark and a dot. It's either going to return what you're expecting from that method, or it's going to return a null, and you can have a check on whether it's null or not, and then go based on that. So, and this can be used in chaining, like in a chaining fashion. So say for instance we have a length and you want to attach another dot to it, and you want to do dot toString. Well, you can do another safe call operator and do toString after that, and keep going if you want to, and use another safe call operator, right? And then get a certain index, right? So you can get the first index, right? If it is if it does have a value, right? But if it doesn't, then this is all going to just return null. So, or at whatever point that it stops at, then it's going to return null if it is null. So that is the safety net of safe call operators, and then you would definitely need to have a check on whether or not it's null or not, and do some logic based on that. But yeah, that's the safe call operator. Now, what if you don't want to just have it return null like safe call does? Because right now safe call is either going to turn the actual value or it's going to return null, right? But what if we want to have a fallback value? Well, we can use the Elvis operator, and that, I guess, it kind of looks like Elvis. I mean, you guys let me know in the comment section if it looks like Elvis to you, but it is a question mark, and let me actually write down the name, Elvis operator, and it's a question mark and colon. I don't think that looks like Elvis to me, but you guys let me know. So essentially it's the same kind of logic, right? If it's not null, then it will return the value, else it'll fall back to a value that we specify. So let's see this, and this can be used a lot with expressions. So say for instance we have the middle name, right? We're trying to do get the length of a middle name. So length of middle name, right? We can do middle name, or make that equal to middle name dot, or we can use the safe call operator here, so question mark and dot length. But then we can also use the Elvis operator with this. So we can use the question mark and colon, and we can have a fallback value. So the fallback value will be 0 in this case, because there is no length for the middle name that is null. So we're just going to have it equal to 0. So in this case, it's gonna, with the safe call operator, if it actually has a length value, then it's gonna store the value of that length to this length of middle name variable. But if it's null, then it's going to return null. But with the Elvis operator after that, it's going to see that this is going to be null, so then it's just going to fall back to the 0, which is, to me, a better way of doing it. I don't want to store null as the length. I want to store a value. So in this case, even if it's 0, that's still okay with me. So if I print this out, I can check that it works. Length of middle name, and actually let me just make a prompt, length of middle name. Oh, wrong wrong variable. I actually was like confused for a second. I was like, hold up, did the Elvis operator stop working? But no, that's just me. That's an error on my part. So I gotta get the length of the middle name and put it in this prompt. And boom, now that's what I expect. So the first one was null, which is the safe call, but with the combination of the safe call and the Elvis operator, I now have a fallback value of 0, and now there's some more protection in regards to nulls, right? Now I don't have to worry about this storing a null value. It's either going to return the actual length of the middle name if there is a value for middle name, or it's going to fall back to 0 if middle name is null and the safe call operator returns null. I don't want to store null. I want to store an actual value or an actual int. So 0 works in this case. Now, if you like a little bit of an explosion, right, we can use the not null operator, which, let me just write that out. Not null operator is 2 exclamation points, right? So the not null assertion operator converts any non-null type and throws an exception if the value is null. So the not null operator converts any value to a non-null type, right? We talked about non-null types, right? It's like this string right here. This is a non-null type because we expect a value to be in here, right? But we're going to be using middle name to see, or to try to convert it to a non-null type. So we're going to use the not null operator to do that. Now, the reason why I said if you like explosions, you will like it is because if it tries to convert a value to a non-null type, and it is null, then it will throw a null pointer exception. So we talked about that in the beginning of the video, how we do not like null pointer exceptions, because that was a problem within other programming languages like Java. But you know, this is still used to try to convert it anyway, and this is something that Kotlin provides for it. So let's see it in action. So we're gonna have a var, we're gonna call it L, and what we're gonna do is we're gonna take a variable and use the not null operator to try to convert it. So as you can see, it's gonna be middle name. Right now, we definitely know that it's equal to null, and we're going to try to convert it to a not null type. And let's see what happens. And let's run this really quick. Boom, an explosion. All right, so we did the initial stuff. Like the safe call operator still works. We see that it's printing out null. We see that the Elvis operator still works with the fallback of 0. But then when we get to that final conversion of turning a middle name into a non-null type, it's just not possible because of the fact that middle name is currently holding null, right? So it's going to return a null pointer exception. Now, say for instance we were to use, an actual middle name, right? Let's put it back to, let's say Lloyd or something like that, or let's say Chris, right? And let's run it. Well, now in this case, it's no problem because the fact that middle name right now it is not a null value. So right now it actually has a string in there. So it's going to try to convert it to a non-null type, and there is no problem, right? Now it's able to store it within L. L is a string, and essentially we're trying to make a contract with Kotlin when we're using this not null operator. Essentially we're saying, okay, look, we're going to try to convert this, this variable, this value to a non-null type, and if it goes great, then we now have a non-null variable or value. But if it doesn't, well, the contract ends with explosion. We're going to give you a null pointer exception. So this can be used for that. You are taking a chance when using it, so try to make sure that you're not trying to convert a null, because then you will get a null pointer exception. It kind of defeats the whole point of Kotlin having this whole null pointer safety. So make sure of that. But these are some of the things that Kotlin provide for null exceptions or for safety. That includes the safe call operator, the Elvis operator, and the not null operator. So hope you guys found that useful. Leave a comment down below if you have any questions or if you enjoyed it. So let's keep going. All right, so let's start talking enums in Kotlin. So what is an enum? An enum is a user-defined type consisting of a set of named constants called enumerators, right? So enumerators, enum is short for enumerators, makes a lot of sense, right? So the idea of an enum is to have a type with a restricted set of values. And an example of these restricted values or a set of values that we can create ourselves is, we can think of an organizational chart, right? So if you ever work corporate, or even if you ever worked at like a fast food restaurant or any job really, you have roles, right? You can have the employee, you can have the manager, you can have the CEO, the CFO. These are all roles, right? But instead of letting the user define those roles, we can already have a restricted set of values for those roles. So that's what we're going to do in this video. We're going to go over enums by creating an organizational chart that creates a restrictive set of values using an enum class, right? So let's go into this Kotlin folder. Let's right click, press new, and then let's press Kotlin class, scroll down a bit, pick enum class and give it a name. In this case, I'm gonna put org chart, short for organizational chart. And now we're gonna start defining some roles. And as you can see, what makes enum class is simply just putting the keyword enum in front of class, just like we did with data class. We created a data class by putting the keyword data in front of class, and we were good to go. So in the case of enum, we just put enum in front of class, and now we have an enum class called org chart. So each enum constant is an object, right? Enum constants are separated by commas, right? Each constant is an instance of the enum class. So in this case, it is an instance of org chart. So let's start creating some of the roles, and each of these roles are going to be an object in itself, and they're going to be an instance of an org chart. So the first one I'm going to do is employee, because they're the backbone of the company. They're the one that actually do a lot of the work. Then we got the manager who orchestrates it, and then he has to go and talk to the CEO, right? So then we have now 3 objects, 3 constants. Each constant is an object, and they're all comma separated except the last one. You don't need a comma for the last one, but we have employee, manager, and CEO, right? And say for instance we want a little bit more detail, right? Say for instance we want to initialize or give each one of these objects a initial value. Well, we can do that as well. Say for instance we want to specify the minimum salary of each of these roles. Well, we can go in and we can still create a constructor, right? So just like we did before, or if you ever came from Java, enums have constructors, because like I said, an enum constant is an instance of an enum class. So these constants can be initialized by passing a specific value to the constructor. So in this case, I want to pass the minimum salary. So the min salary is going to be a double. And now, because this is an instance of an org chart, we have to directly place the value that we want to give to this object, right? So now I want to say I want to make an employee minimum salary 40,000. So I'm gonna do 40,000.0, and instead of using a comma in Kotlin, you could use an underscore just to signify that there's to be a comma in this place, and it makes it more visually pleasing. So I put an underscore instead of just putting nothing, because this looks crazy. But if I put an underscore, it looks way more cleaner. Then for a manager, I want to make sure that their minimum salary is 90,000, because I want to make sure that they're orchestrating people properly. And if they're not, then I guess they're gonna have to get fired. But if they're doing a good job, then they're gonna get paid really well. And then the CEO is the person that keeps it all intact, keeps the business going, hopefully, and I guess get all the funds and put it back into the business. So we're gonna make sure that the CEO is getting paid well as well. So I'm gonna make the CEO get paid $1 million, or whatever currency that you guys are coming from. So now we have 40,000 for employee, manager is making 90,000, and the minimum salary for the CEO is the big bucks, which is $1 million. So we created an enum class with constants, which each constant in an enum class is an instance of the class, so it's an object, and we wanted to give it a value, right? So we passed the value because we're expecting the minimum salary for each role within the org chart, and because this is an instance, an object, an instance of a class, we have to pass it in when creating the object. So we have to pass in a value because we're expecting a value for this enum class. So now let's see, how can we use this enum object, right? How can we use this employee role? How can we use this manager? How can we use the CEO? Well, it's relatively easy, right? So since we know that it's already an object, right? An enum constant is an object, right? All we got to do is use the name of the enum class, which is in this case an org chart, specify what role that we want. So say for instance we want to get information about the employee, right? Someone's interested in a job at whatever business that this is representing, and then they want to know how much does an employee make minimum at this business, right? Well, we can do org chart, which is the class name, and we already have an instance, right? Employees an object, and to get something within an object, all we got to do is use dot notation again, and we can see that we have different items that this enum provides. So we have name, we have ordinal. Ordinal just gives the position of where the employee is. So in this case, it is the first position, so it's going to be 0, manager is 1, CEO is 2. So that's one thing that we can grab. We can also grab the minimum salary. So let's do that really quick. And honestly, we're unable to see it because I have to make this a property, right? So I got to give it a value, right? I got to give it I got to make it a variable essentially. So I got to make it a val or a var. This will make it a property just by the nature of a primary constructor. And then if I use the dot notation, then I can grab the property. So in this case, I'm grabbing the min salary of the employee, and then I'll just use a couple of copies, and then I'll print out the other position. So let me say employee, use some string templating to print out the rest. And honestly, I probably should have just copied these. This would have made it a little bit quicker. So that, and instead of employee, I'm going to do manager, and in this case I'm gonna put CEO. And I talked about the ordinal, so let me just print out that as well so you guys know what exactly that is. So let me do org chart dot employee, and then I'm gonna do ordinal because essentially that's the position on where this specific object is inside of the enum. So if it's in the first place, it's gonna be 0. If it's second, which manager is in, is 1, and CEO is gonna be 2 because all I gotta do is subtract it by 1 because the starting position is 0. And then this is gonna be employee, this is gonna be manager, and this is gonna be CEO. And then I'm gonna take this to make my life easier, and I'm gonna put manager here, and I'm gonna put CEO here, and let me run that. All right, so boom, as you can see, we see that employee has the position of 0 using the ordinal property from the object, and we have manager that also has 1, and CEO that has 2. And then we can see that each one is grabbing the value of each individual role. So we have 40,000 for employee, 90,000 for manager, and 1 million for CEO. So you can see the usefulness of an enum, right? An enum class, because it creates essentially constants, an instance of an object, right? These constants are an instance of an object that are restrictive, right? We created the roles, we created the values, and now the user can't really change that, right? This is something that we created ourselves, and it creates a structured value set that we can use to our application. Say for instance we don't know all of the rows of an org chart, right? We could iterate through it, or say for instance we want access to all of the rows, we could iterate through them if we wanted to. So we can go back to using a for loop. Say for instance we want to get role in org chart, we can do that, and to get the rest of the rows, all we got to do is use dot values. And essentially what this is going to do is that it's going to go into the org chart and get all of them, all the values within the enum, and now as we iterate, each one will be placed into role, and we can do what we need to do with it. So in this case, let me print out the role dot min salary. And if I wanted to get the value of the row, I can do that as well. Like the name, I can do that as well. So essentially I'm gonna just take this line and I'm gonna bring it right under here, but now I'm gonna use the role variable that I have now, and I won't even need this anymore. So I'm gonna do role dot name, right? So now I got the name of the role, and then I can specify that the salary is and then I can do role dot min salary. Now this is much quicker than what I had before, so I'm just going to erase all of that, and I'm going to run this and see what it outputs. So boom, as you can see, it prints out the name that I expect of the role, prints out the actual salary, and if I even wanted to print out the ordinal value, which is the position, let me just put it above here. I could have did that as well. So ordinal, or using the dot notation, I can get the ordinal value. So yeah, enums are very useful in this case. Another way that I can get a specific role or the value of a role or whatever constant that I specify or that I created for an enum class, all I got to do is use the method value of. So let me do file, and I'm going to put employee, or actually no, CEO role, and I'm going to make that equal to org chart, and I'm going to do dot value of, and then I'm going to do CEO because I want to get all the information regarding the CEO, and I want to place it into this variable called CEO role. So if I ever want to, print out the value of the CEO, I can do that by just taking this variable name and specifying or using dot notation to retrieve the minimum salary. So let me do that. So there we go. We see a 1 million here. That's pretty much this line right here. I'm able to grab a value out of the enum class. So I'm able to grab the object instance from the enum class and place it into here. I'm able to do what I need to with it. So if I need to grab the ordinal position, the minimum salary, or just need to get any more information about it, I can do it here. So that is the cool part about an enum class. You're not restricted to just one parameter. If you need to put anything else, like if you need to put like the rank, and you can just place another value in the primary constructor and start specifying the rank for each one of these. So you're not restricted to just using just one parameter. You can use multiple. All you got to do is specify it within the constructor of the constant. So yeah, man, that's the enum class. If you have any questions, leave it down below. All right, so let's dive into collections. All right, so just as the name implies, a collection is a group or a number of objects of the same type stored into one variable, right? So objects in a collection are usually called elements or items. So I used previously an example of employees or managers or CEOs for an organizational chart, but in this case of a collection, you can think of it as a collection of all the employees in a department in one variable or in one place, right? So it's a collection of objects, right? A collection of items. Now, we kind of talked about an example of a collection in the array portion of the video, but in this case, we're now going to have collections that are mutable and immutable. Meaning immutable is, you're not able to modify after creation, whereas mutable is, you're allowed to change if you want to. You're able to add if you want to, right? So in the case of array, we weren't able to add to array. We could create a new array with additional values, but you couldn't add to an array once it's created. But with some of these collections, you're able to add to the collection. So we'll take a look into that. So the first collection that I want to talk about, and I'm not including the array, but the list is a collection that I want to talk about, and it is a generic ordered collection of elements that can contain duplicate values, right? So let's see how we can create a list. Now we talked about immutable versus mutable, right? Immutable means that you cannot change, where mutable means you can change. So in this case, let me create first a immutable list. And to do that, what you will have to do is first let's specify the name that we want to do, right? So let's do a variable called employees, right? And I'm going to make that equal to, and just like how we did array of with arrays, if we wanted to do or use to create a list, all we got to do is do list of. And now we can start defining some values that we want to put inside of this list. So one employee that I want to put is Bobby. Another one that I want to put is Gio. Another one that I want to put is Ashley. And another one that I want to put is Steph. So now we have a list of employees, but this is an immutable list, right? Meaning that we cannot change this once it's created. So once we go to this next line, we cannot change what's inside of the list, right? So it's only read only. So we can grab from it. So if I want to grab somebody from the employee, it'll be the same approach that we took with an array, right? It'll just be employees. We can take the name of the variable, and we can access the value from the list using .gets, or if you want to access it using an index, you can use brackets and specifying the position within the list. We can do all of that, but we cannot change the value. So I can't just say Bobby is now Bob, right? It's not going to allow me to, right? It's not going to allow me to assign a new value to it because it's just not. It's only read only at this point, right? It's an immutable list. But say for instance, I want to make a mutable list, meaning that I want to be able to add to this list. I want to be able to change a value within this list. Well, I can do that. So I'm going to do val mutable list, and I'm going to make this a mutable list of, as you can see. And just like with an array, I can specify the type if I wanted to. So if I know that I'm only going to want to store strings in here, I can do that. And I can specify that right here, or you can just let Kotlin infer it by just leaving it out and starting to put it in. And I'm literally just going to put the same people in there, right? Same employees. Maybe you have, or actually let me just put electronic employees for the name. So that's everybody within the electronic department, right? And say for instance, we got a new hire, right? Before we could add to this list, right? Unfortunately, it was immutable, meaning we couldn't add, we couldn't change. So if somebody needed to change their name, we couldn't do it. But with this mutable list of, we can just go in, take a reference of this list, which is electronic employees, and now we got a new hire named Jimmy, and we could do .add, and now we can just specify the person's name. And when we do add, it's just going to add the person to the end of the list. Or if we want to specify an index, well, we can specify where within the list we want to add. So say for instance, we want Jimmy to be in the front because he's a new hire. Put him in the beginning of the line just to be nice. You can specify that the index is going to be 0, put a comma, then the actual name. If you don't care about the position and you just want the person to just be added at the end, or the item to be added at the end, well, you could just put the item itself, whether it's a string, whether it's a number, just put the value within, and then use the .add method, and it should add that item to the end of the list. Now, just like with an array, if we want to see what's within this list, we could use a for loop. We did that before. We learned about for loops, and to do that, you just use the keyword for, open up parentheses, specify the name of the temporary variable that we want to use to hold each individual item within this collection, and specify where we want to actually grab this information from. So we want to grab employee from within using the keyword in electronic employees. And then now we can open up some curly braces and then start specifying what we want to do with this employee. So we can do print ln, and then we can just open up, so we can do name and then specify the employee, right? So this should be good to go. And employee electronics have a lot of methods that you can use, just like an array did, right? So employee, if I use employee or electronic employees and I use the dot notation, you can start seeing so many things that this collection automatically comes with just by being a list, right? Some of these are not available within the immutable ones, right? Because there's certain things that you cannot change, right? You get the index of a certain place, you can get the last, right, item of the list, but you can't add, right, like you did with a mutable list like we just did. But you can go in and check out what you need. So if you need to replace all, if you need to add all, if you need to remove, these are all available within this collection item, right? So you can check if it contains a specific element, get the last item like you just saw with the immutable one. So there's a lot of methods that you can use with a list, right? Or with a collection period, as we start to go over these collections one by one. So let's actually print out this and see what exactly is in this electronic employees. But I just want to specify that this collection comes with a lot of predefined methods that you can use and play around with. So cool. As we see Bobby, and then at the end we saw Jimmy, because we added Jimmy to the end. We didn't specify what index we wanted to, but remember, if we want to add Jimmy to a specific index, all we got to do is put the index value, use a comma, separate it, and then it will let during the add, right, it will let Kotlin know that, okay, we want to add this item at this specific index, and it will do that. It will just shift it, add that item. So now Jimmy, if, say for instance I wanted Jimmy at the third index, 0, 1, 2, and 3, right? Steph will be last and Jimmy will be before Steph. And we can honestly just test this now to see. So let's run this. So boom, as we can see, Jimmy is before Steph as expected and right after Ashley. So good to go. And you're not restricted to just using, this approach for a for loop. We could use what we learned with, range, right? So we can do I in 0 until the size of electronic employee, because you want to make sure that it stops eventually, right? So we can get the size, and like I said, a list comes with a lot of predefined methods. So essentially what this is saying is going from 0 to the size of employees. It's not going to include the last place, because the nature of collections is that it starts at 0, but then it ends at the size of the item minus 1. So since we're saying until this size, we're essentially saying that we're not including the last number, right? We're only going from 0 up to the size minus 1, because we're not including the size itself. So in this case, right, the mutable list is of size 5 because we added Jimmy. So what this is saying is going from 0 until 4, because we're not including 5, because when we use until, we're not including the last value. So in this case, 5 is the last value. We're not including 5. We're only going up until 5. So hopefully that makes sense. But if it doesn't, you can go back to my range portion of the video. But now to retrieve a value, all we got to do is do electronic employees, open up the brackets, and put I, and I got to use the curly braces here to make sure, because it's a little bit more extended. So essentially what this is saying is I'm going to go into electronic employees and reference the index, right? And I is currently holding each individual index as it starts to iterate through it one by one. And I still have things that I can use within this specific item. So if I want to do dot length, I could, because remember this is a string, so there are predefined methods for that as well. So there's a lot of things you can do with this. And just like I explained, if you want to retrieve by an index, you could do electronic employees like I just did and use an index, or you can use the reference of the list and use .get and specify the index. Or the cool thing about a collection is that you can do electronic employees, and if you want the first value, you can literally use a method called first. Or if you want to get the last value, then you can do electronic employees dot last, right? Or say for instance you want to get a specific range of items from your list, right? You can specify a sublist. So you could do, let's put this in a variable and print that out, but let's do sublist, and let's make that equal to electronic employees dot sublist, and let's pick from the first item, and I want to just get the first, I guess, from 0 to 2. So I can do 0 up into 2, and then let me just comment this out, and let me print out the sublist, and let me print out this, or comment out this for loop, and let me run it. Boom. So now we got from the index 0 up until 2, but it doesn't include index 2, right? It's up until 2. So if you want to include Ashley in this case, then you would specify it'll be 3, because it'll go 0, 1, 2, and then it'll stop at 3. It goes up until the last number. And I already did, dot add if you want to add a specific number, or not number, but specific item or element, add a specific index or number. You can do that, or you can do add all, right? So you can have electronic employees. Imagine there's multiple new hires, so you can do add all, and then you can specify that you want to add multiple. So to do that, you just create another list using a list of, and then specifying the name. So maybe you have a Tim and you have a Jordan that's coming in, right? Then you don't want to have to add that individually, so we can add all of them all at one time. And say for instance you want to specify an index, you can do that as well too. So say for instance you want to add these two individuals starting at index 2, you can specify that by putting 2, right, as the index, and then using a comma and separate it just like we did with Jimmy, right? But in this case it's using a list instead of just one individual element. So you can see the power of this. There's so many things that you could do with a list. And this is mutable, meaning that we could change it. We can add, and that means we can also remove. So we can do electronic employees, we can do dots, and then we can do remove. We can do remove, but we can specify the actual element that we're trying to remove. So say for instance Jimmy did something bad, we can say remove Jimmy, right? Or say for instance you want to remove somebody based on their position, right? You can do remove at, remove at, and specify the position that you want to remove. So we can also say, okay, maybe we want to remove Steph. Well, we removed Jimmy, so that means Steph should be last. So we'll just say electronic employees dot size -1. That should automatically get us the last individual index. So yeah, cool. So actually let me just print out electronic here, and electronic employees, comment out sublist, and then run it. All right, boom. So now we have Bobby, Gio, Tim, Jordan, and Ashley. We saw that unfortunately Jimmy and Steph didn't make it, but we still were able to add Tim and Jordan at index 2, and it just pushed Ashley over, so we're good to go. All right, so we went over a list, but now let's talk about another collection, which is a set, right? So a set is a generic unordered collection of elements, and it does not contain duplicate elements. So if you want to have a collection that by default does not contain duplicate elements, then a set is the collection that you should use. And just like with a list, or just like with any other collection, it supports mutable and immutable sets, meaning a immutable set means that it supports only read-only functionality, meaning that we can't change anything, we can only get. And a mutable set of is meaning that it supports read and write, so we can get things and we can change things. So let's see how we can create a set. So to do that, let's create a variable, and we're going to call this original set, right? And I'm just going to make this immutable by just specifying that it's going to be sets of, right? And now we can start specifying some things that we want to put inside of this set. So let's put Bob, and Joe, right? And due to the nature of a set, right, we said that it does not contain any duplicates. So I want to see what's within the sets when we try to get information out of it. So let's use a for loop, and just like with a list or just like with any other collection, we can use a for loop on this, and we're going to do name in original set. We're going to open up the curly braces, and we're just going to print out the name, and let's run this. So boom, as you can see, it's Bob and Joe, but we placed two strings that have the same value inside of the set, but due to the nature of a set, you're not allowed to have duplicates. It would just simply remove it, because that's just the nature of a set. So if you want to contain items that are not duplicates, then you use a sets, because if you do try to put a duplicate in there, then it will remove it. But you still have the same functionality as you did with a list, right? You can still print it out, and there's still some predefined methods that we can use for a set. So if we wanted to get the size of it, but you also got to remember that because of the nature of a set as well, it is unordered. So you can't just get at an index because it doesn't really know what it's trying to get, right? It's unordered. So Bob can sometimes be at the index of 0, but at the same time, it can also be at the index of 1, right? It doesn't necessarily mean it's going to be at the same spot every single time. So you also have to be wary of that. But there are still some predefined methods. There's size, if you want to use some hash code, or if you want to check if it's empty, you can still have those methods, but there's certain things that you can't do because of just the nature of a set. And also when creating a set, you can also specify the type. So if you know you want to only store strings, you can specify that using the little, I think it's called, I believe these signs are called chevron, but some people say less than, greater than signs. I'm gonna say chevron. Just put the type within here, so it's not string, it's string. And now this is saying within this set, I only want strings. Or if you want to use an int, if you want to use an int, then you can specify that as well. But in this case, it's gonna cause some problems. But yeah, you can do that. Now, if you want to create a set that is mutable, meaning that you can change, you can add, then we'll just do a mutable set, because I'm feeling lazy with the names these days, and I'm gonna just make a mutable set using the mutable set function, and you can specify the type like I did above. That's perfectly fine. And in this case, I'm gonna put Sid and Sid, Joe, and because it's a mutable set now, I can do mutable sets, and I can do add, or I can do mutable sets dot add all, and I can do list, or my bad, or I could do sets of, and I could do what I want to add. So it could be Jim, it can be boss. This is valid, and then I could put Timmy here. And then if I go here and grab this for loop, I'm going to comment this one out, and I use the mutable set, print out the name, and I run this, we shall see. We can see all the names that we expect. I didn't put any duplicates, so I don't have to worry about it ejecting the duplicates. But if I run it again, I wonder if it's going to be in the same order. Jim, boss. Alright, so in this case, I'm getting lucky. They are in the same order when printing, but the nature of a set is that it is unordered and does not contain any duplicates. And in this case, we saw a mutable set. Now, because of the fact that it is mutable set, I am able to change things, right? I'm able to go in and remove if I want to, but I can't remove at a specific index because, like I just said, it's unordered. But if I know the name of the elements, then I could go in and use dot remove and use a string or whatever value that I put inside of the set. I can specify the element that I'm trying to remove, and it should go in and remove it. So as you can see, Timmy is not there anymore because I removed Timmy. So that is a mutable set. That's how you create one, and that is how you create a regular set or immutable set by using the set of function and the mutable set of function if you want to create a mutable set. On to the next collection. Alright, so the last collection that I'll be going over is the map, and honestly I feel like this is the most useful one. I use this very often. A map is a collection of a pair of objects, or key value pair, and it supports efficient retrieval of a value corresponding to the key, right? And the key have to be unique, right? You can't have that'd be kind of useless if you have a key that's a duplicate, right? So the keys have to be unique, and the map holds one value for each key. So let's see that in action. So let's create a map, right? Remember, it's a key value pair, right? There has to be a key to every value, and every value has a key. So let's do a basketball map, right? I'm a huge basketball fan. Sorry if you're not, but just know that a basketball map will essentially have a key of the person's number to the value of the person's name. So let's do that really quick. So val basketball map and equals to a map of. And if you notice with every collection, it's like that, right? We have map of, we have list of, we have array of, we have set of. It makes it very easy to remember. But remember, just like with all the other collections, there is a mutable map, meaning that we can change values, and we can get and set a value within the collection. Or there's the immutable collection, meaning that you can only get, right, you can only read values from that specific collection. You cannot change. So in this case, I'm creating a immutable map, meaning that whatever I created as originally is what it has to stay as. So let's do that mutable map. Then I'm going to specify a key. In this case, it's going to be 23. And usually when someone specifies a key or a number of 23 in basketball, that associates to only one player, and that's Jordan. So to create a key, we specify the key first, and to specify the value to that key, we use the keyword of 2, and then we specify the value that we want to give to this key of 23, or whatever you choose to put here. It can be another string too. It can be a string of player or whatever. It can be a string, but in this case, I want to use a number as the key, so I put 23, or it could be 23.5, right? It could do that, but I'm just gonna put 23 to the player, and I want that player, or I want the value to be a string, and the player that's associated to 23 is Jordan. Or I could put the full name of Michael Jordan, but that's too long, so I'm gonna put Jordan. So cool. So 23 is the key, and the value to 23 is Jordan, right? So key value pair, that is a map, right? Now another player that I want to put is 34, and that's going to be the key to the value of Shaq, right? Shaq is a very tall dude, very good at basketball. Then the last one I want to put is 3. That's the key. I want to associate that key to a player called Dwayne Wade, or Wade for short, or you can even call him Flash, whatever works for you, or sometimes even call it D Wade. So I'm gonna put D Wade. And that is how you create a immutable map, meaning this is just how it's gonna stay, right? We can't change it. We can't just do let's do basketball map, right? We can't do basketball map, and we can't do dots sets or whatever. Like, we can get the entries, meaning we can get each pair, right? And we're gonna use that really quick. We're gonna use a for loop on it. We can get a individual item using the key. So say for instance we want to get 23. What this will return is it will return the value that's stored using this key of 23, which we know is Jordan. But we can't set, like we can't change a value because this is a immutable map. So let's use a for loop really quick so we can see what's inside of our map, right? We can see it here, but let's actually see how we can iterate through a map if need be. Say for instance this is way bigger. Let's see how we can iterate through the entries. So we can iterate through a map in Kotlin by just specifying that for whatever we're trying to extract from the map. So in this case, I'm trying to extract a key and a value, right? And remember, this doesn't have to be, key and value. It could be K and V if you wanted to. This is just variables that's used as placeholders so that when we iterate through each item, it's going to be stored within these variables. So you can name it whatever you want, but I try to make it as obvious as possible. So I'm going to use key and value. And what it's going to do is for each key value in basketball map. So that's how you iterate through it, right? We're essentially saying for each item, we're going to extract the key and value that's in basketball map. And we got to use parentheses to specify that we're going to get 2 items, right? Before, we're so used to saying that, we want to get 1 item, right? But in this case, I want to get the key and I want to get the value. And then we just open this up, and now we can print out what we need to print out. So I'm just going to say the key is key, and comma, the value is value. And let's print that out really quick. And boom, as you can see, for the key of 23, we see the value of Jordan as we specified, 34 for Shaq, and 3 for D Wade. Now say for instance you don't need the values, right? You just want the keys. Like, what's the keys in this map? Well, you can do that as well. You can simply just say for key in map, or in this case it's going to be basketball map dot keys. This is going to retrieve essentially all the keys within the map, and now we have a variable or placeholder variable that's going to store each individual key as it iterates through it one by one. So we can also print that. You know, I like printing things just to make sure that you know that I'm not lying. And then what we can do is just put the key, and I'm gonna comment this out and run it. So boom, as you can see, the key is 23, 34, and 3 because that's the keys that we have in here. And I'm just gonna copy this and paste it right under because I don't feel like writing that again. But if we wanted the value, right, we can do basketball map values, and it will grab each value. It's gonna say forget the keys, let's just get the values, and we can do that. And remember, it doesn't have to be value. It could be V, it could be pork, it could be whatever you want it to be. But I would try to make it as, you know, resemble as close to what you're actually trying to do whatever variable that you choose, right? Whether it's for a map or whether it's you're creating a separate variable, try to make the name make sense. So let's run that. And honestly, you can say that this doesn't make sense because I didn't change that to value, run it, and as you can see, we get the value of Jordan, Shaq, Dwayne, Wade. Or another way that you can retrieve it is if you know the key that you're trying to retrieve, all you got to do is do basketball map or whatever map that you created, and then put the key in here. Once you specify the key, right, you're going to get the value. So let me just put a print right here, right here. Because we're so used to saying that with an array, you pass the index, but since this is a key value pair, Kotlin is smart enough to see that, okay, we have a key value pair. So what is the key? I'll return the value. So in this case, we pass in 23 because we know that 23 is in this map, and it's going to return a value based on that. And there's a lot more ways to get a value, right? We saw it, like you can do basketball map.get, and we can specify the key, just like what we did with this brackets right here. That's great. We saw that plenty of times. But I would say a cool thing about it is that we can do get or get or default. Meaning we're going to try to get a value, and let's choose a random value, right? Let's choose 24. There is no 24 in here. If I did have to put a 24 in here, it would be Kobe, rest in peace. But I could put a key, right, and I can have a default value. If this key is not within this map, then it's gonna fall back to the default value, and I can print that out so you can see, because I don't have a 24 right now in this map. So if I run this, I should get the default value. So boom, as you can see, there is no 24. I should probably add a 24. That's a very important number, but you can see that it's a default value of 0. So that's how we can, you know, mess around with the map, and this is immutable. So let's talk about mutable maps. So let me take all of this out. Now let's start talking about mutable maps. So let me do file, and let me do soccer. Actually, I'm sorry, I probably just offended a whole bunch of people. Football map, and I'm gonna make this a mutable map of. And I can specify the types, right? I didn't do that for map of, but I know it's probably gonna be weird because it's a key value, right? So then we got to specify the type of the key and the value, you are correct. So if you know you want to make an int for the key, you put that first, and if you know you want to put a string for the value, you put that second. You separate it by a comma, right? But say for instance you want int for both, you can do that too. Like there's no restriction. It just has to be a valid data type. So just specify that here. If you want to restrict it, you just being int for the key and string for the value. And now we can start writing the key value pairs. The two greatest soccer players for my generation is obviously going to be Ronaldo and Messi. So what I'm going to do is I'm going to put 7 because that's going to be associated to Ronaldo. And I'm going to put 10. I'm going to use his Argentina number. So 10 for Messi. So we know, whoops, I'm going to make that a string. So we know that 7 is going to be the key to Ronaldo and 10 is going to be the key to Messi. It works perfectly fine. All right, so now we have this football map, and let's start taking advantage of the fact that this is a mutable map. So because this is a mutable map, we could start adding or putting values into this football map like we did with the other mutable collections. So let's take the instance of football map and let's use .put to start putting new values or new key pairs into this mutable map of football map. Now I am interested in putting Neymar in, but that may cause an issue, right? Because Neymar has the same number as Ronaldo, and I think Ronaldo's better than Neymar, unfortunately. So if I try to put 7 into this football map, what it will try to do is essentially replace Ronaldo with this new value. I don't want to do that, so I'm not going to put Neymar in, but I am going to put Ronaldo in, right? And I'm talking about the Brazilian Ronaldo, and he's number 9, and I don't have a number 9 in here, so I am good to go. The values can be the same, but the keys can't be the same, right? Because if the keys are the same, then it's essentially going to try to replace whatever other previous value is, because there can't be any duplicates, because a key has to be unique. It is a form of identifier, right? Imagine if everybody had access to your door because everybody had the same key. That would be an issue, right? So in this case, I'm just going to add a new legend in here called Ronaldo, but it's not the Cristiano Ronaldo. It's Ronaldo from Brazil. And I'm actually going to put that, right? Brazil. And we should be good to go. And we can iterate this, right? We can put for key value in football map. We can print out the key and the value, and let's run it. So boom, we have 7 Ronaldo, we have 10 Messi, and then we have number 9 for Ronaldo, but the Ronaldo from Brazil. So there's so many things you can do with a map, and there's so many useful functions that you can use with it. There is football map, or whatever you named your map as. You can do .puts, you can get or default, you can do contains. You can check if it contains a specific key or if it contains a specific value. You can do .size if you need to know the size of it. You can get the keys, like I said. You can get the entries, meaning the key and the value pair, and then you can use the iterator for that. So there's so many things that you can do with a map. This video is gonna be way too long if I try to do that. And then there are other functions that you can use using lambda expressions. Where I'll do in another video. That's gonna be a little bit confusing, but you can also check if it's empty. There's so many things that you can do with it. I would advise going through these methods and seeing what can be useful for you. Like if you want to clear the whole map, you could. If you want to remove it using a key, which you could. So say for instance, I want to remove number 7, and I want to add, for some reason, I want to add Neymar, right? Let me just do that, add. I can do that. So let me run that. So there's so many things that you can do with a map. I would just say play with it. It's probably, put. Honest mistake. And let me cancel that. It's probably gonna break. Let's run it again. So I would say play around with it. It is one of the most useful collections, if not the most useful collection, because of the fact that a lot of interviews use maps, and it just stores information so efficiently. But as you can see, Neymar's in there. Unfortunately, Cristiano Ronaldo got the boot, I wouldn't do that in real life, but just to show the example, right? We were able to put that. Or if we didn't remove 7, right? We can run that again. And you can see that Neymar replaces Ronaldo. He even kept it the same place in the map itself, right? It just changed the name of Ronaldo to Neymar. So that is the nature of a map. That is a immutable map and a mutable map. If you have any questions, leave it down below. That is all of the collections. Hopefully you found that useful. So hopefully you found that enjoyable as I did. It was great revising Kotlin and teaching people Kotlin. It is a very great language. There is more Kotlin material coming. I just wanted to keep this one not only for beginners, but for refreshing on some Kotlin topics and how to do things. But I do want to start going into lambda expressions, higher order functions, stuff like that, but in a separate series. So stay tuned for that. Subscribe, click the bell icon. And there's also a database design series coming, as well as a Postgres SQL series coming. So just stay tuned, stay locked in, because I'm going to be locked in. There's a lot more material coming in because I'm trying to help you guys improve. And while you guys are improving, I'm also improving as well. So hope you enjoy that. Let's keep going.